Hello everybody, hello, good evening, very good evening all of you. Hello unnaru andariki, am I audible, am I visible? Please tell me once. Cheppandi. Hi. Oh, thank you so much Vaishu, thank you so much. Am I audible, am I visible? Is everything clear? Okasari cheppandi. Yeah, because we have to do a long journey in this class, so we will be dealing with the chapter. Good evening Maitri, very good evening. Good evening Parimala, very good evening. Yes, good, very good. So total chapter, your rotational dynamics, mottam chapter we will be trying to cover in this class. Okay, it's a one shot. Okay, Dr. Anvesh, this should be the confidence, right? You start using doctor in your names. That is a different thing, sir, if we get selected in NEET or not. Kani, make a habit of using doctor in your name from now onwards. Endukante you need inspiration. Inspiration kosam you need determination. Determination kosam you need assumption. So what is the assumption, sir? Assumption is you have become a doctor. Okay, this assumption nunchi you will get a determination. Determination nunchi you will be getting your inspiration. And then everything becomes possible. Yes. Rabbit, very good evening. Okay. Perfect. Alright. So instructions enti, sir. The first instruction is make sure that you are not spamming in the chat, because I am not in the mood to entertain the spam messages. Very good, sure. So if at all you have some doubts, feel free to ask. Kani spam cheyakandi. Sure. Good. So let us start this beautiful session andariki. The name of the chapter is Rotational Dynamics. It seems a little difficult for the students. Kani we will be learning it as it should be learnt. Rotational dynamics kuda antaru. Rotational motion leda rotational dynamics. You can call it whatever you want. Okay? Rotational dynamics. But all of you andariki. Hi. Good. Perfect. Okay. Done. Okay. Rotational dynamics. Sir, what are the prerequisites? This chapter ki prerequisites ante meeku gurtunda, we have completed circular motion ra. Circular motion lo we talked about some terminologies. What terminologies, sir? The first terminology I told you, this was something known as angular displacement ra. Gurtunda? Angular displacement theta. Sir, what is the relationship between theta and us, sir? Angular displacement. Dan tarvata, hey, I am talking about the prerequisites required for this chapter, okay? It is not the entire chapter. Ippudu we did not start the chapter. These are just the mere prerequisites that are required, okay? These are the prerequisites. Hi Vaishu, hi. Angular displacement, dan tarvata angular speed లేదా angular velocity. You can call it whatever you want. Next, it is angular acceleration. Okay, what are this, sir? Angular displacement and entira. There is a difference between your linear motion and your rotational motion. Ade kada? Yes. What is the difference, sir? Sir, in linear motion, the things just move in a straight line. Kani rotational motion lo, these things move in a circle. Ade kada? Yes. So, this entire chapter lo, I want you to focus on a single thing. What is the single thing, sir? There is something known as axis of rotation. Andariki. జాగ్రత్తగా వినండి. యాక్సిస్ ఆఫ్ రొటేషన్ అంటే ఏంటిరా? యాక్సిస్ ఆఫ్ రొటేషన్ ఎప్పుడైనా మీకు ఒక రొటేషనల్ మోషన్ ఇస్తే యూ మస్ట్ బీ హ్యావింగ్ ద ఐడియా అబౌట్ ద యాక్సిస్ ఆఫ్ రొటేషన్. నౌ ఆన్వర్డ్స్ ఇప్పటి నుంచి యూ డూ వన్ థింగ్. ఓకే, అందరికి I'm telling you a fun activity. You have to do this activity till your NEET examination, till the month of May. Whenever you see a circular motion, your fan is rotating. When you see a car, the tires are rotating. Bike lo kuda tires are rotating. Bus lo kuda tires are rotating. Ade kada. You try to identify the axis of rotation. Ade. That is the most important thing in the rotational chapter. If you are not aware of axis of rotation, you will not understand anything about it. Ante kada? Yes. Hey, tell me something, ra. Okay. So, let us talk about these terminologies, ra. Okay, one by one. Let us talk about angular displacement. Chuskondi. Theta kuda antaru. Okay, so this is represented by the letter theta. Angular displacement ante enti sir? Initially, let us understand. Okay, let us understand each and every terminology using your hand only, ra. Chusko. So this was the hand ante rod. You can imagine whatever you want. Okay, it started moving in a circle. Initially it is in a vertical position. Koncham samayam tarvata it has rotated to this point. Ade kada? Yes. So initially the rod was in a vertical position. This is your hinge point. Chuskondi. In 99% of the questions, your hinge point is your axis of rotation. What did I say? In 99% of the question, your hinge point is your axis of rotation. Understanding? Yes. Your hinge point is your axis of rotation. Hey, do you remember? What did I say, sir? Every circular motion has the axis of rotation. And you have to remember it. Hey, sir, axis of rotation ante hinge point ra. Ade. Are you understanding? Okay. So this was the rod. It had started moving ra. Ante ide hinge point kada? Yes. And this itself is the axis of rotation. Understanding? Yes. Koncham samayam tarvata, the rod has come to this position. Ante tell me the angle that it has covered, ra. Tell me the angle that the rod has covered. Oh my goodness, I got a very good thing, ra. Okay, I hope so. Perfect. Okay, so this is the rod. Chuskondi, ra. It's too long, okay? Chuskondi. It's moving, kada? Yes. Where is the hinge point and where is the axis of rotation? Andariki. Where is the axis of rotation and where is the hinge point? Sir, this is the hinge point. And this only is the axis of rotation. Ade kada? Yes. So the rod is moving something like this. Chuskondira. Complete rotation motion kada? Yes. So this is your axis of rotation. This itself is your hinge point. Ade kada? Yes. You understand me? Yes. 99.999999%. That extra 0.00001% in which the hinge point is not the axis of rotation. It's not required for you and me. Okay? It's not required for NEET. Can you understand? Okay. Right. So after some time, this angle theta has been covered. So this angle theta is known as your angular displacement. Choose kondi andariki. It was a circular motion. So I am joining this length. This is the length of arc of circle L. Choose ko. Radius enta sir? Radius is R. Idi kuda radius R. Ide kada? Yes. Angular displacement theta and length L. What is the relation, sir? Multiply. Ade. L is equals to R into theta. L ante enti? L is the length of the arc of the circle. Okay, this is a very basic formula. You must remember all these formulas. Okay, good. Theta values now they will be given to you in degrees. Later it will be given to you in radians. You must be able to convert one form to another. Ide kada? Yes. So if I say theta is equals to 60 degrees ra, convert into radians. Ela convert cheyali sir? Chusko. Theta degree to let us take a new slide only. Okay, chusko. Degree to radian conversion. ఇది చాలా ఇంపార్టెంట్ అందరికి. ఓకే, see once these chapters have been completed, ఒకసారి మొత్తం చాప్టర్స్ కంప్లీట్ అయిన తర్వాత I will be taking your PYQs. ఆ సెషన్స్ లో we will only be focusing on the previous year NEET problems that have been asked from your 2025 నుంచి at least 15 to 20 years అంటే 2005 అదే. So we will be covering the PYQs from 2005 to 2025, at least 20 years. ఇదే కదా? Yes. Yes. Harsha, very good. Yes. So when you are going for that sessions, చూసుకోండి అందరికి what I am telling to you. When you are going for a war without your weapons, the person is the most foolish person ever. Understanding? చూసుకో. At least make sure that when you are attempting your paper, when you are entering into the exam hall ra, ఇది చాలా ఇంపార్టెంట్. You take my advice very sincerely, all of you. I am telling you based on whatever experience I have. Before stepping your leg into your exam hall, you must be having all the list of your formula in your mind. Okay? You cannot take it in the examination hall ra. You can only enter the examination hall if you by heart all the formulas. Sir, formulas gurtundali. If you don't remember the formulas, you need not go to the exam hall ante. Telusa? That means you should skip your examination. Malli cheptunnanu. There is some importance thing in the formulas. If you don't remember them, you cannot put your leg into the examination hall. Make it very clear, 100%. Andariki. Yes, very good. Okay, Varalakshmi, very good. Chusko. Degree to radian conversion. For example, if I have 60 degrees, you simply multiply it with a terminology pi by 180 ra. Chusko. Ade. Understanding? Sir, 61s are 60, 63s are 180, and 60 degrees is equals to pi by 3 radians. You try to understand, okay, x degree multiplied by pi by 180 is your radian terminology. చూసుకోండిరా. ఓకే, ఇది చాలా ఇంపార్టెంట్. ఐఎమ్ టెలింగ్ యూ అగైన్ అండ్ అగైన్. నెక్స్ట్ సార్, నెక్స్ట్ రేడియన్ టు డిగ్రీ కన్వర్జన్. అదే రేడియన్ టు డిగ్రీ కన్వర్జన్ ఎలా కన్వర్ట్ చేయాలి సార్? యూ మల్టిప్లై ఇట్ విత్ ద రివర్స్. రివర్స్ అంటే ఏంటిరా? ఇఫ్ యూ హ్యావ్ పై బై 2 రేడియన్, okay, pi by 2 radians, what do you do, sir? You multiply this number pi by 2 into this extra quantity, చూసుకోండి, 180 divided by pi. ఇదే. So this is the multiplying factor ra. Multiplying factors గుర్తుపెట్టుకోండి. Okay, very good. Pi by 180, not 3. Yes. So it comes out to be pi by 2 అంటే 90 degrees. ఇదే కదా? If you are remembering the direct values, pi by 4 is 45, pi by 6 is 30 degrees, pi by 3 is 60 degrees, pi by 2 90 degrees, 3 pi by 2 it is 270 degrees, 2 pi by 3 it is 120 degrees. You must be knowing all these formulas. Not formulas, I should rather say values directly ra. Okay, dan tarvata let us immediately move towards your next terminology ra. Enti sir idi? This is known as angular speed leda angular velocity. సింబల్ ఏంటిరా? సింబల్ ఈజ్ యువర్ ఒమేగా. చూసుకోండి, ఒమేగా అంటే ఏంటి సార్? ఒమేగా ఈజ్ ద యాంగులర్ స్పీడ్. యాంగులర్ స్పీడ్ అంటే ఏంటి సార్? యూ ట్రై టు అండర్స్టాండ్. ఓకే, యూ ట్రై టు అండర్స్టాండ్ ఇఫ్ యూ అండర్స్టాండ్ ఆర్ నాట్, బట్ ఐఎమ్ మార్కింగ్ సమ్ పాయింట్స్ రా. చూసుకో. ఓకే, దిస్ ఈజ్ యువర్ ఫ్రేమ్. ఎవ్రీథింగ్ ఈజ్ విజిబుల్ కదా? ఎస్. సో దిస్ ఈజ్ యువర్ ఫస్ట్ పాయింట్. చూసుకో. కెన్ యూ సీ ఇట్ రా? కెన్ యూ సీ ఇట్ ఆల్ ఆఫ్ యూ? ఆర్ షుడ్ ఐ చేంజ్ ద ఇంక్ రా? ఐ కాంట్ చేంజ్ ద ఇంక్. ఐ డోంట్ హ్యావ్ ఎనీ అదర్ pen. ఓకే, I don't have any other pen. Gone mad. చూసుకోండి అందరికి. Hey, all of you. Okay, this is my first set of points. దాని తర్వాత this is my second set of points. Okay, and then this is my third set of points. చూసుకో. When I am rotating this rod, Sir, each and every point is moving in a different circle. Different circle ante enti ra? You just trace their paths, okay? You just trace their paths. Hinge ekkada untindi sir? Here is the hinge, ide kada, ante axis of rotation kuda ide. So this is your axis of rotation. You are rotating this rod, sir. చూసుకోండి, ఎవ్రీ పార్టికల్ అంటే 1 2 3 ఈ 3 పార్టికల్స్ కూడా దే ఆర్ మూవింగ్ ఇన్ డిఫరెంట్ సర్కిల్స్, ఇదే కదా? ఎస్. సో యూ ట్రై టు ట్రేస్ దేర్ పాత్స్ రా. వెన్ యూ ట్రై టు ట్రేస్ దేర్ పాత్స్, దే ఆర్ యాక్చువల్లీ మూవింగ్ ఇన్ డిఫరెంట్ సర్కిల్స్ రా. హౌ షుడ్ ఐ టెల్ యూ నో? ఓకే, సో లెట్ us ట్రాక్ ఫర్ ద ఫస్ట్ పార్టికల్. దిస్ ఈస్ ద అండర్స్టాండ్? ఓకే, దిస్ ఈస్ ద ఫస్ట్ పార్టికల్. ఎక్కడ వచ్చి ఐఎమ్ నౌ ట్రేసింగ్ ద సెకండ్ పాత్. చూసుకోండి, దిస్ ఈస్ ద సెకండ్ పాత్. నా థర్డ్ పాత్ రా. దిస్ ఈస్ ద థర్డ్ పాత్, ఇదే కదా? అంటే ఆల్ త్రీ ఆఫ్ దెమ్ దే ఆర్ మూవింగ్ ఇన్ డిఫరెంట్ సర్కిల్స్. చూసుకోండి, అదే కదా? ఎస్. సో దాట్ మీన్స్ ఫర్ ఈచ్ అండ్ ఎవ్రీ పార్టికల్ ద లెంత్ కవర్డ్ ఇస్ డిఫరెంట్ రా. చూసుకోండి, ఇదే లెంత్ L1 అంటారు. లెట్ us కాల్ దిస్ లెంత్ యాజ్ L2 and let us call this as L3. చూసుకోండి, point number 1 that is clear, sir. What is clear, sir? L1 is much greater than L2 is greater than L3. ఎందుకంటే sir, why sir? Why? Because your hinge point is here. చూసుకోండి, ఇదే మీ hinge point అంటే this is your axis of rotation, అంతే కదా? ఎక్కడ నుంచి క్యాల్కులేట్ చేసుకోండి రా, డిస్టెన్సెస్. సో this distance is R1, sir. This distance is R2, sir. And this distance is R3, ఇదే కదా? Your R3 is greater than R2 is greater than R1. కాబట్టి your length of that third particle అంటే ఇదిరా. ఓకే, this is the length of third particle. లేదా you can call it something like this రా. I don't want to change the terminology. L1 greater than L2 greater than L3, ఇదే కదా? Yes. So point number 1. Okay. Point number 1, sir. Every particle moves in a different circle. అంటే the linear speed of each and every particle is different, అదే కదా? టైమ్ is same, distances are different రా. టైమ్ is same కానీ distances are different. అంటే linear speed of each and every particle is different. Linear speed v are different for different particles, ఇదే కదా? కానీ you compare the same 3 points రా. This is your first, second, third point, ఇదే కదా? Initially there were at this instance, కొంచెం సమయం తర్వాత all of them they have moved by this angle. చూసుకో, this point also moved same angle, ఇదే కూడా it has moved the same angle, this also it has moved the same angle. అంటే their angular speeds are same. Okay, their angular speeds are same. చూసుకో, angular speeds omega for every particle is same. Okay, angular speed omega is same for every particle. Sir, what is the relationship between linear speed and angular speed ra? Sir, v is equals to r into omega. ఇది చాలా important result ra. Okay, very important. What is r, sir? R is not the radius. చూసుకోండి, r is distance of point from the axis of rotation, ఇదే కదా? Yes. Axis of rotation. ఇప్పుడు I'm going to give you a question. Let us see how many of you can solve it. Okay, ఒక క్వశ్చన్ తీసుకోండి అందరికి. Find linear speeds of points A, B and C given the rod covers an angle of 60 degrees in 3 seconds. లేదా you can call it in 2 seconds. So this is my rod, okay, అందరికి. This is my rod. This is the hinge point. అందరికి చూసుకోండి. This is your hinge point అంటే the 3 points. ఇదే నా point A. This is my point B. And ఎక్కడ వచ్చి this is my point C. Length తీసుకోండిరా. Okay, Sir, this length L is equals to 2 meters. Here the length L is equals to 5 meters, and here the length L is equals to 8 meters. I want the number answer, numerical answers kavalira naku. Let us see how many of you can answer it. Okay. This is a very good question actually. Getting it? So the first formula that is required is your omega is equals to theta by t. Ide kada. Omega is your angular displacement, whatever angle has been covered in 1 second in unit time. Ide kada? Yes. So modatiga omega calculate cheskondi, dan tarvata you calculate the linear speeds of each and every particle. Ade. First calculate omega, then calculate the linear speeds. చెప్పండి అందరికి theta value ఎంతరా angular displacement ఎంత angle of 60 degrees in 2 seconds అంటే your angular displacement 60 degrees pi by 3 2 seconds time ఇదే కదా so your omega comes out to be pi by 6 radian per second ఇదే ఇప్పుడు this omega is same for each and every particle అదే కదా omega is same for each and every particle ra. So ikkada nunchi our omega comes out to be pi by 6 but I want the linear speeds. Linear speed ante enti ra v. What is the formula sir? V is equals to r omega. Okay, మూడో points ఉన్నాయి కదా. So sir, velocity of A is equals to radius of A into omega. Velocity of B is equals to radius of B into omega. Velocity of C is equals to radius of C into omega. Then substitute till it. All you have to do is to substitute the values. Next, hey, you can do it by yourself, right? Now it's a very simple piece of cake. Chuskondi. Radius of A entara, length of A ante 2 meters. So 2 into pi by 6 is omega. Ide kada ante pi by 3. ఎక్కడ వచ్చి చెప్పండి మీటర్ పర్ సెకండ్ మీటర్ పర్ సెకండ్ యూనిట్స్ లీనియర్ స్పీడ్ అదే కదా సో మీటర్ పర్ సెకండ్ విల్ బి ద యూనిట్ ఎక్కడ వచ్చి చెప్పండి సార్ 5 ఇంటూ పై బై 6 అంటే 5 పై బై 6 మీటర్స్ పర్ సెకండ్ ఎక్కడ వచ్చి 8 పై బై 6 మీటర్ పర్ సెకండ్ ఇదే నెక్స్ట్ యాంగులర్ యాక్సిలరేషన్ ఆల్ఫా అందరికి ఓకే లెట్ us talk about angular. Is it visible, right? Angular acceleration, and we call it as alpha. The same thing re, same thing. Alpha ante enti ra? Alpha ante very good Parimula, very good, right. What is the alpha sir? Alpha is the rate of change of angular speed. Ide rate of change ante enti sir? Sir, alpha is equals to omega by t. Ide leda you can also call it as d omega by dt, but you remember this is for a non యూనిఫామ్ సర్క్యులర్ మోషన్. యూనిఫామ్ సర్క్యులర్ మోషన్ ఉంటే యూ కెనాట్ సే నాన్ యూనిఫామ్ రా. నాన్ యూనిఫామ్ సర్క్యులర్ మోషన్ అంటే ఒమేగా ఈజ్ నాట్ కాన్స్టెంట్. ఓకే, delta omega, change in omega by t is alpha. But here when you say it, the change in omega is also not uniform and it is indisciplined. Do you remember this? This is indisciplined non-uniform circular motion. Okay, right. So once we have discussed all these things, let us jump to the equations of motion. Equations of motion, yes, 3 equations of motion. Number one, sir, your final angular speed omega f is equals to initial angular speed plus alpha into t. Next, omega f whole square is equals to omega initial whole square plus 2 alpha theta. Next, theta is equals to omega initial into time plus half alpha. These are your equations of motion. But sir, only remembering these equations is not sufficient. Hey, మీకు applications కూడా గుర్తుండాలి. You also should remember the applications of these questions. I have actually taken good number of questions in your circular motion chapter. Okay, మీకు కావాలంటే ఎక్కడ కూడా I will take some questions based on these formulas. దాని తర్వాత we will move towards our main chapter. చూసుకోండి. Let us take one question. Okay, this is your fan, fan, F-A-N, fan. ఇదే కదా? Yes. Let us take a question. అందరికి a fan starts moving from rest. Full stop. If the angular speed of fan increases to 10 rpm. rpm ante entira? I told you about rpm also. In circular motion chapter, I have told you about the rpm also. rpm ante rotations per minute, rpm. Okay, full stop. In 6 seconds, full stop, find the angular acceleration so this class will last till 12 at least 4 hours kavali to finish the entire chapter in one shot, at least required. Hi Isha, hi, I'm fine. Long time, right? Long time. ఓకే చూద్దాం. 10 rpm అంటే ఏంటిరా? వాట్ డూ యూ మీన్ బై 10 rpm? సార్, ఒక్కటే నిమిషంలో ఇన్ 1 minute it is moving at 10 rotations. Ide kada ade. This is the meaning of 10 rotations in 1 minute. 1 minute ante 60 seconds ra chuskondi. Right? 10 rotations. Oka rotation lo the angle that has been covered. One rotation kada. Yes. So sir, this is my rod. It is moving one rotation ante total angle chuskondi ra. Total angle is 2 pi radians. 2 pi radians. Ade kada. Yes. 2 pi radians. So sir, 10 into 2 pi radians is my angular displacement. Chuskondi. Ante entira. That means 20 pi radians in 60 seconds. Ante oka nimishamlo 60 seconds kada. Yes. So 60 seconds lo it is performing 20 pi radians. Cheppo. In 1 second, what is the angular displacement? In 1 second, angular displacement is 20 pi by 60 ante pi by 3 radian in 1 second ante your omega value is equals to pi by 3 radian per second. So this ide me final angular speed ra. What about initial angular speed, sir? Sir, initial angular speed was 0. How did I know? Because it has been given in the question that the fan starts from rest. Rest ante me omega initial is equals to 0. Omega final is equals to pi by 3 radian per second. Time enta icharu ra? Time is equals to 6 seconds. Ide kada? Yes. So what formula do we use, sir? V is equals to U plus AT. Ade. Right? Omega F pi by 3 0 plus alpha into 6. You can directly write the value of alpha is equals to pi by 18 radian per second squared. This is your answer. Choose code. I hope it's understandable. Good. Good. Next. Let us take one more question. Are you attending the class on a daily basis, Isha? I did not know that. Okay. I'm sorry. Okay. Cheppandi andariki. It's a simple application kada. Simple application of your formulas. Hey, Chapora, your 2 RPM is the final speed. Fan started initially from rest. Started from rest ante your initial angular speed becomes 0. Your final angular speed is 2 rotations per minute. Ide kada. What about time? Time is given as 4 seconds. Naku number of rotations kavali. Number of rotations ante sir theta value. Ee theta value ni if you divide it by 2 pi we will get number of rotations. Ade kada. Yes. How will I find the theta? You have omega initial, మీకు omega final ఇది కూడా తెలుసా కదా, రైట్. You also know about time రా. ఎక్కడ నుంచి you can find alpha. You can definitely find alpha. Okay, you can find alpha. Okay, you can find alpha. Hi Pavni, hi, hello. If you know omega initial, omega final, time and alpha, you can definitely find theta. ఇదే కదా. సో ఈ క్వశ్చన్లో you have to find two different things. Okay, you have to find two different things. The zero is not the answer. Okay. చూసుకోండి. సో సార్ ఇనీషియలీ నాకు ఆల్ఫా కావాలంటే ఒమేగా ఎఫ్ ఇస్ ఈక్వల్స్ టు ఒమేగా ఐ ప్లస్ ఆల్ఫా ఇంటూ టీ. ఒమేగా ఎఫ్ ఎంతరా? ఒమేగా ఎఫ్ ఇస్ ఈక్వల్స్ టు 2 RPM. You understand, if at all you have to convert your RPM into radian per second. Okay. Okay. You have to convert RPM ante n RPM. You multiply e n with your pi by 30. ఇదే కదా. I told you this, right? I actually told you this in your circular motion chapter. Okay? అందరికి omega sir, omega f is equals to n into pi by 30 అంటే 2 pi by 30 అంటే pi by 15 రా. డైరెక్ట్లీ రాస్తున్నారు చూసుకోండి. సో ఇట్స్ pi by 15 is equals to 0 plus alpha into 4. ఇక్కడ నుంచి your alpha value directly comes out to be pi by 60 radian per second squared. Okay. నాకు మిగతా సబ్జెక్ట్స్ గురించి తెలియదు, కానీ when it comes to physics your calculation must be very strong. Okay. ఎందుకంటే you only have 1 minute to attempt a one single question. అంటే ఏంటిరా, ఈ 1 minute లో you have to read that question, understand that question, think about the formula that has been applicable. ఆ ఫార్ములా తర్వాత you have to substitute the values and then you have to solve the mathematical part. Okay, you have to do 5 things at a time. You have to do 5 things at a time. So మీ speed and it must be very fast. Okay, it must be very fast. So this is your alpha value ra. Adhe, so you just substitute, sir, s is equals to ut plus half at squared. Ide kada. Sir, theta is equals to, this comes out to be 0. Why sir? Because initial angular speed is 0 ante starts from rest. Ide kada. Yes. Half is half. Alpha value is pi by 60 multiplied by time squared ante 16 squared. Chuskondi, 2 1s are 2, it is 8, 2 4s are this, and this is 15 ante 2 pi by 15 radians. This is the value of your angular displacement theta. Kani I don't want angular displacement, I want the number of rotations kada. If you want the number of rotations, you just divide by 2 pi. Chusko your number of rotations. I'll write somewhere here. Okay? I hope the ink is visible ra. Chusko your number of rotations is equals to theta upon 2 pi. Ante 2 pi by 15 divided by 2 pi ante 25 no 2 pi ante 1 by 15 rotations have been completed. You should not say it to be 0 ra. Chusko. Okay, half rotation ante enti ra, started went down. Ide kada, this is your half rotation. 1 by 4 rotation, 1 by 8 rotation, 1 by 16. Similarly 1 by 15 is your rotation. Okay, the rotation is 1/15th of a single rotation. It's not 0. Okay, it's not 0 for sure, it is not 0. Okay, next I don't think we will have to take more questions ra. Let us dive into the chapter andariki. Okay, let us dive into the chapter. Rotational dynamics, rigid body dynamics kuda antaru. What do you mean by rigid body, sir? Let us start from the basic itself ra. Okay, so ikkada varaku whatever I told you, this was something that you should have the idea and it should be known. That is your prerequisite. Okay, that was your prerequisite. చూసుకోండి. ఇప్పుడు let us talk about something known as rigid body రా. Rigid body అంటే ఏంటి సార్? What is a rigid body sir? Rigid body ante it is an object that cannot be elongated or compressed. Are you understanding? Are you understanding? In physics, we do not have a limitation of the numbers. Numbers ante enti sir? When I talk about angular speed omega, I don't keep a limit. And your angular speed should be, it could be 0 also. At the same time, it could be 1 million radian per second also. Are you understanding? Are you understanding? So you don't have any restrictions on values. So you imagine it's a cardboard, okay? It's a cardboard. Hey, you see it is bendable, okay? It's bending, right? It's bending. What do you think if I move this cardboard with an angular speed of, let us say, 2 pi radian per second, okay? 2 pi radian per second, it's a good speed. Sir, pi by 80 radian per second. I hope you are understanding what I am telling to you. Okay, choose kora. Pi by 4 radian per second. Pi by 4 ante enti sir? It should be 45 degree. Okay, pi by 4 ante 45 degree angle ra. Pi by 4 ante 45 degree angle. Choose. So it started ante oka second lo the rod is covering an angle of pi by 4. You see, this is the angular speed kada. Let us start. 3, 2, 1. Finished. 1 second completed. It has completed the angular displacement of pi by 4 radians. But when I say let us increase the speed to pi by 2 radian per second, okay? Pi by 2 radian per second. Ante emaintira? Can you understand, all of you, that the angular speed is increasing? Ante initially in 1 second it was moving pi by 4. Ippudu it is moving pi by 2 distance ante by 90 degrees. Pi by 2 ante 90 degrees. Ide kada okka second lo it has to cover more displacement of 90 degrees ra. Good. Sir, if I increase it to pi radian per second. Pi radian per second ante how much ra? 180 degrees in 1 second. 180 degrees in 1 second ante 3, 2, 1. Okay, the speed was very good. Okka second lo its displacement should be 180 degrees. So speed is more. Are you understanding? Okay. What will happen if I say omega is equals to 1000 pi radian per second? It's a very high angular speed. Andariki choosukondira. It is a very high angular speed. Ante okka second lo it must cover 500 rotations. Are you understanding how much speed it is? So do you think this cardboard made up of paper has the capacity to bear such high speeds? Right? It will break. Are you understanding? It will break. So what, sir? What will happen? It will break. What will happen if it is breaking? Choose. So if it is breaking, that means we can't trust on its motion. Enduku, sir? Because one part of it moves with one speed and another part moves with another speed. The best example is this book. Choose-kondira. It's not a rigid body kada, it's movable. Choose-kondi. It's a movable body. So I'm moving it. Are you understanding? This end is moving properly. Kani, this end is not moving properly. You understand? Okay, this is still not moving. This end is not moving. But this end is moving. Are you understanding? So if you have an object which is shrinkable, leda expandable, ante emaitadira? Ante you cannot trust, or you cannot say that each and every point on that object is performing a uniform motion ra. Chusko. So depending upon the situation, we invent a terminology, rigid body. Rigid body ante enti sir? Rigid body is the object whose points leda whose every part is fixed. You can't break it. Ante if the speed of one particle is omega, the speed of other particle also remains to be omega. Are you understanding? Rigid body is the object at which we will be doing our rotation motion. Enduku, sir? Because rigid body will never break. If it is not breaking, it is not having this type of discrepancy ra. Are you understanding? Are you understanding? The ends are differently moving. You understand? If I say this is my object, it's not rigid kada, it's not rigid. Chuskondi andariki, it's not rigid. So even if I am moving this end too fast, it will not follow the same way. You see, okay? You see. Are you understanding? There is a little delay. There is a delay in motion, at the same time there is no specific path. Kabatti we cannot write any equation for non-rigid bodies. I hope you are understanding, right? Okay? Right. Rigid body is the object whose every particle is fixed and does not change its position with respect to time. Ante enti sir? You can't break it, you can't bend it, you can't shrink it, you can't expand it. Ade kada? We need it, ra. We need it. It is our necessary. It is our necessity. This is the need of the hour. Why, sir? Why is it needed? Because we have to write the equation of each and every point on that object. So, equation, when you are going to write it, every point must be perfectly aligned. Ide kada? And that can only happen with your rigid object. If the object is breaking, you cannot say that its motion will be uniform. Uniform ante you cannot write the equation. Okay? Ade. Next, let us talk about the rigid body now. Chuskondi andariki. You try to understand. Okay? So let us say na daggara oka rod untundira. Okay? I am rotating this rod. Name of the chapter is rotational motion. Kabatti we will only be seeing the motions in which there is rotation in the rod. Okay, chuskondi. So now I am naming some of the points. Ide na first point. This is my second point. Third point. Sir, how many particles are there, sir? There are infinite particles. I can say, right? Can I say there are infinite particles? Yes. You can say there are infinite particles on this rod. Infinite particles on this rod. When the rod is moving, let us say it's moving with an angular speed omega. Andariki. Moving with an angular speed omega. What is same for every particle and what is different for every particle? Chusko. Point number 1. Can I say that angular speed is same for all the particles? Ide, the starting of the chapter itself has been done with this assumption. Ide kada? Okay, chuskora. Okay. The starting of the lecture was done with an assumption, ra. Ee rod lo unte every point it has the same angular speed omega. Ide kada. Kani distance where untundira. Distances are different. Chusko. This distance is r1. Distance ante enti ra? Distance of your point from the axis of rotation. Leda from the hinge point. Ide kada? Yes. So ide distance ante r1. This distance is r2. Here the distance is r3 and so on and so forth. Okay? I hope you are understanding what I want to tell to you. Andariki, are you understanding it? Yes. 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 Very good. So now I want you to imagine a rod, Rachosko. But this rod is made up of particles. Okay? This is my first particle, my second particle, third particle, fourth one, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th and so on and so forth. Okay? This is my rod. Can you visualize? This is a rod. Okay, this is a rod. The particles are there. Okay, the particles are there. Let us say mass of each particle. Here mass is m. M1 తీసుకో. ఎక్కడ వచ్చి let us say mass is m2 రా. Here mass is m3, m4, m5 ఇదే కదా, m6, m7, sir m8, sir m9, m10 and so on and so forth. These are the masses of the particles. Are you understanding, all of you? Yes. Yes. Now the problem is I want to rotate this rod. Okay, I want to rotate this rod. So this is my hinge point. Andariki, I hope you are understanding what I am telling you. This is my hinge point, all of you. The distance of the first mass from the hinge point is r1. The distance of the first mass from the hinge point is r1. Ikkada obviously it's 0. Yes. So let us say this is the distance r1. Ekkada vachi this distance is r2 ra. this distance should be r3, this distance should be r4, this distance should be r5, r6, r7, r8, r9 and so on and so forth. Can you visualize? Can you visualize? Right. Sir, mass m1, distance r1, mass m2, distance r2. Hey, ekkadi nunchi ra? When I am talking about this distance, where am I counting from? From the hinge point, leda from the axis of rotation. What did I say? Whenever you are given a rotation motion, you try to find the axis of motion of that object. Okay, so this is the axis of rotation. Ante ee axis of rotation nunchi you try to calculate the distance of each and every point ra chusko. So if this is my book, I don't know if I would be able to rotate it or not, but let us see. Let us try to do some experiments. This is my object. Chusko ra. This is the object. Kada? Yes. Now what I am doing is, I want to make it move. Okay, chuskondi andariki. It is moving, right? It is performing a circular motion. It's not the center of mass. I need the center of mass of it, so that it does not fall ra. Okay, a little towards this side, right? Hey. Oy. Yeah. What's happening, Ray? I'm taking. You understand? Okay. Now I want you to tell me the axis of rotation. Okay. What is the axis of rotation, sir? What is the axis of rotation, sir? It's falling down, right? It's not getting perfectly aligned. Choose. Okay. Whenever a moving object is given to you, hi, hello, Prisi, Praneeth, hi, hello. Whenever an object is given to you, you must be able to tell the axis of rotation of that particle. Okay, I can't make a whole but let us see. Okay, let us try to understand this. I hope it's understandable. Okay, all of you chuskondi ra. Okay, this is the motion happening. అర్థమైంది కదా? You must know the axis of rotation. Sir, ఒక్కసారి axis of rotation has been identified అంటే దాని తర్వాత you calculate the distances of each and every point. If the system is discrete అంటే ఏంటిరా? Finite masses ఉన్నాయి. 2 mass system, 3 mass system, 4 mass system. If you have that type of system, you identify the axis of rotation first. దాని తర్వాత you take the distance of each and every mass from the axis of rotation. అంతే కదా? Yes. Okay, right. So sir, mass m1 has distance r1, m2 ki distance is r2 and so on and so forth. ఇదే కదా? Right. ఇప్పుడు when the rod is moving, you understand this. Okay, when the rod is actually moving, when it is only moving, I want to talk about kinetic energy of this rod. చెప్పండి అందరికి. So can I simply say, sir, kinetic energy of the rod is equals to the sum of kinetic energies of, hey, listen to me, when I am telling the kinetic energy of the rod, I am telling that it is the sum of kinetic energies of each and every particle. అర్థమైంది? అంటే this is my first particle, ఇదే నా second particle, third one, fourth one, fifth one, 6, 7, 8, 9, 10, all these particles ra. I want to add their kinetic energies independently, then and only then I will be getting the kinetic energies of the total rod kada? Yes. So kinetic energy of the rod is equals to kinetic energy of particle 1 plus 2 plus kinetic energy 3 plus 4 and so on and so forth. అర్థమైంది? Yes. ఇప్పుడు the biggest question I have is, what is the kinetic energy of particle 1? Similarly for particle 2, particle 3, particle 4, particle 5 and particle 6 and so on and so forth. ఇదే కదా? Yes. చెప్పండి. So sir, for kinetic energy of particle 1, it is equals to, how many of you are understanding? Half m1 v1 square. For particle 2, it is half m2 v2 square. For particle 3, చెప్పండి అందరికి, చెప్పండి. For particle 3, kinetic energy is half m3 v3 square. and so on. ఇదే కదా? Yes, అర్థమైంది. ఇప్పుడు I want to talk about this V1, V2, V3, V4, V5, so on so forth రా. V1, V2, V3 అంటే ఏంటిరా? V1, V2, V3 are the linear speeds of these particles. ఇదే కదా? They are moving in a circle. So a circle లో ఉంటే they do have linear speed, and while writing the kinetic energy we only consider their linear speed of independent particles. అందరికి right? Very good. Kanmani, very good. Sir, V1 is the linear speed. What did we say the relationship between V and omega? Andariki. If any one of you remembers it, cheppandi andariki. Can I simply say, sir, if V is my linear speed, V is my linear speed, it must be equals to R into omega. What is R, sir? R is the distance of that particle from your axis of rotation. Mari, what about this omega, sir? Omega is the angular speed of each and every particle, ra. It is same. Yes, it is same for every particle. Ante omega 1 is equals to omega 2, it is equals to omega 3, omega 4, omega 5 and so on and so forth. Enduku sir? Because omega is same for every particle on this rod. Ippudu cheppandi sir, V1 is equals to R1 omega. Right? V2 is equals to R2 omega. V3 is equals to R3 omega. V4 is equals to R4 omega and so on so forth. అర్థమైంది? Yes. So substitute చేసుకోండిరా. Once you have the values of V1, V2, V3, you directly substitute. So sir, total kinetic energy of the rod half m1 v1 squared ante r1 omega whole squared plus half m2 into r2 omega whole squared plus half m3 into r3 omega whole square plus so on so forth. Sir, total kinetic energy is half m1 r1 omega whole squared plus half m2 r2 omega whole squared plus half m3 r3 omega whole squared. Enta particles unnayra? Infinite particles. So I'll leave it to infinite terminologies. Okay? సుషికి ఈ స్టేజ్లో I would highly recommend you not to follow anything. Anything ante enti sir? Anything ante you don't follow something by yourself. Keep a mentor. Keep a mentor ante enti ra? Keep a mentor ante a person who can guide you live. Live ante telusa? So the best thing that everybody of you can do, the best thing, andariki chudandi, I'm just giving you a 2-3 second pause, okay, all of you. I want you to understand what I'm telling to you, okay? 16 people are watching, chusko. The best thing that you can do now is quickly go on this channel. ఈ ఛానల్లో ఉంటే మొత్తం lives అంటే subject wise రా, subject wise. When did the first live of physics happen? It happened somewhere around 8th or 9th of December. చూసుకో. So 9th of December నుంచి ఇప్పటిదాకా whatever the lives have been covered, you first finish all of them. Okay? You first finish all of them. దాని తర్వాత I am now only specifying about physics. Okay? Physics గురించి మాట్లాడుతాం. చూసుకోండి. When it comes to physics, ఒకసారి you have completed all these live videos, the immediate thing that you will be doing is you follow whatever I am doing. Ante once our syllabus has been completed, we will be directly jumping to the PYQs. 4-hour, 5-hour, 6-hour live lecture lo I will be completing your 20 years to 25 years of last complete PYQs. So sir, ఒకసారి your PYQs are completed, you don't even have to do any random question ra. Are you understanding? I am giving you the guarantee. Okay, I am giving you the guarantee. Andariki chuskondi. I am giving you the guarantee. What is the guarantee, sir? If your 30 years PYQ are clear, me past 30 years PYQ clear unte, in physics you can at least score 150 to 160 minimum, 150 to 170 kuda, you can expect this much marks also. But the biggest thing or the biggest problem is you have 32 chapters ra. Physics lo you have around 32 chapters. Deentlo I personally have completed around 14 chapters. Chuskondi. 18 chapters are left, and these 32 chapters you have modern physics. I am breaking the chapters of modern physics also. Modern physics ante enti sir, you have nuclear physics, you have your photoelectric effect, you have your particle wave theory, okay, basically. So if you combine all these chapters, your 32 chapters will reduce somewhere around 28 to 27 chapters ra. In 27 nunchi I have already covered 14 chapters. If I am telling lie, you file a case on me. You go to the previous lives and check how many chapters I have completed, starting from basic maths ra. Okay, I have completed 14 chapters. Next I will be completing your syllabus mostly by February. Dan tarvata March, April నా దగ్గర 2 months ఉన్నాయి కదా. ఈ 2 monthsలో వాట్ ఎవర్ సెషన్స్ ఐ విల్ బి టేకింగ్, ఐ విల్ బి జస్ట్ డూయింగ్ ద పీవైక్యూస్. పీవైక్యూస్ అంటే ఐ విల్ బి ప్రిపేరింగ్ ఆల్ ఆఫ్ యూ ఫర్ యువర్ 150 to 170 మార్క్. ఇప్పుడు దట్ టైమ్ ఈస్ గాన్ వెన్ యూ ఆర్ టేకింగ్ సమ్ ర్యాండమ్ బుక్ అండ్ సాల్వింగ్ ద క్వశ్చన్స్. యూ కాంట్ డూ ఇట్, అండర్స్టాండ్, యూ కాంట్ డూ ఇట్ బికాస్ మీ దగ్గర టైం అంటే అసలు లేదురా. ఓకే, యూ జస్ట్ డోంట్ హ్యావ్ ద టైం, రైట్? ఎనీవేస్, so the students who have not started anything, for the students who have not started anything and who just know the basics of every subject and the basics of physics telusa, I recommend or I request all of you to first cover the live videos. In live videos lo you have the list of all the concepts and formulas. You make a proper note of it. When it comes to the PYQs, you use all those formulas. If we are solving 200 PYQs, chusko. If I am taking 200 PYQs, okay, let us say approximately I am giving you 3 minutes of time ra. Okay, 3 minutes of time ante it's approximately equals to 600 minutes. 600 minutes ante it is approximately 10 hours of time ra. But I will not take this much long of sessions. Okay, I will be trying to wind up this session only in 6 hours. How sir? I will be giving you some questions in homework. Some questions homework ante one question has been asked in 2020. Same pattern, same repetition has been done in 2024. I will skip it. Okay, I will skip it. Ante I will only be taking your 6 hours. See, 6 hours lo we will be completing 200 PYQs. Okay, I need your support. I can't do it alone. Okay, I literally can't do it alone. If at all the students are not interested, I can't take this series forward. Chuskondi. Anyways, so let us move toward our discussion. Let us move towards our discussion. No, and time ante chala takwa ra. You don't have much time. Chala takwa. If one more month has been passed, and if you are jumping to February, you can't do anything. If your syllabus is not completed, just raise your hands, wait for the next year, leda take whatever college you are getting. Okay, I can't guarantee you for your MBBS. Anyways, okay, chuskondi. This is your total kinetic energy. Ide kada? Yes. Simplify ra. Sir, half m1 r1 square omega square plus half m2 r2 square omega square plus half m3 r3 square omega square plus half m4 r4 square omega square plus so on and so forth. Can you take something common ra? Can you take something common andariki? Yes, you can take something common. What aim common tiyali ra? Cheppandi andariki. Sir, I can take half. At the same time I can take omega. Common ide kada? Yes. So sir, half omega squared. What is left ra? Mikita mottam raskondi. So you can simply say m1 r1 squared plus m2 r2 squared plus m3 r3 squared plus so on so forth. Now ఈ మొత్తం ఎక్స్ప్రెషన్ని అంటే m1r1 స్క్వేర్ ప్లస్ m2r2 స్క్వేర్ ప్లస్ m3r3 స్క్వేర్ ఐఎమ్ గివింగ్ ఇట్ అ స్పెషల్ నేమ్. స్పెషల్ నేమ్ అంటే ఏంటి? లెట్ us see how many of you can guess that special name. ఈ మొత్తం టర్మినాలజీని ఐఎమ్ గోయింగ్ టు అసైన్ అ స్పెషల్ నేమ్. వాట్ ఈస్ దట్ స్పెషల్ నేమ్? అందరికి వాట్ ఈస్ ద స్పెషల్ నేమ్ ఫర్ ఆల్ దిస్ ఎక్స్ప్రెషన్? How many of you have the idea? చెప్పండి. What should be the special name? Nobody? Huh? Nobody knows? Nobody knows. Oh, no one. No one. No one. Okay, nobody knows. If అన్నిటిని we call it with some special name. What is that name? Moment of inertia. Okay, moment of inertia. Oh, now we clicked, sir. Now it clicked. Now it clicked. Ante your total kinetic energy of rotation. You remember the particle was లేదా the rod was just doing rotation kada. Yes, so rotation motion lo you can say your total kinetic energy is half omega squared into I లేదా half I omega squared. So this is your total kinetic energy. Total kinetic energy of rotation. This is a formula andariki. I want all of you to remember it. Okay, I want all of you to remember it andariki. Okay, right. Eppudu perfect. So we have heard the name, sir, but you forgot what it means. Okay? So మీ దగ్గర ఒక ఆబ్జెక్ట్స్ ఉంటే యూ అండర్స్టాండ్. ఓకే, వాట్ ఈస్ దిస్ మూమెంట్ ఆఫ్ ఇనర్షియా రా? m1r1 స్క్వేర్. వాట్ ఈస్ m1 రే? అదే దిస్ ఈజ్ అ ట్విస్ట్ వేర్ ఎవ్రీ స్టూడెంట్ ఫెయిల్స్. ఓకే, ఈవెన్ ఇఫ్ ఐ టోల్డ్ యూ ద ప్రూఫ్ ఫ్రమ్ ద బిగినింగ్ రా, యూ మైట్ ఫీల్ డిఫికల్టీ ఇన్ ఆన్సరింగ్ మై క్వశ్చన్స్. నా ఫస్ట్ క్వశ్చన్ అంటే, సార్ వాట్ ఆర్ దీస్ టర్మినాలజీస్ సార్? వాట్ ఈస్ m1? చెప్పండి, వాట్ ఈస్ m1 రా? వాట్ ఈస్ m1? హౌ మెనీ ఆఫ్ యూ కెన్ టెల్ ద ఆన్సర్? లెట్ us see. వాట్ ఈస్ m1, m2, m3? వాట్ ఈస్ r1, r2, r3? చెప్పండి అందరికి. What is m1, m2, m3? What is r1, r2, r3? Sir, m1 ante mass of the first particle. Okay. Sir, m2 ante mass of the second particle. I have started the journey. You can say m3 mass of third particle, mass of fourth particle, so on and so forth. Kani, where are these particles? Ekkada unnarra? Where are these particles? So these particles, there are on the rigid body. Chusko. So మీ దగ్గర ఒక rigid body ఉంటే, you take each and every point on that rigid body. You say those masses as m1, m2, m3, m4, m5. Distance from axis లేదా distance from the hinge. Sir, r1, r2, r3, r4, r5. అదే కదా? Right. So you define a terminology, moment of inertia, m1 r1 square plus m2 r2 square plus m3 r3 square, so on and so forth. And then you write that with letter I and substitute chase. You can find the kinetic energy of rotation. Yes, very good, very good. Mass and radius, కానీ it's not explicitly telling me రా, చూసుకో. So moment of inertia could be categorized into two categories రా. The first one is మీ rigid body, it is a continuous mass distribution. Continuous mass distribution అంటే ఏంటి సార్? Like a pen, like a rod, like a ring, like a disc. Are you understanding? Every particle is attached to one another. లేదా you have discrete mass distribution రా. I am focusing more on discrete mass distribution. ఎందుకంటే continuous mass distribution needs a little more advanced application of mathematics. So we will just be remembering the formulas for continuous mass, and for the rigid mass distribution we will be remembering the results also. చూసుకోండి రా. Discrete mass distribution. ఈ మొత్తం డిస్కస్ చేసి ముందు I want all of you to remember the formula of moment of inertia. చూసుకోరా. What is the formula of moment of inertia, sir? I is equals to m1 r1 squared plus m2 r2 squared plus m3 r3 squared plus చెప్పండి అందరికి so on so forth ఇదే కదా. what is r1 r2 r3 చెప్పండి. what is r1 r2 r3 r4 r5 r6 what are the distances ra. what is r1 r2 r3 I want the explicit answer. explicit answer అంటే that answer should include everything. sir r అంటే distance. no, it's not the explicit answer. you are the students who are going to be the doctors. okay sir, we are doing surgery and forgetting the scissor into the stomach of the person. it's not acceptable ra. okay sir, surgery చేసిన తర్వాత I got a thought that I forgot this cloth into the person itself. okay you must be perfectly doing your work ra. చూసుకో ఈ ఫార్ములాలో m1 m2 m3 so on so forth. what are these sir? these are masses of individual particles. ఇదే కదా masses of individual particles. what about r1 r2 r3 r4 ra? చెప్పు sir, r1 r2 r3 and so on so forth, they are distances. అదే కదా. yes sir, they are the distances. finished sir. నా రెస్పాన్సిబిలిటీ కంప్లీట్ అయింది. నేను చెప్పాను కదా r1 r2 r3 are the distances. what distances? whose distances? from what point are we calculating these distances? చూసుకోరా, these are distances of masses ra. masses అంటే ఏంటిరా? your masses m1 m2 so on so forth. from what? from ఇది చాలా ఇంపార్టెంట్ రా. this is the most important thing I insist on. from సో ఇప్పుడు మీకు యాక్సిస్ ఆఫ్ రొటేషన్ తెలియదు అంటే gone. if you don't know the axis of rotation, you can't take the distances. if you don't know the distances, you don't know r1 r2 r3 values. if you don't know r1 r2 r3 values, you can't substitute. if you can't substitute, you can't find moment of inertia. if you can't find moment of inertia, you can't find the energy. if you can't find the energy, you can't solve the question. if you can't solve the question, you will lose the marks. if you are losing the marks, your score will decrease. if your score is decreasing, your rank will decrease. if your rank is decreasing, you will not get college. if you don't get college, you will repeat. if you repeat, you will waste your entire year. if you waste your entire year, your life is getting shortened. if your life is getting shortened, you are not getting anything to enjoy. if you are not getting anything to enjoy, your life is dead. hey, focus. okay, I request you, please focus on these things. అందరికి next. so all started from axis of rotation kada. yes, so you must be good with it. okay, you must be good with it. లేదా it is going to end your life రా. చూసుకో axis of rotation. next, discrete mass distribution అంటే ఏంటిరా? ఈ discrete mass distribution లో there are separate masses who are actually performing circular motion. అంటే ఏంటిరా? అంటే ఏంటి? ఈ సర్క్యులర్ మోషన్ లేదా రొటేషనల్ మోషన్లో we will be giving priority to the masses only. sir, what are you talking sir? we are giving priority to masses only. masses and their positions. అందరికి masses and their positions. masses and their positions. చూసుకో. so sir, if I have 3 masses, అంటే నా దగ్గర 3 masses ఉన్నాయిరా. so this is mass m1, ఇదే m2, this is m3. okay, now when I say, what color should I choose? let us choose this color. okay, something a little light. lay down. Yellow is there. let us choose this color. చూసుకో. so you have 3 balls లేదా 3 masses, 3 marbles రా, 3 marbles. the practical limitation in physics is that you can't have these 3 masses move in a same motion until and unless you connect them with a rigid object. అంటే ఏంటిరా? these masses are connected with, I changed the color, right? Why did it come the same, ra? Okay, so these masses, they are connected with a massless rod, ra. What I am telling you, listen my words, okay? Andarki jagrataga vinandi whatever I am telling to you. So this is my first mass, ide ante na second mass, and here it is my third mass. So 3 masses unnai kada? Yes, ochindi sir, ochindi. Now are they looking like an equilateral triangle to you? Okay, are they looking like an equilateral triangle? So now they are looking. Okay, now they are looking like an equilateral triangle. You ignore, okay, you ignore whatever discrepancy is there. So I am connecting these 3 masses with a rod, with a massless rod. Choose whatever, every word of me you understand it very carefully. Okay, I am connecting this with a massless rod. Massless rod ante enti ra? Massless rod ante, this rod has only one task, that is to support these masses ra. Choose. So ante ide na mass M1. Let us say the value is 10 kgs. Andariki. Mass M2. And you are rotating it, okay? You are rotating it. Okay, you are rotating it. How are you rotating, sir? The rotation is happening in such a way like this. Okay, so these are rotating, something like this, ra. Choose. Kani, the angular speed of rotation, omega is equals to 4 radian per second. Okay, did you understand the scenario? నా దగ్గర 3 masses ఉన్నాయి, and I am connecting these 3 masses with a massless rod. Massless rod, right? It's a very important terminology. I don't know if you are focusing it or not. చూసుకో. This is your massless rod. Sir, why massless rod, sir? ఈ rod కి mass ఉంటే you have to consider this mass as well in rotation. So whenever you have mass, you are going to have kinetic energy whenever it is rotating. అదే కదా, half mv square రా, half mv square లో m is your mass. Half mv square లో m is your mass. So ఎప్పుడైనా m ఉంటే your kinetic energy will also have to be present. But I don't want this kinetic energy of this rod. కాబట్టి I am just telling these are the 3 masses. And this is the assembly. Length కూడా తీసుకోరా. This length r is equals to, లేదా you take this 10 meters, ఇది కూడా 10 meters, ఇది కూడా 10 meters. Did you understand the scenario? 3 masses, 10 meter, 10 meter, 10 meter distance, 10 kg, 20 kg, 40 kg are their masses, moving with an angular speed of 4 radian per second. Question is, find kinetic energy okay, kinetic energy of system. Hint కావాలంటే hint కూడా ఇస్తాను, చూసుకోండి. I'm also giving you hints. Hint is, kinetic energy కోసం మొదటిగా you calculate first moment of inertia. Moment of inertia కావాలిరా. Without moment of inertia, you simply cannot calculate the kinetic energy. So first you need the moment of inertia. దాని తర్వాత formula for kinetic energy is this. Hey, where is it? Where is it? This. Hey, if you want, I'll write it in a very detailed way. Choose andariki. Your total kinetic energy for a rotating object, rotating, only rotating. I'm not talking about translation motion now. Ippudu, okay? Ippudu, you can simply say, sir, kinetic energy is equals to half to visible, yes, moment of inertia I into omega squared. Choose square. So this is your kinetic energy for rotation. So ఈ calculate చేయడానికి మీకు kinetic energy కావాలి, at the same time you need omega also, but omega is not a twist, it will be given to me. Most of the times I will have to calculate the moment of inertia only. Choose. Okay, again I am telling you that this formula is only valid for a purely rotating object. Okay, for a purely rotating object. Try this question, I will give you 2-3 minutes of time. For a purely rotating object, kinetic energy is given by this formula. Again, this is valid for purely rotating object. Okay, there is nothing as translation motion. Translation ante telusa, it is moving in a straight line, right? Ide na translation, and this is my rotation. Okay, this is your rotation, this is your translation. Chuskondi andariki. Okay, this is your translation motion. Okay, and this is your rotation motion. Okay, complete rotation. I hope you are understanding. Let's come back to the question. Chusko. Take this question, calculate the moment of inertia. Andariki. Yes, Isha, rotation and translation, they are different. Translation Gurunji, we have talked in your kinematics 1D, kinematics 2D. Rotation Gurunji Kuda, we have talked in your circular motion. But in this chapter lo, we are going to combine both of them. Combine both of them, and that would be the last milestone of this chapter. So this lecture, when it ends, we will be having a good amount of idea about both the things doing the rotation and kinetic motion. Okay. Hey, one more important information, Andariki. Okay. Since the attendance is good, I am going to tell you, whoever has not registered for Vedantu All India Score Accelerator Test Series, YSAT. Okay? The last date is your 18th of Jan. Ante sir, the exams have already been started. So whoever did not registered, Valli Kosam, your 4th January was your first exam date, ante first Sunday of this January. Dan tarvata 11th of January was the second date. These two exams have been completed. Now the only exam that is left, so these series of examinations were supposed to happen in 3 stages. Ante 3 stages lo exam perform cheyali. The 2 series, the 2 sessions have already been completed. The last and the final session of this test series is going to be on 18th of Jan. Chuskondi andariki. That is yet to be conducted. So whoever has not registered for this test, I would highly recommend all of you to register for it. Okay, along with this test, you go into the description section of this video. This video ki description section lo, you have different types of test series. Okay, maths, physics lo kuda MPC ante there is maths coming out in my mouth. Okay, test series are there. You BPC students kada, so BPC walanuku there are 3 subject test series, ante physics, chemistry and biology. All 3 test series are there. You go to the description section, click on the links, you will automatically find the material, and at the same time you will also find the test series for each and every subject. Once your 18th January YSAT has been completed, so whatever videos from here, Super 45 series ki, right from the beginning of the videos till the end of the video, every description section has some links. Links ante your test series links are there. Click on them, register if you have not registered. Okay, whoever is attending this lecture if you have not registered in your Vedantu website, you are not the student at all. Are you understanding? You are doing some incomplete work, ra. So register. First of all, what you have to do is you register on Vedantu website, ra. Okay, you are missing a lot of things if you are not registering. Go open the website. First of all, register yourself. Then you will see a huge series of the variety whatever we are having. Okay, okasari you are done with your visa test, your results will be there. Right along with the results, they will tell you this. The analysis will tell you your score. After your score, they will tell you your weak points. Choose score. It's a very important thing. That's why I tell you. Okay. Having a mentor is the most important thing in today's age. Having a mentor. Okay. Having a mentor is most important. They'll tell you your weak points and accordingly they will give you the lectures, free lectures. Okay. All of this will happen for free. They'll give you the lectures. At the same time, you will also get the modules, everything for free, okay? You will be getting the modules, everything for free. And the most important thing, whatever handwritten notes I have made, nenu kuda some handwritten notes I have uploaded over there. Kani, ee mottam kosam you will first have to register, okay? You register yourself, you will see the handwritten notes section also, you will see the tests results also. You will see your score, your weak points, your strong points, your competitors, your national level ranking, your predicted score. There are much more things involved into it, okay? So 18th January is the last date. Aa tarvata whatever videos, be it physics, chemistry, biology, go into the description section. You will find the links to the mock tests, give them test series, and then you will come to the results. Okay, just good. Okay, perfect. Hello. Hi. Pranod. What a method to say hello. Okay, let's continue. Okay, let's continue. So if you have to talk about the kinetic energy, what did I say? Kinetic energy is given as half I omega square. So kinetic energy kavalante moment of inertia gurtundale. You must have moment of inertia. Omega you know. If it's a rigid body ade nenu cheppina kada, whenever you have a rigid body, all three masses must have same omega, ante 4 radian per second. It also should have 4 radian per second. Here also it should be 4 radian per second, and here also it should be 4 radian per second. How can I say, sir? Because I know that this rods, they are connected, massless rod kada, it's a rigid body. If it breaks, if this thin rod, thin ante chinna rod kada, if it breaks, then they will not have same omega. Okay? The first thing that I have is omega. I don't have a moment of inertia. So how to calculate, sir? Sir, moment of inertia formula chudandi. What is the moment of inertia formula? M1r1 square, M2r2 square, M3r3 square. But in formula lo, what are the terminologies? Sir, M1, M2, M3 are the masses of individual particles. Do I have the masses? Yes, sir. M1, M3, M2. I have it. Na daggara masses untundira. What next, sir? R1, R2, R3 kavali. What are these? Distances. Is it okay if I just say distances? No. It's not explicitly mentioning. Distances of masses from axis of rotation. And what did I say in the beginning of the lecture? First slide, what did I say? You must know the axis of rotation to attend any question. So you must know the axis of rotation. Akkadunchi you must know the distances R1, R2, R3 values ochindi. Substitute M1 R1 square plus M2 R2 square plus M3 R3 square, you got moment of inertia. Then half I omega square will give you the kinetic energy. Again, if you are saying only the distances, I will break my whole head, okay? Not the distances. Distances of the masses from the axis of rotation. Axis of rotation. Choose andariki. Where is the axis of rotation in this scenario? ఒక ఇన్ఫర్మేషన్ ఇస్తే యూ మస్ట్ బి నోయింగ్ ద యాక్సిస్ ఆఫ్ రొటేషన్ అందరికి. వేర్ ఇస్ ద యాక్సిస్ ఆఫ్ రొటేషన్ చెప్పండి ఆల్ ఆఫ్ యూ. ఐ వాంట్ టు టెల్ యూ ద యాక్సిస్ ఆఫ్ రొటేషన్. చెప్పు. ఐ థింక్ ఐ డూ హ్యావ్ సమ్ స్ట్రాస్ రే. Where is the axis of rotation? Where is the axis of rotation? చెప్పండి అందరికి. Do I have only two colors ra? What else I have to do re? क्या करना पड़ रहा है? Okay, try to understand अंदर. Hey, I think I did mistake ra. Mistake. Okay, చూసుకో. Hey, should be straight. Okay, this is your rod. Okay, this is your rod system. Right, చూసుకో. Moving like this. Okay, moving like this. Where is the axis of rotation? Where is the axis of rotation? This ide kada? Yes. This is the axis of rotation andariki. This should be the color. Okay, this is the axis of rotation. So whenever a motion is happening andariki, you must know the axis of rotation. At least do that for me. Okay, at least do that for me. So whenever the motion is there, center, very good. And how is it? How is the axis of rotation acting? It will always be perpendicular to the plane of the motion. Are you understanding? The axis of rotation is always perpendicular to the plane of motion. You understand something like this, okay? All of you. So this is a plane kada, this is a plane, okay? This is a plane. Moving like this, చూసుకోండి, it is moving like this అంటే axis of rotation will be something like this. Are you understanding? So this object always moves around the axis of rotation, right? Perfect. Isha, very good, very good. So ekkada vachi your axis of rotation will be something like this, perpendicular, okay? Coming out లేదా going in, you can assume whatever you want. This is your axis of rotation. Distance is calculate చేసుకోండిరా. This distance is r1 అదే కదా. This distance is r2 and this distance is r3. చెప్పు సార్ moment of inertia I is equals to మూడు masses ఉన్నాయి కదా, discrete mass system ఉంటే m1r1 square plus m2r2 square plus m3r3 square. ఓకే సార్ m1r1 square plus m2r2 square plus m3r3 square. m1 ఏంటిరా? m1 value is 10. r1 square అంటే 10 square అంటే 100. Are you understanding? Right. Plus m2 r2 square plus m3 r3 square. How many of you have understood? Can I directly write, sir? 7,000. 7,000 is it 70,000? 7,000. Okay. Unit is kg meter square. M r square kada. M ante kg, r square ante meter square. So ide na moment of inertia andariki. Right. I got the moment of inertia. Ippudu when you write about the kinetic energy andariki cheppandi. So when you write about the kinetic energy, can I simply say, sir, kinetic energy is half I omega squared. Ante half moment of inertia 7,000 omega entara 4 square. Ede ante half into 7,000 into 16 ante 56,000 joules. This is your kinetic energy. I hope you understood it. Okay, very good Isha, very good. So this is your total kinetic energy, half I omega square. Cheppu. Now I'll give you different questions. Let us see how many of you can answer these questions. Okay, ide na first mass ra. Your mass m is equals to 100 kgs andariki. And this is my second mass. Again let us say mass m is equals to 50 kgs andariki. Right? Yes, it is moving something like this with an angular speed omega is equals to 4 radian per second. And this is your angular speed omega is equals to 20 radian per, not 20, it should be 2 radian per second. okay, radian per second. If I am attaching a massless rod ra chusko, this is the massless rod andariki ide kada, massless rod. I am connecting it with a rod, okay, I am connecting it with the rod. Let us say this is a point about which the motion is happening, ante ide na axis of rotation. I am giving you directly in the question. Let us say this distance is 2 meters, ekkada kuda the distance is 2 meters. Calculate the kinetic energy. Now I am going to club it. నాకు కైనెటిక్ ఎనర్జీ కావాలి. లెట్ us see how many of you can answer it. చెప్పండి అందరికి తొందరగా, క్విక్లీ. Let us take a break at 10 p.m. okay, 10 to 10:40. If possible I will extend this lecture to 12 లేదా 12:30 లేదా 1 p.m. రా, 1 a.m. sorry 1 a.m. I don't know how long it goes, okay, but we will complete everything. You have to find kinetic energies, Isha. ఈ సిస్టంలో కైనెటిక్ ఎనర్జీ కావాలి. వర్కింగ్ రే చూద్దాం. సో సార్, if you are interested, I'll try to club this question with the next question, okay. Next question ante enti ra, next question ante let's talk about neutron stars, something like this, right? Something, okay. You see sir, total kinetic energy can be given as half I omega square. I value unta sir, I is m1, rendu masses unnai kada, so rendu masses unte m1 r1 square plus m2 r2 square. Ade very good, very good. Varalakshmi, let us see, chuddam, okay. I don't know the answer, but I congratulate for having the attempt, okay. So half directly రాస్తున్నా చూసుకోండి, m1 r1 squared plus m2 r2 squared multiplied by omega squared. ఇదే కదా, half value is half. m1 ఎంత రా, m1 100 multiplied by r1 square అంటే r is 2 meter, 2 meter square అంటే 4 meter plus m2 r2 square is మళ్ళీ ఒకసారి 4 multiplied by omega. omega ఎంత సార్, 4 radian per second. Hey, let us take this as 4 only ra, okay, because it's taking too much. If it's a rigid rod, then omega will be same for every particle, okay. Yes, so 4 square is 16, okay. So 2 ones are 2, 2 8s are 16, and you can simply say sir 400 plus 200 600 multiplied by 8 ante 4800 joule of energy is there. Okay, now let me ask a little advanced question, okay, little advanced question. Chusko. The question says something like this. మీ దగ్గర రెండు masses ఉంటాయి, okay? So this is your first mass. Let us say mass m is equals to 6 kgs లేదా 7 kgs. Not 7, let us take it to be 6 kgs only, okay? First mass is 6 kgs. Your second mass is 4 kgs andariki, okay? 4 kgs. The distance between the two masses is a chala important question, okay? In the last class of gravitation also, I have given you something sort of question, okay? And I am here also, I am telling you the same thing. Let us say the distance between the object is 20 meters. This is moving something like this, omega, ide kuda same angular speed omega, omega ki value omega is equals to sir 2 radian per second. Ide kada? Yes. So the question is, if the masses are moving due to their, లేదా don't try to moving, okay, are rotating, due to their gravity ra, okay, their gravity. Find kinetic energy of rotation. It is chala important. It's a very beautiful question, okay? Find kinetic energy of rotation. Very beautiful question. Okay. I'll give you a hint. I will give you a hint. Andariki. The hint in this question is, if they are moving due to their gravitation chapter has been completed in the last class. Ante yesterday's class only we discussed about gravitation. I told you two things about the gravitation. First, your gravitational force is a central force. Then I told you your gravitational force is an internal force. Internal force ante entira? Internal force unte there will be no motion of your center of mass. Ante your center of mass remains the same. Okay, Isha, let us see. Okay, let us see. Your center of mass remains the same. Ante if they are rotating due to their gravity, their axis of rotation is nothing but their center of mass. Hey, not like this, it should be a little towards the heavier mass, kada? Yes. So this is their center of mass, and the center of mass is nothing but their axis of rotation. It's a little concept based question, okay? I am trying to mix center of mass, gravity and your rotational motion. Okay? So sir, if axis of rotation is center of mass, I want to calculate the center of mass. Ela calculate cheyali sir? Kabatti you must know the formula for finding the center of mass of the two mass system. Okay, how will you find the center of mass? Any one of you knows the formula? Evaraina cheppandi. Does any one of you know the formula ra? Direct shortcut, okay? Whoever tells me the formula, I will give them Cadbury Dairy Milk. Okay? Whoever tells me the formula, I will give them Cadbury Dairy Milk. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ade, your chance has been gone. Your chance has been gone. So the formula for center of mass is, you had a chance to win the Cadbury Dairy Milk Silk. Hey, anyways, I am not promoting anything. Chusko. The formula for center of mass is m2d divided by m1 plus m2. Thus I told you to remember this formula. So if this is your first mass m1, ee mass nunchi the distance will be m2d divided by m1 plus m2. Ide kada? M2 value entira. Ide na mass m1 ra. This is my mass m2, okay? సో m1 నుంచి డిస్టెన్స్ ఈజ్ m2d డివైడెడ్ బై m1 ప్లస్ m2. m2 వాల్యూ ఎంత సార్ 4 మల్టిప్లైడ్ బై d అంతారా 20 డివైడెడ్ బై m1 ప్లస్ m2 ఇస్ 10. ఇదే కదా 8 meters. Are you understanding? అంటే this distance is 8 meters రా అందరికి చెప్పండి. This distance is 8 meter. మిగతా you can automatically tell 20 నుంచి 8 అంటే 12 meter is the remaining distance. This is your axis of rotation. This distance is 8, that distance is 12. చెప్పు, it's a very simple question now. So kinetic energy can be written as half I omega squared అంటే half m1 r1 squared plus m2 r2 square into omega square. Omega is same for both the masses. ఇదే కదా. Okay, so half m1 value ఏంటి రా m1 is this 6. r1 square అంటే 8 square రా 64 plus m2 is 4 r2 is 12 square అంటే 144 into omega is how much sir? Omega is given as 2 square అంటే 4. డైరెక్ట్లీ రాస్తున్నాను చూసుకోండి. 2 gone రా. 6 into 64 plus 144 into 4 sir, 4 6 are 24, 2 carry 3 3 is 36, 38 plus 144 288. Directly you can write it 16 17 1 576 into 2. Ide kada, you add it. I think you will get somewhere around 0 6 9 into 2 అంటే 1920 joules. This is your kinetic energy. It's not in my hands, Kanmani. It's not in my hands. The hands are not in my hands. Okay, so this is your answer. Let us see if you can understand whatever the calculation mistake is there. You do it by yourself. Okay, 960 kada, yes. 800 plus 80 80 60, right? 800 plus 160 అంటే 960 into 2 అంటే 1920 joules. Okay, hey, it's a very standard question andariki, very standard question. For all of you who did not understand this question, go back, watch it 2 times and come back again. Okay, come back again. Keep this question in mind. This is a very important question ra. Keep this question in mind. If possible, make a similar question. Just masses change cheskondi, distance kuda change. This mass is 6 and 10 kada, you take 12 and 8 ra. You can also change the distance. It's 20, you can take 30 and do the same question once again. Malli okkasari cheyandi. Then and only then, yes, very good. Parimala, very good. Okay, of what Isha, what expansion kavali? Cheppu okkasari. I'll try to tell you. Okay, this is the formula for center of mass. So if you're talking about this formula, sir, you don't understand it, you can directly take m1 r1 plus m2 r2 plus m3 r3 divided by m1 plus m2 plus m3. Okay. Okay, what expansion, Isha, what expansion do you want? Hey, rabbit, how can you say no break? I did not eat anything, I'm hungry. Okay, I'm hungry. Let us say anyways, I'll be hungry for you. Okay, I want my students to succeed in life. Okay, let us postpone the break a little. Andariki, moment of inertia, ardhamaindi andariki? Yes. So let us talk about some more terminologies. We have successfully expressed the kinetic energy of a rotating object in terms of its moment of inertia. Okay, we have successfully expressed the kinetic energy of a rotating object in terms of its moment of inertia. Ippudu let us talk about the momentum of rotating object. Chala important formulas. Okay, momentum of rotating objects. I'll try to tell you in a new way so that nobody has told it. Okay, let's first define what the momentum in rotation looks like. Choose rotation lo, when you talk about momentum andariki, if this is the object, choose andariki, all of you, I want you to remember. Okay, all of you, I want you to remember, this is my mass. Okay, this is my mass and this is the axis of rotation. Andariki chuskondi, if this is the axis of rotation ante distance chuskora okasari, distance is r, ade kada. Hey, what did happen? Okay, so ide na axis of rotation, this is my mass m. Andariki chuskondi, mass m, radius r unte, right, it must move in circle something like this. Ide kada. Yes, so this is the center ante axis of rotation, mass m and moving with a speed v ra, andariki chuskondi. What did I say, sir? What did I say? What did I say? What did I say? What did I say? I told you that if you have a moving object, and whenever we are talking momentum in a rotating objects kada, rotating ante circular motion lo rotate cheyali. So this is my first object, it is moving in a perfect circle ra. Always remember, if the object is moving in a perfect circle, there must be the axis of rotation. What did I say? Axis of rotation. Cheppandi, if it is moving like this, this is my mass, okay? This is my mass. Mass m is there, moving in a circle with some speeds, okay? With some speed. Let us say the speed is v ra. Andariki cheppandi. Speed v, mass m. Moving like this. Can you tell me the axis of rotation? Andariki. Who can tell me the axis of rotation? I don't have much things to show you, but if possible, let us see, okay? Chuddam. Where is the axis of rotation? Andariki cheppandi. Can I risk one thing for you ra? Okay, can I risk it for you? Chusko. If this is your mass, okay, if this is your mass, idi mi mass unte, I am trying to rotate it, but I don't think it will rotate ra. Endukante it is being supported by two different ends. Okay. Anyways, let us see. Chuddam andariki. If this mass is there, you only focus on it. Okay, you only focus on this. Only focus on this. Okay, it is moving something like this. Chudandi. Where is the axis of rotation? Where is the axis of rotation? Cheppandi andariki. Where is the axis of rotation? What did I say? What did I say? You understand, Ray, you understand. If you don't know the axis of rotation, this entire chapter is gone. Okay? No. It's not rotating, it's revolving. Okay? It's revolving. So if you don't know the axis of rotation for a rotating particle, you're never going to understand. Okay? You'll never understand. I'll tell you, okay? I will tell you. If you don't know, listen to me and keep it in mind, okay? Keep it in mind. Chusko andariki. So whenever an object is moving in a circle, if it is connected, if it is not connected, even if it's moving by itself ra, the axis of rotation will always be very good. Isha, very good. At the center. This is the axis of rotation, and it is moving along this axis of rotation. Ante kada? Yes. This is the axis of rotation at the center. Right. Perfect, sir. This is my axis of rotation. Distance cheppora. Distance is r. Ide kada? Koncham samayam tarvata this mass will come at this distance. Chuskondi andariki. Ide kada? So after some time it came here. Dan tarvata it is coming at this point, and then again it is coming at this point. Andariki chuskondi. Cheppora. Distances cheppandi andariki. Idi kuda r, and this is also r. Why, sir? Because it is moving in a circle. Circle ante every point has a fixed distance from the center. Ide kada? Hey, if you are spamming, I will block you. Okay? Whoever, evaraina, Kola Praneeth, last warning from my side. Don't spam. ఈ లెక్చర్ స్టార్ట్ చేసి ముందు ఐ హావ్ టోల్డ్ యూ నాట్ టు స్పామ్. ఓకే, ఐఎమ్ నాట్ గోయింగ్ టు టాలరేట్. లెట్ us see. Distances are r1, r2, r3. అంటే r. Complete distances are r kada? Yes. Okay, perfect. Now you tell me the momentums ra. Momentum అంటే linear momentum kada. Mass is m, speed is v. అందరికి చూసుకోండి. Sir, linear momentum is always represented by the letter p and given as mass into velocity, mv. P is equals to mv. ante kada? Right. In rotation we don't talk about linear momentums. Linear momentum we only talk about when the mass m is there moving with a linear speed v ra. Hey, this pen is there moving with speed v, mass m, speed v, mass m, speed v unte momentum is given as m into v. Kani circular motion lo it is always changing the direction kada. So direction change aina tarvata you need some extra force to change the direction. If some force is there, momentum will not remain constant. Until linear momentum is not going to be constant. Are you understanding? In that scenario, you have to talk about something known as angular momentum. Chusko. Again I am telling you, whenever it comes to rotation, pure rotation, linear momentum will not work. Em kavali? Angular momentum kavali, sir. Ippudu angular momentum, yes, no, mass does not change. Isha, mass remains the same. You want angular momentum kosam, you have a formula, okay? The scientist did some research. Ippudu we don't have to go into the depths of those formulas. It's there for JE, it's there for JE, okay? We take small chinna masses, we take it from a system and then we assemble everything. We'll try to write not required for us. You just remember the formula, sir. They say angular momentum is a vector quantity represented by the letter L, okay? Angular momentum ante vector quantity untundira and it is represented by the letter L, okay? Formula is given as L is equals to R bar cross P bar. This is chala important, okay? This is one of the most important formulas in your entire rotational dynamics, okay? Yeah, Varalakshmi, it's there, but this is the standard format, okay? L bar is equals to R bar cross P bar. Ippudu, to proceed further, you must have a little idea about the cross product. Telsa, cross product ante enti, sir? You understand it something like this. Na daggara oka object is there, mass m array and moving with some speed v ra. Is it moving in a linear motion? Cheppandi andariki. My question to you is it moving in a circular motion? Is it moving in a circular motion, andariki? Yes or no? Yes or no? Yes or no? Yes or no? Is it moving in a circular motion? Why so much time, ra? Enduku enta time తీసుకున్నారు అందరికి చెప్పండి. Is it moving in a circular motion? It's moving, it's not moving, sir. Yes or no? రెండు options ఉన్నాయి కదా. You say whatever you want, sir. If you don't know. Okay, Purushottam Gandhi. What a perfect name you got, right? My question was, if the object was moving down, is it a circular motion? No, it's a linear motion, raha. How can you say it's circular motion? It's a linear motion, okay? It's not a circular motion. Kani. Let us come a little out of the conventional way. No, it is not a circular motion. It's a linear motion, okay? But, Purushottam, I appreciate it. I think you have understood something that I want to tell you. Okay? Okay. Choose code. It's not a circular motion. For sure, note it down. I guarantee you, I'm giving you in writing, right? It's not a rotation motion. Point number 1. Kani, what is the angular momentum formula I have written? Cheppandi andariki. R bar cross P bar. R bar ante enti ra? Okay, let us introduce one more slide and let us highlight this formula as much as possible. Chusko andariki. Angular momentum L bar can be written as, cheppandi andariki, your R bar cross your P bar. Ide kada. This is your angular momentum. Okay? This is your angular momentum. Ee formula lo you must be good with all the expressions ra. L bar ante angular momentum naku telusu. I know it very perfectly. L bar ante enti ra? L bar is your angular momentum. Bar ante it is a vector quantity. Point number 1. Noted, sir. Dan tarvata your R bar ra. What is R bar? What is R bar, sir? What is R bar? R bar ante same as your moment of inertia. What is R bar, re? What is R bar, sir? Sir, R bar is nothing but the distance. Cheppandi andariki. Why are you so dull? I don't understand. Distance of mass from other from యాక్సిస్ ఆఫ్ రొటేషన్ ఇదే కదా, ఎస్ పర్ఫెక్ట్. వాట్ అబౌట్ పీ రే? పీ ఈజ్ ద లీనియర్ మొమెంటమ్ ఆఫ్ ద పార్టికల్. లీనియర్ మొమెంటమ్ అంటే ఏంటిరా? ఎంవి. ఎంవి కదా, ఎస్ సార్. హియర్ ఈస్ బార్ సార్. బార్ ఉన్నప్పుడు యూ కెనాట్ సే డిస్టెన్స్. ఆర్ యూ అండర్స్టాండింగ్? ఇఫ్ ఇట్స్ అ బార్ యూ కెనాట్ సే డిస్టెన్స్, ఇట్ మస్ట్ బి ద పొజిషన్ వెక్టర్. వాట్ ఆర్ యూ టాకింగ్ సార్? ఇప్పుడు యూ సెడ్ డిస్టెన్స్ అండ్ నౌ యూ ఆర్ టెలింగ్ టు పొజిషన్ వెక్టర్ రా. ఎస్, ఇట్ మస్ట్ బి రిమెంబర్డ్ యాజ్ పొజిషన్ వెక్టర్ ఆఫ్ పార్టికల్ from axis of rotation. Okay, this is also good, but this is better, position vector. Okay, position vector. Yes, very good. Your r bar is the position vector of the particle from the axis of rotation. Ippudu I am going to come back to my original question. Andariki chuskondi. Okay, we don't decide if it's a circular motion or not. Purushottam has given a very good answer. He said that sir, it's a circular motion. Yes, it's not a circular motion, but okay, but it can be said as circular motion in one condition. In what condition ra? When you continuously change your axis of rotations. Are you understanding? When your axis of rotation is continuously changing, you can say that is circular motion. Chusko. How should I tell you, ra? I'm really not understanding. Okay, not understanding. Okay, chusko. Modatiga, this is my axis of rotation. Okay, this is my axis of rotation. The particle is moving a very small angular displacement. Chala chinna, very small angular displacement. Andariki, I don't know how many of you are understanding. Okay, let us say this was my particle ra. Initially it's there, now it want to move very small angular displacement. Very small ante telusa, very small ante from the part of the circle, it is moving a very small distance. Very small ante telusa, very small ante it has just moved this much. It's visible, right? I don't know if it's visible or not. Chusko. Okay, this is the distance that the particle has moved, ra. Very small, very small, very small. Are you understanding? Yes. As soon as it has moved that distance, andariki chuskondi, as soon as it has moved the axis of rotation, now that axis of rotation has moved a little down. It has moved a little down. Okay? Now it has moved a little down. Little down ante enti ra? Once the axis of rotation has been changed, the particle motion will also change ra. Chusko. Ippudu this is the axis of rotation kada. Yes. So ee axis of rotation kosam I have zoomed it too much. Ee axis of rotation kosam the particle will move a little down. Not like this ra. This particle will move a little down. Okay sir, ardhamaindi. So this motion, and I will change the color itself ra. Chusko. A little down, something like this. So for brown motion the axis of rotation was this. And for pink motion, the axis of rotation is this. Are you understanding? So, malli, if I change the axis of rotation to this point, ra, the particle will move something in a blue way, something like this. Chusko. I hope you are understanding, okay? I hope you are understanding. If I change the axis of rotation once again, Ray, I am moving it downwards. Let us say a green color already. Yes. So, let us say it's a light pink, ra. This is the axis of rotation. Are you understanding? When the axis of rotation is continuously changing, rotation motion is also changing. Ante when you try to zoom it out, ra, what do you see, sir? You see a straight line, ra. What do you see, sir? You just see a straight line. Are you understanding? You see a straight line. Ante this straight line is a circular motion. Kani the axis of rotation is changing continuously. It should be actually taught to JEE students, but I am telling you, whoever is understanding, well and good. Not understanding, just remember, okay? I want to jump to a formula ra, kabatti cheptunnanu. Otherwise I would not have told you anything. Okay, chusko. Ee formula lo I want to calculate angular momentum. Ide kada? Yes. So angular momentum kosam your axis of rotation should be given to you. Momentarily oka random moment lo, okay, ఒక random moment లో let us say this is your axis of rotation. At some time it is continuously changing. Hey, linear motion unte it has infinite axis of rotations and it is changing at each and every time. Okay, it is changing at each and every time ra. So I am telling you this is the axis of rotation and here is the particle ra. Ekkada unnaru particle, it is at the top, it is at the top. So I think this does not keep any significance ra. Okay, I'll wipe it out. Chusko. So this is your particle having speed v at this particular time. Chusko, your r bar ante enti ra? What did I say about r bar? R bar is a position vector of particle from axis of rotation. Okay, position vector of particle from axis of rotation ante ide na axis of rotation and I want to draw the position vector. Ela draw cheyali ra? This is your r bar. Are you understanding? Position vector of particle from axis of rotation. Okay sir, what about p bar sir? Chuskora, your angular momentum r bar cross p bar ante linear momentum ante mass into velocity. mv bar kada? Yes, mv bar, v bar ki direction enti sir? Downwards. Ante your momentum is also in the downward direction. Ippudu naku l bar kavali, l bar. Sir, l bar can be given as r bar cross p bar. Ide kada? Yes. Where is your r bar ra? This is your r bar. Where is your p bar re? Downwards kada? You shift it. You can shift kada? Yes, you can shift the independent values ra. Chusko. How to do it re? Yes. No. Hey, how to shift re? I forgot. Hey, okay, you shift it. Something like this. Okay, this is your vector. Andariki cheppandi. So this is your p bar. Okay, ide mee p bar ra. I'll write it. R bar cross p bar ra. Ippudu cheppandi r bar cross p bar direction. How do you do it? Curl your fingers. Sir, this is my r bar. Curl it. P bar into the plane kada? Yes, so this is my angular momentum direction. Understand? Are you understanding? Are you understanding? Your L bar ante R bar cross P bar, it is going into the plane of the paper. I hope you are understanding ra. Okay, so let us take one more question based on the same concept. So sir, okay, before that, deeniki mundu let us discuss one more formula ra. L bar is equals to R bar cross p bar. Ide kada? A bar cross b bar ra. Cheppu, what is a bar cross b bar sir? Ante L bar is equals to r into p into sin theta. Theta ante enti ra? Ee scenario lo your theta is angle, cheppu, angle between what ra? R bar and p bar kada? Yes, between r bar and p bar. But p is what sir? Sir, p bar ante m into v bar. So direction of p bar is direction of v bar. Okay, so it is nothing but r bar and p bar leda r bar and v bar. You can take this also ra. Always remember your L bar is rp sin theta. Theta is the angle between r bar and v bar ra. Okay, r bar and v bar. Yes, very good. Choose. So if you have a motion like this, andariki, ide knee mass m and this, okay, this is your mass m andariki and this is your axis of rotation. Okay, this is your axis of rotation. What do you do to find angular momentum? Step number 1, r bar cross p bar kosam you need r bar ante the position vector of the given mass from the axis of rotation. Idi kavali ra. So you can directly draw the position vector of the mass from the axis of rotation and name it as r bar ra. Ide na momentum p bar kada? Yes, so ide na p bar, this is my r bar. What is angle sir? If you know, write it. If you don't know, try to construct it. So in the question I have given you, this angle is theta. Ide kada? Now what do? You shift it. You shift what sir? You shift everything. And you bring it this side. Cheppu, what is the angle between r bar and p bar? Ippudu cheppandi andariki. What is the angle between your r bar and p bar? Sir, this is the angle between r bar cross p bar. Which one ra? Ide. If 90 degree is it's theta, so automatically comes out as 90 minus theta. Ide kada? So your angle is 90 minus theta. Chuskondi. So when you write the formula, your L bar should be equals to R bar cross P bar ante RP sin of value is 90 minus theta andariki. Sin 90 minus theta is cos theta ante RP cos theta. Chuskondira, this is your angular momentum. What is direction, sir? R bar cross P bar, curl it into the plane. Into the plane ante negative k cap. Ide kada? Yes. So this is the direction. Very good. Very good. Varalakshmi, very good. Okay, I hope you are enjoying the session. Okay. Next, I have much more things to tell, but I have to limit it. నెక్స్ట్ చూడండి రా, నా దగ్గర ఒకటే మాస్ ఉంటుంది. ఇప్పుడు ఈ కేసులో దిస్ ఈజ్ మై యాక్సిస్ ఆఫ్ రొటేషన్ అండ్ హియర్ ఈజ్ మై మాస్. చూసుకోండి అందరికి, దిస్ ఈజ్ మై మాస్ రా, ఇదే నా మాస్ m, అదే కదా. ఎస్, సో దిస్ ఈజ్ మై మాస్. యాక్చువల్లీ దిస్ మాస్ ఈజ్ మూవింగ్ ఇన్ అ రొటేషనల్ సర్క్యులర్ మోషన్, సంథింగ్ లైక్ దిస్. చూసుకోండి అందరికి, అబౌట్ ద యాక్సిస్ ఆఫ్ రొటేషన్, అంతే కదా. ఎస్, నౌ ఐ వాంట్ టు టాక్ అబౌట్ ద యాంగులర్ మొమెంటం. చూసుకోండి అందరికి, ఇప్పుడు I'm giving you a very standard result. So whenever the object is moving in a circle, ఈ ఆబ్జెక్ట్ కి యాంగులర్ మొమెంటం గురించి మాట్లాడాలంటే ఆర్ బార్ క్రాస్ పీ బార్. అందరికి చెప్పండి, వెర్ ఈజ్ ఆర్ బార్ రా? ఆర్ బార్ అంటే పొజిషన్ వెక్టర్. పొజిషన్ వెక్టర్ అంటే ఏంటిరా? ఇదే నా పొజిషన్ వెక్టర్ ఆర్ బార్, ఇదే కదా. ఎస్. వాట్ అబౌట్ పీ బార్? పీ బార్ అంటే మొమెంటం ఎం వి బార్. వాట్ అబౌట్ వి బార్ రా? సర్క్యులర్ మోషన్ ఉంటే యువర్ వి బార్ షుడ్ బి పర్పెండిక్యులర్ టు ద రేడియస్, అంటే టాంజెన్షియల్ డైరెక్షన్ లో. సో దిస్ ఈజ్ యువర్ వి బార్ రా. వాట్ ఈజ్ యాంగిల్? అందరికి చెప్పండి. సార్ థీటా ఈజ్ ఈక్వల్స్ టు 90 degrees. ఇదే కదా, ఇదే కదా. ఎస్, ఎస్. సో సార్ యువర్ యాంగులర్ మొమెంటం విల్ బి గివెన్ యాజ్ ఆర్పీ సైన్ థీటా. ఏ బార్ క్రాస్ బి బార్ అంటే ఏబీ సైన్ థీటా, ఇదే కదా. సో ఆర్ ఇంటూ పీ ఇంటూ సైన్ థీటా అంటే సైన్ 90 రా. వాట్ ఈస్ ద వాల్యూ ఆఫ్ సైన్ 90 సార్? ఇట్ కమ్స్ అవుట్ టు బి 1. అంటే ఆర్ ఇంటూ పీ, పీ అంటే ఏంటిరా? ఆర్ ఇంటూ ఎంబీ, ఇదే కదా. ఎస్, అంటే ఎంవిఆర్. సో దిస్ కమ్స్ అవుట్ టు బి యువర్ యాంగులర్ మొమెంటం ఇన్ అ సర్క్యులర్ మోషన్. ఒకటే పార్టికల్ ఉంటే యువర్ యాంగులర్ మొమెంటం విల్ బికమ్ ఎంవిఆర్, ఇదే కదా. ఎస్. ద సేమ్ థింగ్ వి యూజ్ ఇన్ క్వాంటమ్ మెకానిక్స్. క్వాంటమ్ మెకానిక్స్ అంటే బోర్స్ మోడల్ గుర్తుందా? యువర్ సెంట్రిపిటల్ ఫోర్స్, యాంగులర్ మొమెంటం, క్వాంటైజేషన్ రూల్, MVR is equals to NH by 2 pi. Are you understanding something? Hey, your electron will move in only those orbitals for which the angular momentum of the electron is the integral multiple of h upon 2. Understand? Okay? So if the particle is moving in circular motion, ee particle kosam angular momentum is MVR ra. M ante mass, V ante speed, R ante radius. అర్థమైంది అందరికీ? ఎస్. సో నౌ ఐఎమ్ గివింగ్ యూ వన్ క్వశ్చన్. తీసుకోండి. ఒకటే పార్టికల్ ఉంటే ఐ అండర్స్టూడ్. ఓకే, ఐ అండర్స్టూడ్ ఇఫ్ ఐ హ్యావ్ అ సింగిల్ పార్టికల్ రా. వాట్ అబౌట్ ఐ హ్యావ్ మల్టిపుల్ పార్టికల్స్? చెప్పండి అందరికీ. ఓకే, సో దిస్ ఈజ్ మై సర్క్యులర్ మోషన్. ఓకే, అందరికీ చెప్పండి. So if this is my circular motion అంటే నా దగ్గర there are more than one particles రా. చూసుకో. So this is your first particle, ఇదే మీ second particle, this is your third particle, this is your fourth one, ఇదే మీ fifth particle, ఇదే మీ sixth particle. And this is the axis of rotation. అందరికి this is the axis of rotation, center of the circle కదా. yes, yes. చెప్పు, mass అంటే m1, m2, m3, m4, m5, m6. 6 masses ఉన్నాయి అందరికి. And let us say the speeds are same speeds అంటే every particle having speed v, ఇక్కడ కూడా speed v, here also speed is v, here also speed is v, speed v, speed v. చెప్పండి. రేడియస్ r ఇస్తున్నారు చూసుకోండి. So I am giving you the radius also is equals to r. ఇప్పుడు I want, yes, Isha, we will take the break in 5 minutes. Okay, ఇప్పుడు I want the angular momentum. చెప్పండి, how many particles are there రా? 6 particles. So I need the angular momentum of the system అంటే the angular momentum of all 6 particles, ఇదే కదా. yes. So sir, total angular momentum is equals to, చెప్పండి, total angular momentum is equals to, లేదా I'll remove this bar. Okay, I'm only interested in the values రా. లేదా చూసుకోండి, L1 bar plus L2 bar. how many particles రా? 6 particles కదా. L3, L4, L5, L6. Understanding? Right. What about values ra? whenever the object is moving in a circular motion. What did I say? Whenever it is moving in a circular motion, angular momentum is mvr. Fill it in your mind, okay? Put it in your mind. ఎప్పుడైనా the object is moving in a circle, its angular momentum is mvr రా. అదే చెప్పు. సో ఫర్ దిస్ పార్టికల్, ఈ పార్టికల్ కోసం m1vr, m2vr, mvr కదా, mvr m1vr, m2vr, m3vr, m4, m5, m6vr. అదే. సో యూ కెన్ సింప్లీ సే సార్ m1vr ప్లస్ m2vr. వై vr రా? v సేమ్ ఉంటుంది. ఫర్ ఆల్ ద పార్టికల్స్ v is సేమ్ కదా, ప్లస్ m3vr ప్లస్ m4vr ప్లస్ m5vr ప్లస్ m6vr. ఇదే కదా. సో what can we take common? We can take v into r common. Yes, we can take v into r common. అంటే vr కామన్ తీసిన తర్వాత you are left with m1 plus m2 plus m3 plus m4 plus m5 plus m6. ఇప్పుడు I want you all to understand, okay? Understand. Just 5 more minutes. Sir, vr, v, sir, v. In the first lecture itself, in the beginning of the lecture itself, I told you something about v and omega. Hey, v can be written as r omega. Omega ante angular speed. Ide kada. V is equals to r omega. Andariki. V is equals to r omega. V is equals to r omega. V is equals to r omega unte r omega into r into m1 plus and so on so forth. Ide kada. Yes. Now I'll change the slide. Andariki. So sir, r omega r ante r square omega. R square omega. Yes. So you can simply say, sir, total momentum is r square omega into m1 plus m2 plus m3 plus so on so forth ante m6. Now break it, multiply with everything. Multiply, okay? Multiply. You are left with m1 r square omega plus m2 r square omega plus m3 r square omega plus so on so forth. Ippudu you take only omega common ra. Take only omega common. Sir, omega common I took it. m1 r square plus m2 r square plus m3 r square plus so on so forth. Hey, m1 r1 square, m2 r2 square, m3 r3 square. We have a special term for it. What is the special term name ra? Cadbury Dairy Milk. Gurtunda? Cadbury Dairy Milk ra. What is the special name? Moment of inertia ra. I. Ante your angular momentum will be given as I into omega. Ade. Your kinetic energy is given as half I omega squared and your momentum is given as I into omega. So, ippudu you remember the two formulas for momentum. First formula, sir, L bar is equals to R bar cross P bar. At the same time, L bar is equals to I into omega bar. Okay, this is the first formula. This is the second formula. Okay, let's take a question, and e question at the same time I will be giving you a break. Okay, e break lo you solve it the question. Yes, very good. Okay. So the question is something like this: find the angular momentums of the following. Number 1, తీసుకోండి. Number 2, తీసుకోండి. Number 3. Only 3 questions and then we will be giving a break to solve all 3 of them. Okay. So this is your first mass M. Ide me second mass M, and this is your third mass M. Andariki. Okay. Let us say this is the axis of rotation kavali. Why, sir? Because whenever you have moment of inertia, you cannot calculate the moment of inertia without knowing the axis of rotation. Chala important, okay? Idi chala important. Andariki chuskondi. So this is your axis of rotation. Ee distance ante r1, this distance r2, this distance r3. Their speeds are v3, 90 degree angle. Speed is v2 90-degree angle, speed is v1 90-degree angle. Okay. Second case lo, you have a circle. Okay, there. And there are these particles ra teeskondi andariki. Your first particle is 10 kgs, your second particle is 10 kgs, your third particle is 10 kgs, your fourth particle is 10 kgs. Radius gurinchi maatladalante, your radius r is equals to 5 meters and every particle is moving with an angular speed omega is equals to 2 radian per second. Okay, radian per second. Third case lo, your particle is moving towards right ra. Okay, mass teeskondi, m is equals to 10 kgs, your speed v is equals to 4 meter per second. Ante kada, this is your axis of rotation andariki. This, okay, and this distance is 4 meters. Okay, calculate the angular momentum. Okay, so let us take a break. With this, what is the time ra? Time is your 12:32 kada? Yes. So your break will be, where should I write? Okay, this question comes with a break. After break, torque, conservation of angular momentum, kinetic energy, rotational plus translational momentum. Ade. Okay. Hello, everybody. So I'm back. Hi. I hope you all are done with the question, right? Okay. Yeah. A very warm welcome after the breaks. చెప్పండి. So okay, you're waiting. Okay, so Varalakshmi, very good. So in first case lo your angular momentum will be given as, చెప్పండి. Hey, you cannot directly add it. ఇక్కడ చూడండి, your angular momentum should be ఏంటిరా? Should I take separate scenarios and then do it? I don't know how to copy it. Okay? How to copy it? Up and down. Text copy. What is it? Lock. Copy. Okay, copy it. Here, I think. How to paste it? Anyways, చూసుకోండిరా. I will quickly go through the system. Okay? ఈ కేసులో your distances were r1, r2, r3, masses were m1, m2, m3. ఇదే కదా, your mass was m1, mass was m2, mass was m3, speed was v. ఎక్కడ కూడా your speed was v. చూడండి అందరికి, your distance was r2, here your distance was r1, here your distance was r3. అందరికి చూడండి. Hi. Good evening, Gonad. Good evening. Why are you so late, Gonad? Anyways, chalo. Hey, your total angular momentum, okay, your total angular momentum should be sum of L1 bar plus L2 bar plus L3 bar. Sum ante vector sum ra, vector sum చూసుకోండి. Vector sum ante ఏంటి రా? అంటే your velocity is momentum చూసుకో. Initially you talk about your P1 bar లేదా L1 bar, L2 bar, L3 bar. Separate గా చూడండి. How will your L1 bar look like రా? Your V1 అంటే P1 is in this direction, your R1 is in that direction. అంటే ఇదే మీ P1 and this is your R1 bar. ఇదే కదా, angle 90 degree ఇచ్చాను. So your R bar cross P bar is into the plane of the paper. Okay? Hi soulmate, hi. Your R bar cross P bar is into the plane of the paper. అంటే your L1 bar is into the plane of the paper. ఇక్కడ కూడా చూడండి, your R bar is here, your P bar is in the left రా. ఇక్కడ కూడా your R bar cross P bar, do the cross product, it is into the plane of the paper అంటే here. What about this? Sir, your P bar is this side, your R bar is this side. ఇదే కదా. Hey, R bar అంటే పొజిషన్ వెక్టర్ రా, డైరెక్షన్ చూసుకో. Sir, ఇక్కడ కూడా your R bar cross P bar is into the plane of the paper అంటే your directions are same. Directions same ఉంటే you can directly add them. Right. Good. Very good. Isha, very good. Now you can directly add them. ఎలా యాడ్ చేయాలి sir? You can simply say, sir, m1 v1 r1 plus m2 v2 r2 plus m3 v3 r3. So this was the feel of your angular momentum. If you understand this, I am very happy. Okay? ఏదైనా కామన్ ఉంటే రాసుకోండి, కామన్ తీసి యూ కెన్ ఫైనలీ రైట్ ద ఆన్సర్స్. అంటే m1 r1 వేరే ఉంటుంది, స్పీడ్ ఇస్ v అంటే టేక్ v కామన్, ఇట్ ఇస్ సింప్లీ ఈక్వల్స్ టు m1 r1 ప్లస్ m2 r2 ప్లస్ m3 r3. ఇదేరా. సో దిస్ ఈజ్ యువర్ టోటల్ యాంగులర్ మొమెంటమ్. డైరెక్షన్ ఏంటిరా? డైరెక్షన్ ఈజ్ ఇన్ టు ద ప్లేన్ ఆఫ్ ద పేపర్ అంటే నెగటివ్ k క్యాప్లో డైరెక్షన్. not special classes because I did not get the time to take the class. Time ante studios were not free. Next, చూసుకోండి. Your first question I have been done. Your second question it's చాలా simple రా, చూసుకో. Your momentum r bar cross p bar is into the plane, okay? Hey, similarly the second thing, okay? Second thing I want you to understand. Second thing I want you to understand రా, చూసుకో. ఎప్పుడైనా మీ దగ్గర సర్క్యులర్ మోషన్ ఉంటే, ఓకే, ఇఫ్ యూ అట్ ఆల్ యూ హ్యావ్ యువర్ సర్క్యులర్ మోషన్, చూసుకోండి అందరికి. ఇఫ్ యువర్ మోషన్ ఈజ్ అలాంగ్ అ సర్కిల్, అంటే ఇఫ్ యూ హ్యావ్ అ సర్క్యులర్ మోషన్, ఇదే మీ పార్టికల్, ఓకే, మాస్ m ఇస్ దేర్, యువర్ యాంగులర్ స్పీడ్ లేదా యువర్ లీనియర్ స్పీడ్ ఒమేగా లేదా వాట్ ఎవర్ ఇస్ దేర్, ఓకే. షార్ట్ కట్ చూసుకోరా, షార్ట్ కట్ ఉంది ఫర్ ఓన్లీ ఫర్ అ సర్క్యులర్ మోషన్. సర్క్యులర్ మోషన్ అంటే ఒక పార్టికల్ లేదా the particles moving in a circle, to find the angular momentum, curl your fingers in the direction of the motion ra. Em cheyali curl your fingers in the direction of momentum. Ade you don't have to do r bar cross p bar here. R bar cross p bar kuda cheste you get the same answer ra. So your momentum, angular momentum is into the plane of the paper. Leda if the motion is in this direction, curl your fingers, your angular momentum is outside. ఇదే కదా చెప్పు. Here your angular momentum in ఎక్కడ కూడా inside, so you have to add all four of them. So sir, directly you write m1 v1 r1 bar plus and so on and so forth ra. Mass is same, speed కూడా same, r కూడా same, అంటే 4 times of m times of v times of r రా ఇదే. సో 4 10 స్పీడ్ ఎంత రా, v అంటే r omega కదా. yes, v అంటే r omega. లేదా you can also say sir 4m r omega into r అంటే 4m omega r square. ఇదే కదా. చెప్పండి omega ఎంత రా? omega is 2. r square అంటే 5 square అంటే 25. ఇదే కదా. yes, 50 into 10 500 into 4 becomes 2000. so here your angular momentum is 2000. okay, your angular momentum is 2000. Next. Okay. It is little complicated in this scenario. Chuskondi ra. Okay, so I'll select it. Let us shrink it a little and let us bring it here. Okay. Hey, you understand it, okay? I'm leaving it like this. Choose, taking too much of time. ఇక్కడ చూడండి, ఇక్కడ here. What is the formula for angular momentum, sir? Sir, L bar equals to R bar cross P bar. అదే అర్థమైంది. I don't have any problem till this formula. కానీ నాకు వాల్యూస్ కావాలిరా. వాల్యూస్ అంటే ఏంటి సార్? What is R bar? What is P bar? And how to do the stuff? చూసుకో. ఈ ఫార్ములా L bar is equals to R bar cross P bar లో what is R bar? I've told you clearly. Even at the time of moment of inertia, I've told you clearly what is R. R is distance. But this answer is not sufficient. R is the distance of the particle from the axis of rotation. Leda R bar is the position vector of the mass from the axis of rotation. Cheppandi. So this is the axis of rotation. ఇదే కదా. ఈ axis of rotation ఉంటే ఇక్కడ నుంచి directly write the position vector. చూడండి. So this becomes my R bar అందరికి. అదే కదా. ఇప్పుడు yes, very good. What should be the momentum? అంటే angular momentum. R bar cross P bar కదా. అంటే RP sin theta. Let me take this question on a fresh page రా. చూసుకో. Okay. So this was my particle moving with some speed ra. This was my axis of rotation. ఇదే కదా. Yes, this was my axis of rotation. చూసుకోండి. I given you this distance. Okay, I given you this distance. అందరికి. What was this distance ra? 4 meters, 4 meter per second, 10 kg. Okay, 4 meter distance, speed kuda 4 meter per second, and mass was 10 kgs. Okay, mass was m is equals to 10 kgs. ఇప్పుడు చెప్పండి అందరికి. When you write your R bar, you listen to me very carefully. Okay, జాగ్రత్తగా వినండి అందరికి. ఎందుకంటే ఇట్స్ చాలా ఇంపార్టెంట్ రా. ఓకే, చాలా ఇంపార్టెంట్. చూసుకో. So this is my radius vector. Radius vector ante enti ra? First of all, let us write the formula, sir. L bar is equals to R bar cross P bar. Ee formula lo R bar is the position vector from your axis of rotation to the given mass. Ante ide na R bar ra. Andariki ardhamaindi. This is my R bar. R bar cross P bar ante RP sin theta. RP sin theta. What is theta, sir? R bar cross P bar ante RP sin theta. What is theta ra? Theta is the angle between R bar and P bar. Leda R bar and V bar. Ade kuda same kada? Yes. Your V bar towards right. Your R bar is in this direction. Can I say this is the angle ra? Is it theta? Yes or no? Is it theta? Yes or no? Yes or no? Yeah. It is going in. Gonad, I told before you came, if the object is moving in a straight line, that can be said that it is circular motion. Kani the axis of rotation is changing. No. My question is angle theta the angle between the vectors? Vectors ante R bar and P bar. Is it there or it's not there? Just tell me that much information. Ade R bar cross P bar lo is the angle theta the angle between R bar and P bar? Is it or it's not? Chepan, I just want to know it. No. Chusko. It is not the angle. Why, sir? Because the first vector head is there, head chudora, and here the tail of the second vector is there. So head to tail, we can't count the angle between the vectors. Mari em cheyali, sir? You shift it. What to shift, right? You shift any vector you want. You shift whatever vector you want. Okay, you shift whatever vector you want, ra. So here, let us say I am shifting this vector. Ela shift cheyali, sir? You simply shift it to this direction. Ante kada? Yes. But before that, you understand what length is given to you, ra. What length is given to you in the question? In the question, ante question lo, this length has been given to you. Which length, sir? This length. Enta 4 meters. Ide kada? 4 meter length has been given to you. Ade. So, sir, when you are shifting this, Chapandi, when you are shifting this becomes the angle between the vector, right? Yes, this becomes the angle between the vector. Whatever it is. Chusko, andariki. If this angle is alpha, automatically this becomes 180 minus alpha. Ide kada? Yes. Are you understanding? Andariki, Chapandi. Yes. Okay. No. So this angle becomes 180 minus alpha. Ippudu cheppandi, the angle between the vector theta is 180 minus alpha. Ippudu substitute ra, RP sin theta ante R into P into sin of 180 minus theta. What is the value of sin of 180 minus alpha? What is sin 180 minus alpha? Sin alpha. Yes. So sir, it is simply equals to R into P into sin alpha. Ide kuda chuskondi. Hey, I am going to tell you the shortcut after this, okay? Can I say this is nothing but P into R into sin alpha? Rearrange chestunnaru ade. Nothing more than that. R sin alpha. Chusko. R ante enti ra? R is the distance of mass from axis of rotation. Ante this should be my distance R. All of you agreeing, not agreeing, cheppandi andariki. This, endukante this is my axis of rotation kada? Chusko. This is the axis of rotation and this is the distance R bar. Ante this distance should be R bar ra. This is after shifting. Okay? So if this R is there, alpha angle is here, R sin alpha ante opposite side kada? Yes. So this becomes R sin alpha. Shortcut chudandi ra. Shortcut. I have already given you the value of R sin alpha as 4 meters. R sin alpha is already 4 meters. P ante enti ra? Mass into speed. Mass is 10 kg. Speed enta, sir? 4. Ante 160. Ade. So this is your angular momentum L bar. 160. Direction ekkadi, sir? Where is the direction, sir? R bar cross P bar ante into the plane of the paper ante 160 times minus k cap. Minus 160 k cap kuda antaru. You understand now? Shortcut ra. What is the shortcut? Shortcut is this. Chusko. Whenever you are given to find the angular momentum L bar, meeku okada general formula is this ra. This is the general formula. Ledante you can simply say, sir, L is equals to R perpendicular into P. Leda you can simply say L is equals to R into P perpendicular ra. What are the perpendiculars? పర్పెండిక్యులర్ అంటే సైన్ కన్మని హౌ కెన్ యూ సే కాస్ ఆర్ ఏబీ సైన్ థీటా కదా, క్రాస్ ప్రొడక్ట్, ఇట్స్ అ క్రాస్ ప్రొడక్ట్ రైట్. ఇప్పుడు చూడండి రా, దీస్ ఫార్ములాస్ ఆర్ యూస్ఫుల్ ఫార్ అ లీనియర్ మోషన్. లీనియర్ మోషన్ అంటే ఏంటి? ఇన్స్టంటేనియస్ యాక్సిస్ ఆఫ్ రొటేషన్ ఇస్ గివెన్ and then you can consider it as yes r into mv, not like that. You can simply say r perpendicular into p లేదా r into p perpendicular. What are this sir? I'll tell you. చూసుకో, if this is your mass, okay, ఇదే మీ mass m ఉంటే it is moving downwards రా, speed v అదే కదా, yes, and your axis of rotation is somewhere here. అందరికి చూడండి, ఇది చాలా ఇంపార్టెంట్, okay, it's very important. Your axis of rotation is somewhere here రా. So this is మీ axis of rotation. మరి ఏం చేయాలి ఇప్పుడు? You do one thing, you extend this complete line ra, complete line extend cheyandi, complete line extend cheyandi. So now I am extending this complete line something like this. Chusko, this is my extension, ide kada, step number 1. Dan tarvata you directly take r perpendicular kada, r perpendicular ante perpendicular distance of axis of rotation. Perpendicular distance ante enti ra, this would become my r perpendicular. Chusko, ఇదే కదా. సో దిస్ ఈజ్ యువర్ ఆర్ పర్పెండిక్యులర్. అందరికి అర్థమైంది? ఈవెన్ ఇఫ్ నాట్ గివెన్ ఎక్స్టెండ్ ద లైన్, డ్రాప్ ద పర్పెండిక్యులర్ అండ్ దట్స్ ఇట్. ఓకే, ఎస్. సో యూ కెన్ సింప్లీ సే ఇదే మీ ఆర్ పర్పెండిక్యులర్, యూ హ్యావ్ ద మొమెంటమ్, సో హియర్ సార్ ఇట్ ఈస్ సింప్లీ ఈక్వల్స్ టు ఎంవి ఆర్ పర్పెండిక్యులర్. అంతే కదా. నౌ వెన్ యూ సీ దిస్ క్వశ్చన్ మళ్ళీ ఒకసారి యూ విల్ అండర్స్టాండ్ ఇట్. ఓకే, యూ విల్ అండర్స్టాండ్. సీ ద సేమ్ క్వశ్చన్ రా, ఇదే మీ యాక్సిస్ ఆఫ్ రొటేషన్, ఇదే కదా, ఎస్. నౌ వాట్ టు డూ సార్? దిస్ ఈజ్ యువర్ మొమెంటమ్ లైన్, ఎక్స్టెండ్ ఇట్, ఎక్స్టెండ్ చేయి అండ్ డ్రాప్ అ పర్పెండిక్యులర్ ఫ్రమ్ యాక్సిస్ ఆఫ్ రొటేషన్. ఇదే మీ ఆర్ పర్పెండిక్యులర్ రా. హౌ మచ్? 4. మొమెంటమ్ ఎంత సార్? 10 into 4 అంటే 40. mv, p is 40 and r perpendicular is 4. షార్ట్ కట్, 40 into 4 is 160. ఓకే, నెక్స్ట్. లేదంటే you can also say L bar is equals to R into P perpendicular. P perpendicular అంటే ఏంటి రా చూసుకోండి. Let us say this is your axis of rotation. అందరికి ఇదే మీ axis of rotation ఉంటే your momentum is something like this. How should I say? Okay, so let us say this is your R bar. R bar directly given to you. Okay, ఇదే మీ R bar in the upward direction. కానీ the momentum of the particle is something like this. చూసుకోండి. So this is the momentum of the particle ra, mv. Understanding, your r bar is directly given to you upwards, but the momentum of the particle is in that direction. Mari em cheyali? mv ante p kada, yes. So you take the momentum that is perpendicular to r bar. Ela tiyali sir? How to take it sir? You draw the components of it. Ela draw cheyali? That's the question. The first component will be towards the right and the second component will be in the upward direction. Ide kada, ee angle theta iste you can simply say p cos theta and this component will be p sin theta. Ade kada, yes. R value enta icharu ra, r is r only, multiplied by p perpendicular ante p cos theta. Ide kada, yes. Ante r p cos theta. You understand, in general most of the times your L bar is equals to r bar cross p bar should be equals to rp sin theta according to the vector expansion formula kada. Kani ee case lo it will be rp cos theta. Endukante the theta is adjusted in such a way that instead of sin theta it is coming as cos theta. Are you understanding? It could be asked. Okay, it could be asked. Okay, perfect. So now let me again come back to the moment of inertia. Okay, we talked about kinetic energy kada. We talked about kinetic energy. Cheppandi. Kinetic energy can be given as half I omega squared. What about momentum sir? I into omega. Ide kada. So these are the two terminologies that we discussed. Andariki, are you understanding? Okay, so sir, I is what? I is m1 r1 squared plus m2 r2 squared plus m3 r3 squared. Ade, and so on and so forth. Ide kada. What is m1, m2, m3 sir? They are independent masses. And what is r1, r2, r3 sir? They are distance of the masses from axis of rotation. Okay. So sir, if I have this system, ante ee mass m1, here the mass is m2, here the mass is m3, here the mass is m4. Ide na axis of rotation unte distance r. Can I find moment of inertia? Yes, you can. కానీ కంటిన్యూస్ మాసెస్లో కంటిన్యూస్ మాసెస్ అంటే ఏంటిరా? రింగ్, డిస్క్, స్ఫియర్, సిలిండర్, కోన్, లామినా అంటే స్క్వేర్ ప్లేట్, triangular plate. Are you understanding? At the same time, you have different objects, okay? So you cannot calculate the moment of inertia. Kabatti, we just have to remember them, okay? So you just remember the formula. Andariki, moment of inertia. First of all, let us take shapes, ra. Then we will talk about their moment of inertia, okay? First we talk about shapes. Idi for continuous mass distribution kada? Yes. This is for continuous mass distribution. Chudandi, when you talk about moment of inertia, what did I say? What did I say? For a continuous mass distribution, ఎప్పుడైనా moment of inertia calculate చేయాలంటే you must know the axis of rotation. Without going to axis of rotation, if you want to calculate it, you will be stuck 100%, okay? 100%. Right? Okay, చూడండి. నీ ఫస్ట్ షేప్ అంటే your ring. చూసుకోండి. When you talk about ring, it must be rotating, ra. You cannot talk, hey, what is the moment of inertia of this pen? What is the moment of inertia of this pen? You can't say. Why? Because it's not moving. Are you understanding? Whenever you want the moment of inertia of an object, it must move in a circle. Understand? If you want the moment of inertia of this sheet, it must move in a circle. So if I'm just asking what is the moment of inertia, can't say. So sir, how can it move, sir? How can it move? It can move like this also, leda it can move like this also, leda it can move like this also, ra. Meeku teliyadu kada how is it moving? Ledante it can move like this also, or else it can also move like this, okay? Like this. So you must understand how the object is moving. Then and only then you can talk about the moment of inertia of that object. Endukante meeku axis of rotation, if you don't know it, you cannot comment anything of the moment of inertia. Moment of inertia ante you must have the axis of rotation. Ardhamaindi? Isha, did you understand that? Good. Ring unte, you again cannot say the moment of inertia until and unless I give you the axis of rotation. Meeku axis of rotation teluste, you can tell about the entire motion of that object. Are you understanding? So if the axis of rotation is this, చూసుకోండి, ఎప్పుడు I am writing the axis of rotation with a red color mark. This is my axis of rotation. Ante this. So if this is your axis of rotation, how should the ring move, re? Something like this. Are you understanding? Leda, it should move something like this, clockwise, anti-clockwise. But always remember, the motion is always perpendicular to the axis of rotation. Are you understanding, all of you? Okay? Right. So this is the direction of rotation of your ring. Omega is the angular speed, okay? In case low, if the mass of the ring is m and the radius is r, directly గుర్తుపెట్టుకోండి, your moment of inertia I is equals to m into r square. It is as if a single particle is moving, ra. Okay? It is as if a single particle is moving. I'm again telling you, if you don't know the shape, leda if you don't know the axis of rotation, you are not able to comment on the moment of inertia. Who is this Basar? Who is Basaraj, sir? Yes, mr square. Very good. Okay, next question, ra. Next question chudandi. If you have a disk, okay, oka disk unte, same ra, disk ante enti, it's a collection of rings kada. Yes, so this is your disk. The only difference is that your disk is a 2D shape. Hey, are you remembering something, Ray? This is how you mark your answers, kada? Bubbling the answers. Okay, this is the bubbling of answers. Okay, it continuously breaks my head. It's a disc. Okay. Okay. I'm sorry. Okay, I'm really sorry. Chuskondi. Disk ante mass is m, radius is r. What is the axis of rotation, sir? What is the axis of rotation ante? This ide me axis of rotation ra. I am drawing a simple dot ante it is perpendicular to the axis. Okay, chuskondi. Malli cheptunnanu. Okay. So your disk is rotating something like this. Chudandi. So your moment of inertia I will be equals to cheppandi half m r square. Okay. Next, your sphere. Sphere kuda rendu rakalu unnai. Okay. Shapes and your moment of inertia. Third is your sphere. Sphere ante solid sphere తీసుకోండి. First one is your solid sphere. Okay, solid sphere. Ippudu the biggest good news for you is in solid sphere the axis does not matter. Endukante sir it's a 3D symmetric figure. So however you change the axis, moment of inertia remains the same. Okay, so your solid sphere ante this ra. Understand it, okay? Understand. It is your sphere, okay? Solid sphere. Mass m, radius is r, sir. Whatever axis of rotation it is, moment of inertia remains the same. Okay? I'm not giving axis of rotation. Just remember the formula. I should be equals to 2 by 5 m r squared. Okay? But it should rotate. It should rotate. It should rotate. Moment of inertia is simply not defined for the objects which are at rest. I am telling a very complicated statement andariki, okay? But you will only understand when you know the concept in depth. Next, fourth one, hollow sphere. Ikkada kuda you don't have to specify about the axis of rotation. Okay? Hollow sphere unte, sir, your moment of inertia is 2 by 3 mr squared. Okay. Next, Parimala, the class duration will be a little longer, okay? It might be 1 AM or 2 AM, depending upon the situations. Because rotation is a little lengthy chapter. Next. Your cylinders, okay? Cylinders kuda rendu rakalu. Your shape and your moment of inertia. Chuskondi. Cylinders ante two types of cylinders are there. Your fifth shape is solid cylinder. Okay, solid cylinder. In case lo kuda you must understand the axis of rotation. You must understand the axis of rotation. Okay, so this is the solid sphere. Okay, idena solid sphere. I'm taking a little short length. Can you choose? This is my axis of rotation. I should draw it with a red color. Okay, this is the axis of rotation. And the sphere is rotating about it. Okay, the sphere is actually rotating about this axis of rotation. Choose one. So it is rotating something like this with an angular speed equals to omega. Ante kada? Yes. Tell me, what is the moment of inertia? Solid sphere unte, this must be pack. Are you understanding? Moment of inertia is again half mr squared. Like disc. Gurdunda? Disc. Same like disc. Hollow cylinder unte, sixth case. Hollow cylinder unte, this is the axis of rotation. Okay, rotating something like this. Finished. Now you can utilize this everything to find the kinetic energy and at the same time angular momentum. Okay, kinetic energy and angular momentum, both of them you can calculate it using the same formula. Now I am not going into the details of it endukante we have to move to the next topic. Next topic entante torque. Okay, next topic is torque, and perhaps that is yes, it is like a ring, so it must be mr square, right? Okay, yes. Next topic is gonna be torque. Chuskondi. This is perhaps one of the most interesting topic in your entire rotational dynamics. Okay, now I don't know how to simulate the things, but I'll try to keep it as realistic as possible. Chuskondi. Okay. Find it anywhere if you want. Chusko. In your rotational dynamics, chuskondi. Okay, when I have to, okay, when I have to talk about your rotational versus linear motion ra, okay, let me just give you the comparison ante enti ra, ide me rotational motion and this is your linear motion. Andariki these are the two types of motion ante kada. Yes, rotational lo whatever your moment of inertia ante I, whatever role your moment of inertia has in rotational motion, similar role is performed by the mass in linear motion. Are you understanding? Yes, very good Isha, very good. Okay, right. At the same time, when you talk about angular momentum, chepora, angular momentum in rotational motion, angular momentum ante enti sir? L bar. This gets converted into the linear momentum P bar. Are you understanding? But you understand these are the required basis. L bar ante R bar cross P bar. Ee formula lo P bar untundi ra. Ikkada kuda moment of inertia mr square ante m kuda untundi. Are you understanding? The only thing is you have to add the distance term extra. Ade. Okay, very good. Here when it comes to torque, cheppandi endariki linear motion lo force. Are you understanding? Ante enti ra? Let us talk about first law of Newton. What does Newton's first law say, sir? Sir, the object at rest remains at rest until and unless an unbalanced external force acts on it. Ide kada? Yes. So in linear motion, oka linear motion lo if this object is at rest ra, andariki chudandi. Okay, if this object is at rest in linear motion, to move ante enti, move it in a linear motion ante in a straight line, what do you need, sir? You need a force. Okay, you need a force. ఒకసారి ఫోర్స్ ఎక్సర్ట్ చేస్తే దిస్ ఆబ్జెక్ట్ విల్ స్టార్ట్ మూవింగ్. అదే కదా, అంటే లీనియర్ మోషన్ అవుతుంది. వెన్ ఇట్ ఇస్ కమింగ్ టు ద రొటేషనల్ మోషన్, ఈ రొటేషనల్ మోషన్ పై యూ కెన్ సింప్లీ సే సార్ దిస్ ఈజ్ మై రాడ్. ఇప్పుడు టు మూవ్ దిస్ రాడ్ అంటే టు మూవ్ ఇట్ ఇన్ అ లైన్ రా, లీనియర్ మోషన్లో యూ నీడ్ అ ఫోర్స్. So this is the force, sir. I am pushing it, it is moving. Okay, it's moving. You are pushing it, it's moving. Ante kada? Yes. So this is your rod. You are pushing it, and this rod is moving. Ade. Are you understanding? But in rotational motion, pure rotational motion lo, we don't want this rod to move. Ante I want this rod to rotate now. Ee rod ni rotate cheyadaniki I don't need force. I need torque. Chudandi. So if this is your hinge point ra, whenever you are talking about torque, hey, are you understanding? Whenever you are talking about torque, you must know about the axis of rotation. Chuskondi. It is chala important ra. Axis of rotation keeps the huge significance in rotational dynamics. If you don't give significance to axis of rotation, your entire rotation will be gone. Okay? So if this is the axis of rotation, చూసుకోండి, if this is the axis of rotation, I want to apply the force, చూసుకోండి. So it is at the hinge point, I am applying the force somewhere here, చూసుకోండి అందరికి, I am applying the force here, you apply, okay, you apply the force, rotation motion is happening, అంతే కదా. Yes, turning effect కూడా అంటారు, right, perfect. So this is your force, you are applying at some distance, చూసుకో, this is the hinge point ra, this is the hinge point, okay, this is the hinge point, and you are applying force here, అంటే this much distance you are leaving ra, leaving, చూసుకో, are you understanding? Okay, yes. So sir, what is torque ante, if you have a rod, we are taking the best and the easiest example, rod example ra. Let us say the length of the rod is capital L. మళ్ళీ చెప్తున్నాను, మళ్ళీ చూసుకోండి. To talk about torque, the most important thing you require is the axis of rotation. Where is the axis of rotation, sir? Where is the axis of rotation? Where is the axis of rotation? Yeah, some nonsense things are going on in comment section, okay? చూసుకోండి, this is the axis of rotation, అంతే కదా, ఇదే మీ axis of rotation రా. Now onwards you remember this cross should be given you as the axis of rotation, okay, perfect. now let us say you are applying force right here, you are applying the force right here, F. Do you think it will rotate? లేదండి. Okay, it does not rotate. Why? Because you are applying the force exactly on the axis of rotation. It does not rotate. I hope. It will not rotate because you are applying the force exactly on the axis of rotation. Okay, what will happen, sir, if I shift it? What will happen if I shift my force? అంటే ఎప్పుడు I am applying it here రా, చూసుకో, there is a tendency to move, okay, there is a tendency to move. What will happen if I shift it more రా, మళ్ళీ shift చేస్తే here the rod has the maximum tendency to move. అంటే ఏంటిరా, even if you apply less force here it will move, కానీ if you apply more force here it will not move. Understanding? If you are applying too much force here it will not move, but if you are applying less force here it will move. Are you understanding? అంటే based on this condition the scientists they have discovered a terminology. ఈ టర్మినాలజీని దే ఆర్ కాలింగ్ ఇట్ యాజ్ టార్క్ రా, టార్క్ అంటే ఏంటి రా, చూసుకో. ఇఫ్ యూ అప్లై అంటే నా ప్రైమరీ గోల్ ఏంటంటే ఐ హ్యావ్ టు మూవ్ దిస్ రాడ్, ఇదే కదా, ఎస్. సో ఐ హ్యావ్ 2 different స్టూడెంట్స్ రా. ఫస్ట్ స్టూడెంట్ ఇస్ పుషింగ్ హియర్, హీ ఈస్ అప్లైయింగ్ 10 newtons ఆఫ్ ఫోర్స్, ఓకే, చూసుకో, హీ ఈస్ అప్లైయింగ్ 10 Newton ఫోర్స్, మూవింగ్, ఈజీలీ మూవింగ్. సెకండ్ అప్లై పుషింగ్ హియర్ రా, హీ ఈస్ అప్లైయింగ్ F is equals to 20 Newton. Third student is pushing here, he is applying F is equals to 60 Newton ra. Okay, here. But when the observation was done, it was found out that all of them they are creating the same rotating effect. Okay? All of them they are creating the same rotating effect. Are you understanding? The same rotating effect. Ante enti ra? You ask this rod, it is telling, sir, he applied the force on me, I am happy because I am rotating. Same happiness I got here also, కానీ forces were different. ఎందుకు different forces, sir? Why different forces are required? ఎందుకంటే the distances are different రా, చూసుకోండి. Are you understanding? So రెండు factors contribute చేస్తున్నాయి. The first one is your force and the second one is your distance. Based on these 2 factors, they have devised a terminology ra. No. Gonad, we are not talking about friction now, okay? Don't make it complicated. They devised a terminology, they said a torque is tau. It is a letter, okay? Alpha, beta, gamma, delta, epsilon, pi, tau, okay? Okay, tau. Yeah. So tau bar is equals to r bar cross f bar. Arey, r bar cross f bar, something similar formula ra. What is the formula? Angular momentum, sir. Angular momentum lo, what did we discuss, sir? R bar cross p bar. Can I click something? Sir, r bar cross p bar is my angular momentum. Rotational lo angular momentum unte, linear lo it gets converted into linear momentum kada. Again, I have to compare ra. Chusko. This is your angular momentum, this is your linear momentum. Ade kada? Yes. This is your torque, this is your force. Ide me linear momentum, ide me force. Do you have any relation between momentum and force? Any relation between momentum and force? Newton's second law of motion. Force is rate of change of momentum. Right, sir. So Newton's second law says force is rate of change of momentum. Linear lo kada, kani rotation lo vaste momentum gets the place replaced by angular momentum ra. In rotation lo vaste your momentum will be replaced by angular momentum dl by dt, and your force will get replaced by your torque. Are you understanding? Yes, sir. L bar ante enti, sir? Sir, d by dt of L bar ante d by dt of r bar cross p bar. Ide kada? Yes. d by dt of r bar cross p bar ante torque ra. R bar is a constant quantity. You remember, we usually take R bar as constant. R bar ni variable tisi, you can go into the advancements, but not required for you. JEE Advanced, Olympiad, those people, those idiots, they do something, okay? For us, we will keep R bar constant. R bar constant, you can take out of the differentiation symbol, kada? Yes. So, sir, R bar cross d by dt of p bar ra. P bar ante enti ra? P bar ante mv bar. Yeah. Yes, sir. Is equals to torque, sir. P bar ante r bar cross d by dt of m into v bar, sir. It is equals to torque. Hey, m also ra. We are going to take it constant. Mass variable unte, it goes to variable mass problems. Adi kuda JEE Advanced valla Olympiads. They are idiots. They will be doing such questions. For us, mass is constant ante idi kuda baitiki teeskura. Okay, what you are left with now? You are left with r bar cross m into d by dt of v bar is equals to torque. d by dt of v bar ra. d by dt of v bar ra. d by dt of v bar ante dv by dt ante acceleration, sir. R bar cross m into a bar is tau bar. Hey, m into a bar ante enti ra? M into a bar ra. Force. So, sir, R bar cross F bar is equals to torque. Whatever you can remember, you remember. Okay, this is known as Newton's second law in rotation. Okay, Newton's second law in rotation. What is Newton's second law in rotation? Chusko. First thing, your L bar is equals to R bar cross P bar. Dan tarvata Newton's second law of rotation. Newton's second law of motion untundi kada? Yes. Ikkada kuda Newton's second law of rotation ante torque is nothing but the rate of change of momentum. From this formula, we get torque is equals to R bar cross F bar. Idi mottam gurtundali ra. Okay, all three of them. You must remember this. Okay, you must remember this. Very good. Andariki very good. Okay, right. Perfect. So, ippudu let us talk about torque ra. Torque. Okay, torque ante enti sir? So, ikkada nunchi I can simply say torque is equals to R bar cross F bar. Me exam lo there are different varieties of questions that are being actually asked from this topic. Let us take one by one all of the questions. Okay, first question is, choose directly numerical based question ra. ఓకే, క్వశ్చన్ నెంబర్ 1 తీసుకోండి. You should take only ra. You let it be, okay? Let's not complicate the question. Just torque calculate చేసుకోండి. అదే, I was going to give you the angular acceleration also by giving you the mass, but does not keep any significance. Okay, చూసుకో. Direct formula based question ఇదే, right? What is it coming, sir? What is it coming? Okay. Very good. Mohan Krishna. Very good for attempting the question. Okay? I don't know the answer, Kenny. That is the problem. Let us just shrink it a little so that we can make the space. A direct formula, tau is equals to r bar cross f bar. అదే కదా, r bar cross f bar అంటే ఏంటి సార్? వాల్యూస్ సబ్స్టిట్యూట్ చేసుకోండి. r bar అంటే పొజిషన్ వెక్టర్ అంటే i cap ప్లస్ 2j cap మైనస్ k cap క్రాస్ ఫోర్స్ చెప్పండి రా. ఫోర్స్ ఇస్ ఈక్వల్స్ టు 2i cap ప్లస్ 3j cap ప్లస్ 4k cap. ఇప్పుడు టు డూ ద క్రాస్ ప్రొడక్ట్ యూ నీడ్ అ డిటర్మినెంట్ సార్. i ఇట్ ఇస్ j ఇట్ ఇస్ k, అంతే కదా. యువర్ క్యాల్కులేషన్ మస్ట్ బి ఎక్స్ట్రీమ్లీ గుడ్, ఎక్సెప్షనలీ గుడ్ క్యాల్కులేషన్ ఉండాలి. ఓకే, ఎస్. ఓకే చెప్పండి. ijk అంటే 1 2 -1, ఎక్కడ వచ్చి 2 3 4 ఇదే కదా. ఎస్, డైరెక్ట్లీ రైట్ సార్. i cap ఇంటూ డూ ద క్రాస్ మల్టిప్లికేషన్. 8 - -3 అంటే 11 మైనస్ j cap ఇంటూ j cap into 4 minus minus 2 అంటే 6 ఇదే కదా ప్లస్ k cap into it is gone 3 minus 4 అంటే minus 1 ఇదే. సో your answer is 11 I cap minus 6 j cap minus k cap. ఇదే మీ టార్క్ రా. Is it the same? You can check wherever it's getting wrong. Okay, r bar cross f bar ante you first write r bar not f bar. 2 3 4 1 2 minus 1 will be wrong. Okay, first take r bar I cap, it is 8 minus minus 3 becomes 11. Very good. But minus j, it is 4 minus minus 2 becomes plus 2. 4 minus 2 is all these things. Your math should be good. Next. చూసుకోండి. We can talk about r tau is equals to r bar cross f bar. ఇదే కదా. Yes. So this could be reduced to 2 more simplifications. Okay, doing 2 more simplifications ra. First simplification could be something like this, sir. Tau bar is equals to r perpendicular into f. Ledante you can also say, sir, tau is equals to, not t ra, tau is equals to r into f perpendicular. These are the 2 golden formulas, I would say. Okay, golden formulas ra. Endukante these simplify our work so much. R perpendicular into f, r into f perpendicular, we have seen it somewhere ra. Where did we see? Oh sir, we talked about angular momentum, r bar cross p bar ante r perpendicular into p leda r into p perpendicular. Gurtunda? Hey, are you understanding or forgetting everything ra? This is the answer. Chuskondi. I would request you ra, don't do mistakes. Okay, nobody has given you the right answer. Nobody in the comment section has given me the right answer for the cross multiplication of the vectors. Are you understanding? మీ సిచ్యువేషన్ చూసుకోండి ఒక్కసారి and you think about the remaining మిగతా వాళ్ళకి సిచ్యువేషన్ రా. It is the same, similar to it. Understanding? Physics కోసం your maths must be very good. Very good అంటే if your target is to achieve 150 plus, you cannot achieve it with bad maths. Okay? Bad mathematics. No, you can't do that. Okay, anyways, let us go to the question ra. Original questions లేదు, concepts. Okay, concepts. చూసుకోండి. Let us take one more question. Let us take question. Okay, a rod is acted upon by a force as shown. Find the torque. Okay, find the torque. So ఇదే మీ రాడ్ రా. ఓకే, దిస్ ఈజ్ యువర్ హింజ్ పాయింట్ అంటే యాక్సిస్ ఆఫ్ రొటేషన్. ఇదే మీ యాక్సిస్ ఆఫ్ రొటేషన్. ఐఎమ్ గివింగ్ దిస్ ఆల్సో. ఓకే, నెక్స్ట్. ఇప్పుడు లెట్ us say this is your force. అందరికి how should I say? You understanding? Okay, I'll decrease it. Don't worry, I'll decrease the thickness. ఇప్పుడు let us say this angle is somewhere around 60 degrees. ఓకే, ఈ యాంగిల్ అంటే 60 degrees అండ్ ఫోర్స్కి వాల్యూ కూడా ఇస్తుంది. చూసుకోండి, ఫోర్స్కి వాల్యూ F is equals to let us say 60 Newton of force is there రా. అండ్ దిస్ లెంత్, ఈ మొత్తం లెంత్ అంటే L is equals to 60 meters. 60 60 60 6 6 6 6 6 6. Rod is there, force is there. Ante this is my rod. Okay, should I tell you? Okay, this is my rod. Chuskondi, this is my rod. This is hinge point. Ide na rod ra. I am applying force something like this. Okay, I am applying force something like this. Kindagi, directly kindagi act chestunna. Chuskondi, the force is like this and the rod is moving. Okay, you understand, there are some concepts that a teacher can never teach you. Are you understanding? what is the concept, sir? Sir, the force of gravity acts at what, ra? The force of gravity acts at geometrical center లేదా center of mass of the object. అంతే కదా. No, go not no. Answer is not correct. Not 180. It's not 180. Okay. Choose. What did I say? I told you that torque is either r perpendicular into f లేదా r into f perpendicular. You can take whatever you want. R perpendicular into f use చేయాలంటే r perpendicular into f అంటే ఏంటిరా? You have to take perpendicular distance of force from axis of rotation. Understanding? So sir, this is my force. I have to take its perpendicular distance. ఎక్కడ నుంచి రా? Axis of rotation నుంచి. అంటే you extend it. You extend this force. అందరికి you extend this force. This is the line of my force. This is how we do it. I told you in momentum also. You go back to the video and you just see it. How do we take the perpendicular distances? So ఇదే నా force కి line రా. ఓకే, ఎక్కడ నుంచి యూ డైరెక్ట్లీ డ్రాప్ అ పర్పెండిక్యులర్. ఎలా డ్రాప్ చేయాలి సార్? యాక్సిస్ ఆఫ్ రొటేషన్ నుంచి ఒక పర్పెండిక్యులర్ డ్రాప్ చేయండి. దిస్ బికమ్స్ యువర్ ఆర్ పర్పెండిక్యులర్. అదే కదా. సో ఇఫ్ దిస్ లెంత్ ఇస్ 60 meters, ఈ యాంగిల్ 60 degree ఉంటే ఆపోజిట్ సైడ్ ఆఫ్ 60 degree. అదే కదా. వాట్ ఈస్ ద వాల్యూ సార్? ఎల్ సైన్ 60. ఆపోజిట్ సైడ్ ఉంటే ఎల్ ఇంటూ సైన్ 60. ఎల్ వాల్యూ ఎంత? ఎల్ ఈజ్ 60 meters మల్టీప్లైడ్ బై సైన్ 60 ఈజ్ √3/2. ఇదే కదా. అంటే 30 into √3 meters. So this is your r perpendicular. అదే, you simply lift it, you shift it, మీ torque is equals to, చెప్పండి, r perpendicular is 30 √3 multiplied by మీ force is f అంటే 60. That means your answer is 1800 √3 Newton meter. Units also గుర్తుపెట్టుకోండి. If I am forgetting some unit, you make me realize, I will write the units also. The unit of torque is 1800. Varalakshmi, it's not 1700. 30 into 60 is 6 3s are 17. It might be your typing mistake. Okay, right, I understand. It might be your typing mistake. Okay. Next. Okay, so let us talk about one last question and then we will wind up with the torque, all these things. Okay, choose Kora. So this is your axis of rotation. అంటే this is my rod. అందరికి చూసుకోండి, ఇదే నా రాడ్ రా. ఓకే, లెట్ us go a little thick. సో ఇదే నా రాడ్ and this is my axis of rotation. Okay, are you understanding? Yes. ఎప్పుడు I am applying the force on this rod, something like this. సో ఇదే నా ఫోర్స్. అందరికి చూసుకోండి, this is my force. లెంత్ ఎంత సార్? సార్, లెంత్ ఆఫ్ ద రాడ్ L is equals to 50 meters. And let us say this angle is somewhere around 60 degrees. మళ్ళీ ఒకసారి. And this force F is equals to 100 Newton. నాకు టార్క్ కావాలిరా. So this is my axis of rotation. అంటే this rod is moving something like this. Okay, are you understanding? Yes, RF sin theta, right? RF sin theta. కానీ the angle should be the angle between R and F. You understand? It's a very good question actually. Okay, Mohan Krishna, it's a very good question. Whatever you have asked. Kani, choose. Your theta is the angle between R bar and F bar. Where is your R bar? Ide mi R bar. Ide kada. Mohan Krishna, choose. This is R bar. And what is F bar? Ide F bar. Choose. So your R bar, I am shifting it somewhere here. Okay, I am shifting your R bar. And where is your F bar? Your F bar is vertically downwards kada. Yes. So this is your F bar. And this is your R bar. Are you understanding R bar and F bar values? Are you understanding? You try to calculate the angle between them. Okay, now what I am doing is I am shifting this R bar. Now first question is 60 degree. My first question to you is this 60 degree angle between R bar and F bar? No. No. Why? Because you see in my vector video, that's why I am telling to you, nobody tells you. No teacher tells you what I tell you. Okay, angle between the vector, it is only counted when the vectors are either head to head లేదా tail to tail. Okay, head to head లేదా tail to tail. You choose, you see it. Okay, when I am shifting this vector here, you can shift it. You can shift it. I have told you that also. Okay, you shift the first vector, you shift the second vector. Now you tell me 60 degree was here kada. Yes, so this was your angle 60 degrees andariki. But this is not the angle between the vectors. Mari em cheyali? You shift the vectors once again. How to shift it, sir? Now I am shifting this vector something like this. Choose if you can understand it. You see, this is a tail of the first vector. This is the tail of the second vector. Now they are coinciding. Ippudu, if I was talking about my original line, this was my original line, this was coming as 60, kani my original angle is 120 degrees. Chuskondi, straight line untundi kada, 60, 120. So r bar cross f bar ante rf sin theta, kani the value of theta is 120 degrees andariki. It's not 60 degrees, okay? Sin 120 degrees. Understanding? But coincidentally, that is also equals to 60 degrees. Right? Yes. I've just told you to have some idea, nothing other than just cheppandi. You can tell me here, where is your r bar? You must be good with r bar. R bar ante starting from your axis of rotation and the last point should be the point of application of force. 1 am. Pavani, the class will be finishing at 1 am. 1 am, 2 am, whatever it may be, okay? I don't know when the chapter ends. If it is ending now, we will end it now only, okay? If it ends at 2 pm, 2 am, we will end at 2 am. If it ends at 6 am, we will end at 6 am. Okay, this is a chapter that is at the end of your mechanics. See, chapter tarvata, there is a single chapter left, 2 more chapters left from your mechanics. First one is your fluid mechanics. Ade kuda chala important chapter. And the second one is your properties of solids. Properties of solids will take it tomorrow, and tomorrow itself our entire mechanics is completed. Tomorrow, day after tomorrow, okay? Tomorrow we will take 2 chapters. Hey, no answer, no problem, go ahead. Your efforts are giving me energy. If you are hitting efforts, at least you are writing the questions, that's more than sitting, sleeping and attending the class on mobile. Try. Okay. So what can we say, sir? Torque has 2 formulas, r perpendicular into f లేదా r into f perpendicular. ఈ రెండు నుంచి ఏదైనా యూస్ చేయొచ్చు, okay? You can use whatever you want. You can convert this f perpendicular into r perpendicular లేదా r perpendicular to f perpendicular. It is always up to you how to go. Choose. For me, it seems this is my force kada. I can resolve this force. Can you resolve? Yes, you can resolve. Where is the first component of the force? Sir, towards the right. Ide. And what is the second component of the force? Towards the upper position. Ide. This is my F1. Leda, this is my F2. Ade. Ide kada? Yes. So these are the components. So which formula will be easier to use? R perpendicular F leda R into F perpendicular. R is fixed. I have fixed R kada. So out of these 2 components, I can take perpendicular component to r bar. R bar horizontal untundi, f bar is in the vertical direction. Chusko. So I can simply say, sir, I can simply shift everything. Okay, I am going to shift everything now. Okay, I am shifting this whole process here. In physics you can shift. You can shift the vectors. That is the biggest plus point you have when it comes to vectors. Okay, very good. Now values cheppandi ra. If this angle is 60 degree with the horizontal, if the angle with the horizontal is 60 degrees, cheppandi andariki. Ee angle 60 unte, what is this angle, sir? Idi kuda 60. How? Alternate angles. Telusa? Parallel lines ra, transversal, alternate angles. Okay, idi kuda 60 ante, this 100, it becomes f cos 60. Ade kada? And this becomes f sin 60. Ide. So which is your perpendicular force? It is not perpendicular. Choose. Why? Because, sir, your radius vector r bar is something like this. Ide me r bar ra. Ide me r bar. Okay, this is your r bar. This is your r bar. Okay. Your f cos 60 is parallel to r bar and your f sin 60, it is perpendicular to r bar. Ide kada? Yes. So you can directly write the formula. What formula, sir? What formula you can write, sir? Torque is equals to r into f perpendicular. Ante enti ra? Radius enta undi? 50 into force perpendicular into, sir, f sin 60 ante f value enta icharu question lo. Your force value is 100 Newton kada? Yes. So 100 into sin 60 is root 3/2. Ade. So it is equals to this is your torque. Are you understanding? You must be exceptionally good at finding the torques. Okay, you must be exceptionally good in finding the torques. Next, తీసుకోండి. If you want one more question, I'll take it. Okay, if you want one more, okay, I'm giving you 2 questions, and then I'll give you 5 minutes break. You tell me the answers. Okay, what formula to use and how to calculate. This is my rod. Okay, ఇదే నా hinge point అందరికి. Let us say the length of the rod is 100 meters. All of you, మొత్తం చూసుకోండి. And this is my force. ఇదే నా force రా. Okay, let us say F is equals to మళ్ళీ 100 Newton. కానీ this distance has been given to you. D is equals to 20 meters. Okay, question is find the torque. In this question, I'll say this is the force. Okay. ఇదే నా particle, let us say mass is equals to 10 kgs అందరికి. Now all the times we can't take rod కదా. Yes. And this is my axis of rotation అందరికి. Axis of rotation. అంతే కదా. Yes. Can you join it? 100 meters. Okay. And this line, ante this distance, it is making an angle of 60 degrees. Later you can take 30 degrees. Okay, 30 degrees with the vertical. Ikkada kuda question is find the torque. I'm just giving you 5 minutes torque time 5 minutes time. Cheppandi torque ki values cheppandi. Whatever you can take, whatever you want to take, you can take. Okay, theta value, you want theta here. Oh, very good, very good, thank you so much. Hey, go not. I'm sorry. చెప్పండి. All of you like the video, ra. Okay, all of you. ఎందుకంటే students are not liking the video, they are not appreciating. Gonat, your answer is a little correct. Can I want you to understand the concept? Okay, what is R bar, Gonat? In the expression torque is equals to R bar cross F bar. What is R bar? Okay, what is R bar? Hi, Anil. No. No, Gonat, R bar is not 20. Ade. That's what I've told you. What is R bar? And R bar is the distance the position vector of the application from. That's sufficient, I think. So I need not give you more information. Very good. Mohana Krishna, very good. Okay, very good. I want the second answer from you, Mohan Krishna. Chepo. Very good, very good. Actually, very good. Okay, clap for yourself, Ram. No. 1000 root 3 is wrong. Yes, Mohan Krishna, correct. Perfect. Gonad, perfect. Right. All the answers are correct. Chusko. So, in case lo, you have only two formulas. See, other than that, you are direct ready to use formula R bar cross F bar ante, the first variety that they can give you is R bar ki vector form ante 2i plus 3j plus 4 ki. F bar kuda vector form ante I plus j plus ki. You have to do the cross product. That's done. Everything clear. Okay? Yes. Okay. The second form is you have torque is equals to R perpendicular into F leda R into F perpendicular. Ide kada? Yes. Okay. Right. Chusko. So here when it comes to force F, you can resolve kada. So resolve chesina tarvata you can take the perpendicular force and multiply directly with the R bar. Ade kada? Yes. So you resolve it. Resolve chesina tarvata this would be lines ink is getting same kada. I want to change it. Okay. So this is your first component of force and ide me second component of force ra. Chuskondi. Angle 30 degree ante this angle automatically comes out to be 60 degrees. This force is F ante 100. This is adjacent to 60 kada. So it becomes F cos 60 and this becomes F sin 60. Right? Yes. What is the formula, sir? Perpendicular radius kavali ante this is useless for me ra. I'll only say F cos 60 ante force inta sir 100 into cos 60 is half ante 50 Newton of force is there. Okay sir, R perpendicular, sorry, not R perpendicular, F perpendicular ochindi ra. F perpendicular ante 50 Newton ochindi. What about R now? R ante distance of point of application of force from axis of rotation. Ide me axis of rotation and point of application of force is here kada. You are applying force like this. Ante this distance will be your R ra. Total length 100. Idi 20 and this automatically comes out to be 80 meters. Ade kada? Yes. So your F perpendicular is 50, your R is 80. Torque is equals to R into F perpendicular 80 into 50 ante 4000 units kuda kavalira. Very good. Okay, this is your torque. No, it should not be 5000. Yeah, in this case it's 5000. Okay, in case low it's 5000. Cheppandi. So how do you do, sir? In case low, your F is already given to you. You can resolve it kuda. You can also resolve this force in two components. Your first component of force will be here and your second component of force will be here. If you want to resolve the force, you can resolve the force. Kani, for me, it is easier to resolve the R bar ra. Chusko. This is your axis of rotation kada. Yes. So ikkada nunchi you join this and this becomes your R bar ra. Chusko. Are you understanding? Yes. Now you have to take perpendicular r until you extend this force line andariki and take the perpendicular distance. Ade, this becomes your r perpendicular. Ide kada? Yes. So if it's r bar, your components will be working here. Chusko. This is the first component and this becomes your second component. Gonat, very good. Okay. At the same time, Mohan Krishna, very good. Very good. Okay. You clap for yourself because these are very good questions. Very good questions. Okay. Chusko. So if this angle is 30 degree, it automatically comes to be 60 degrees. Okasari, you know this length kada, so you resolve. This comes out to be r into cos theta. Cos theta ante cos 60. This becomes r into sin theta ante sin 60. Choose idena r perpendicular kada, so this becomes useless for me. You only use this one. Choose r value anta, r is 100 into cos 60 is half kada. So 100 into half is 50 meters only. Your force is 1000 Newton. Your r perpendicular is 50 Newton and torque is equals to r perpendicular into f. 50 into 100 and 5000 Newton meter. Very good. Okay. Very good. Very good. Very good. Right? Perfect. Okay. 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 Now, as I said you, most of the teachers, they will not give you the information. Chuskondi. I am asking you a question that consists of 3 different chapters, 3 different concepts. Chusko. This is my rod, andariki. Sir, this is getting boring kada. Same questions. No, it's not same. It's not same. Little change is there. Okay, little change is there. Chuskondi, andariki. Okay. So this is your axis of rotation, andariki. I have hinged it like this. Chusko. Your length of the rod L is equals to, andariki, the length of the rod L is equals to 10 meters. Mass of the rod M is equals to, let us say, 100 kgs. Ade kada? Yes. Emaitadi sir? What will happen, sir? What will happen? Koncham samayam tarvata, this rod will fall down. Ade kada? It will fall down, andariki. This rod will fall down. Kani instance low, it is making an angle of, what should I give you the angle? What is the angle this rod is making? 60 degrees. Okay? 60 degrees with the horizontal. Question is, find the total torque on the rod. Torque is changing kada? Yes. Find the total torque on the rod. Cheppandi andariki. No, Gunat, you are perfectly alright. If you are taking sin 30 instead of cos 60, it is perfect. Okay, perfect. It just depends on the angle. Now, this rod is falling down. Ante kada? Choose something like this. It is something like this. Okay, this rod is here. Now if I release, it is falling down. The question is, why is it falling? Why is the rod falling, andariki? Mohan Krishna. Okay. Little. Rest everything is correct. Please check. Cross check. Okay, cross check. Yeah, I'm live, okay? I'm live, ra. R is not more. I think Tanuja, no, it's not 5000. No, go not. I have not got correct answer till now. No, 5000 is wrong. 5000 ante wrong. Gonat, your half concept is right. Kani calculation lo konjam mistake undi, okay? You just see your calculation once. Just see your calculation once. Okay, Varalakshmi, your concept is right. Kani, I want the answer right. Right answer. I want the right answer. Mohana Krishna, I am expecting from you. Okay, I am expecting from you actually. Okay, choose. Perfect. Sir, this rod is falling down. Endugu, why? Why is it falling down, Ra? Cheppandi andariki. Why is it falling down? It was here, released, falling down. Why is it falling, sir? Because of gravity. Because of gravity. Ardhamaindi. Okay. Because of gravity is it falling down. Perfect. Okay, till this point you be with me. It is falling down because of gravity, ante kada? Yes. Where does the gravitational force act? I have told you in the center of mass. At the same time, very good, Gonat, very good, very good. At the same time, in gravitation I have told you the gravitational force acts on the center of mass of the system. Okay? Center of mass ante this. Here is the center of mass of the rod. Exactly at the center, Ra. Ade. Are you understanding? Yes. What is the gravitational force, Ra? mg. mg kada? Yes. The gravitational force is always mg. M value enta, sir? mg ante m is 100, g is 10. Hey, m is 100, g is 10. Ante mg value 1000 ochindi andariki. 1000 Newton of force acting at the center of the rod. Ide kada? Yes. Naku torque kavalante, can I say, sir, torque is equals to r perpendicular into f leda r into f perpendicular. I already have f, Ra. I already have f. Naku r perpendicular kavali. What is r? Distance of point of application from axis of rotation. Ante this becomes your r perpendicular. Drop the perpendicular from the axis of rotation. This is your r perpendicular. Andariki ardhamaindi. So, sir, total length 100 ante this length comes out to be 50 meters. So, if it is 50 cos 60 degrees adjacent side kada, so 50 cos 60 ante 50 into half, Ra, cos 60 is half. That means 25 meters is the perpendicular distance. R perpendicular value ochindi, Ra, 25 meters. Force ante 1000, torque is equals to R perpendicular into F ante 25 into 1000 kada, that means 25,000 Newton meters. 2500 is not there, okay? 25,000. 25,000, okay? 25,000. 25,000, Ra. Vaishnavi, if you are weak in physics, start from the basics. Basics ante from units and dimensions, basics of maths. Just start chesk. But again I will tell you the 2500, where are you saying 2500, sir? Are 3 zeros unnai kada? There are 3 zeros, okay? There are 3 zeros. Again 2500, 2500. mg, Ra, mg, mass 100 kgs untundi, Ra. G is 10, mg ante 1000, perpendicular distance is 25. 25 into 1000 becomes 25,000, not 2500. 25,000 and 2500 are same. Oh my goodness. Okay, perfect. Now let us move forward, okay? Let us move forward. Andariki. Let us move forward and see, sir, what did you get your angular momentum, Ra? Sir, angular momentum. Do you remember? I have told angular momentum is I into omega. Something like this, Ra. I into omega. Okay? I have told you angular momentum is I into omega. How many of you remember this? Before break. Okay? Before break, I have told you your angular momentum is I into omega. Andariki. Okay, sir. Mali, what did we say, sir? We said that torque is nothing but the rate of change of momentum, dl by dt. అదే కదా అంటే d by dt of I omega. అందరికి చూసుకోండి. Again, where did we write 10? Oh, sorry. Hey, I'm sorry. I'm really sorry. Okay, I'm really sorry. I thought this length as 100 meters. Okay, it's 10 meters. Very good. Gonat, I'm sorry. I'm sorry. Your answers are correct. Okay, this should be 5 meters, and this should be 5 into half. Ante it should be 2 meters. 2.5. Okay, 2.5 meters. Ante 2.5 into 1000. That means it must be 2500 Newton meter. I'm really sorry. Okay, andariki. I'm really sorry. I thought the length is 100, okay, but the length is 10 meters. 100 unte 50-50, it would have matched. Okay, anyways, చూసుకోండి here. Yeah. Start unit and dimension and watch my lectures first. Okay, go to the playlist. అక్కడ నుంచి start watching the lectures. Right? Then till the time you come here, I hope some things get cleared. చూసుకో. మళ్ళీ what did I say, sir? ఈ కేసులో again your moment of inertia and angular speeds are there. We will take moment of inertia as constant. Variable moment of inertia unte, it's not our game. Those idiots of JEE Advanced who are preparing, they'll deal with variable moment of inertia. Ede kada? Yes. Okay. So you can simply say, sir, torque is equals to d by dt of moment of inertia into angular speed omega. Ikkada nunchi chuskondi, you can take it out ra. So I into d by dt of omega, d by dt of omega is alpha ra, ade kada I alpha. So this is one of the most important formula. D by dt of omega is alpha. Ante your torque is equals to I into alpha. Chala important formula, chala important formula. Chuskondi ra. Let's talk about Atwood's machine. Gurtunda? Or directly should I go here, or let us take some questions. Andariki chusko. Did I talk about moment of inertia of rod ra? I did not talk about moment of inertia of rod. Yes, so here I'll give you. Okay, moment of inertia of rod. ikkada kuda na daggara two cases unnai ra. First case lo, this is my axis of rotation, okay, and rod is rotating something like this. Mass m, length l unte your I is equals to ml square by 3. Okay, next case lo chudandi andariki. Next case lo, if your axis of rotation is somewhere here, okay, this is your axis of rotation, ante at the center only, right? Exactly at the center. Ante your rod is rotating something like this, okay, something like this, right from the center. Okay, right, very good. Yes. So you can simply say, sir, your moment of inertia I is equals to m into L square upon 12. Okay, gurtu pettukondi, these are the important results. Mass m, length L ra ide. Okay, perfect. Now let us take a question andariki. Find the initial angular acceleration. Em formula use cheyali ra. I'll also give you hint, tau is equals to I into alpha. Ade. Okay, this is my rod andariki. This is the axis of rotation. Ante kada? Yes. And this is your force. It's a very simple question now. 100 Newton rod is there. Your mass of the rod is 10 kgs and the length of the rod is also equals to 10 meters. Cheppandi ippudu. I'll directly solve it, okay, because we don't have time. I don't want to waste much of the time. Directly solve chestam chuskondi. So you can simply say, sir, torque is equals to r bar cross f bar. Ide kada? Ante you can simply say r perpendicular into f leda r into f perpendicular. R into f perpendicular. Ikkada chudandi yaar, your r is here and we force is something like this, already perpendicular unnai kada. Yes, so you can simply say, sir, r bar cross f bar ante r perpendicular into f ante simply r into f. Ide kada? Your r enta ra 10, force enta sir 100 ante your torque is equals to 1000. Ide kada? Yes, 1000 Newton meter. Ippudu you have to use this very same formula, tau is equals to I into alpha. What is I, sir? Moment of inertia. What did I say? Hey, moment of inertia about the end is ml square by 3. Ade kada? Chusko. So moment of inertia is m into L square divided by 3 into alpha. Andariki chudandi. This is my torque ra. వాల్యూస్ పెట్టుకోండి అందరికి. సో టార్క్ ఇస్ 1000 ఇదే కదా, ఈజ్ ఈక్వల్స్ టు మాస్ ఎంతారా 10, L square అంటే length square is 100 divided by 3 into alpha. So 1000 is equals to 1000 by 3 into alpha. 1000 gone ra. 1 is equals to alpha by 3. Ekkada nunchi you can simply say 3 radian per second square. Units gurupetkondi. Unit keeps important. Your alpha is 3 radian per second square. Choose. Next. We were talking about Atwood's machine. Ide kada. It's one of the classic cases ra. Dan tarvata I'll jump to perpendicular and parallel axis theorem. Okay. Moment of inertia lo there are two theorems, parallel axis theorem, perpendicular axis theorem. We'll do that. Dan tarvata let us talk about conservation of angular momentum. Your translation plus rotational momentum. Ade your chapter will be completed. Okay. Chuskondi. Atwood's machine lo, when we discussed this concept in your Newton's laws of motion, when we discussed your Atwood's machine in Newton's laws of motion, what did we say re? What did we say? Cheppandi andariki. Mass m1 ekkada vachi the mass is m2 ide kada. Yes. What did we say? Ee case lo, if you remember Newton's laws of motion, okay, if you remember, that's why I'm telling to you, if you are watching someone else's Newton's laws, dan tarvata you are watching my rotational motion, you'll not understand anything. Okay, you'll not understand anything. I have told you that if the mass m2 is greater than m1, m2 greater than m1 unte, it will come down and it will go up. Ide kada. Kani, the pulley will not rotate. Are you understanding? It will go up and it will come down, but the pulley will not rotate. Ante enti sir, this string is simply sliding on the pulley ra. Ade, this pulley will not rotate. Are you understanding? This string will only slide on that pulley. Ante enti sir, if the string is sliding on the pulley, then and only then the tension is same ra, Tt. Are you understanding? Yes. What if the pulley is rotating? That happens in the real life scenario ra. Real life chudandi, when you see that pulley actually on the edges of the wall, the pulley actually rotates kada. Yes. So there needs some torque to rotate that pulley also. Ide kada. Yes. So a torque, how does it come? It comes from the tension. Chuskondi what I'm telling to you now. So if I have a pulley, okay, and these are the tensions ra. Tensions ante these are the strings. Mass m1 is here. Ikkada vachi your mass is m2. Andariki chudandi. The first thing that you can say is the tension is T1, ekkada vachi your tension is T2. Ide kada. Yes. Radius of the pulley is R. Andariki chudandi. Are you understanding? Pulley ante disc ra, disc. Pulley is a disc shape. How do you write the equation, sir? That there is a difference between tension. Chusko. This tension T2 is trying to rotate this pulley in the clockwise and T1 in the anti-clockwise. Ade kada. Ante opposite torques ra. Opposite torques unte, what you can write, sir? T torque of the tension 2 minus torque of the tension 1. Ide kada. Ide na net torque. It must be equals to I into alpha. Ade. You only remember this much ra. I am only telling you from a concept basis. Are you understanding? If the pulley is rotating ante, tensions will not be same. You understanding? There is calculation also, but I am not going into the much details. When you talk about Atwood's machine in Newton's laws of motion, tension same unte, the pulley will not rotate. If the pulley is rotating ante, there will be different tensions ra. Ade. This is the only thing that I want you to remember. Okay, very good. Andariki very good. Right. So ippudu let us talk about theorems. Rendu theorems unnai ra. First theorem is your parallel axis theorem. Chuskondi. I am taking everything in different sections. First we talk about moment of inertia, then we talk about angular momentum, then we talk about kinetic energy, then we talk about torque. Again we are coming back to moment of inertia. I am doing it deliberately so that you mix everything and you are habituated with the beginning to the end of the chapter. Chusko. Parallel axis theorem ante, there is a theorem. What does it say, sir? You just remember it. Okay, you just remember it. If I have a rod, andariki chuskondi. Leda, if I have, okay, let us say if I have a rod ra, okay, naku moment of inertia kavali. moment of inertia ante enti sir. Okay, what Mohan Krishna, what are you telling? What to elaborate? Mohan Krishna, what to elaborate? This question is what to elaborate? Parallel axis theorem ante enti ra chusko. Let us first cover it. Okay, if this is my rod, andariki chuskondi, if this is my rod, naku moment of inertia kavali. My statement is incomplete. Okay, Mohan Krishna, I'll elaborate it. I will elaborate it at the end of the lecture. Okay, I will elaborate it at the end of the lecture. Mostly 15, 20, half an hour tarvata I'll explain it. Okay, for the students who are not interested in it, NEET students, I'll not go for them. Okay, just go. Moment of inertia ante enti sir? Moment of inertia is incomplete because here we did not talk about the axis of rotation. Ante naku axis of rotation kavali, ide kada? Yes. So if I say this is my axis of rotation, andariki chuskondi, ee axis of rotation, it is passing through the center of mass, ide kada? Yes. In 100% questions, chuskora, in 100% of the questions, whatever it is given to you, in 100% of the questions, the moment of inertia, it will be given about the axis passing through the center of mass. It will be given. Okay, and they will ask you about the moment of inertia passing through any general point. This is I given. Okay, this is I given. What is it? It is given to you as ml square by 12. Ide kada? So it is given to you. Kani, let us say this distance is d ra, naku ee axis, I want this moment of inertia passing through that axis. Ante enti sir? Ante this is the center of the rod, ide kada? Yes. So your rod moves something like this ra, passing through this axis. Okay, something like this. But if you are talking about moment of inertia about this point, ante this becomes the axis of rotation and the motion happens something like this. Are you understanding? If this is your axis of rotation, a motion happens something like this. You just try to understand. If your axis of rotation is something like this, motion happens something like this. Hey, are you able to understand? Okay. Yes. Yeah. Let us see that. Mohan Krishna, I'll tell you. So, if you have to change your axis of rotation, you understand. Okay? Chudandi. If this was my axis of rotation, how is the rod moving? How is the rod moving? It is moving something like this. Ide kada? Yes, this is my motion. This point is not moving, this is fixed. But if I want the motion to be this axis, about this axis, axis change chesina kada, then your entire motion should change. See, this is my first motion, this is my second motion. Difference untundi kada. If you can spot the difference, well and good. If you can't spot the difference, you need a little sharper brain. Okay, kani difference untundi ra, 100% there is a difference. Okay, this was my initial axis, ide na final axis of rotation. Change chesina kada, so your moments of inertia will be changed. Ante for different axis of rotations, you have different moment of inertias. Are you understanding? Yes. So sir, how do we calculate moments of inertias for different axes? Chuskondira. Hey, this is my first format. Chusko. This was my center of the rod. I know the moment of inertia about the center. What is it? ml square by 12. Ade kada? Yes. Kani, if I want the moment of inertia about this point, I don't know it. But I know the distance. I know this distance d. So, moment of inertia about any point can be given as moment of inertia about center of mass plus total mass తీసుకోండిరా. ఈ total mass కి rod అంటే m into d square. d square అంటే ఏంటిరా? d is the distance from center of mass to the new axis of rotation. కానీ చూసుకోండి, అందరికీ చూసుకోండి, your both axis of rotation should be parallel కదా. It was here, I just shifted it parallel. కాబట్టి the name parallel axis theorem. Are you understanding? Yes. Go not yes. For different axis, moment of inertias will be there. So I'll ask you the same questions. Chuskondira. I'll give you one, I'll ask you one. Chusko. So this is my ring, okay? Ide na ring. this is the axis of rotation. And your ring is rotating something like this. So your moment of inertia about center of mass is m into r square. It is given kada. You know it. Mass m is there, radius r is there. Kani, now I am changing my entire motion. Ante, this is my axis of rotation. Choose. Sir, what if this is the axis of rotation? How will it move, sir? How will it move? Choose. If you are able to understand this or not. This is your ring kada. See, this is your ring ray. This is your ring. Okay, this is your ring. If the axis of rotation is this, how should I say? If the axis of rotation is this, your ring will move something like this. Yes. But when I change the axis of rotation to this point ray, your ring will move something like this. Can you understand about your axis of rotation? Are you understanding it? Yes. Ante enti sir? Ante ee case lo your motion will look something like this. Something like this. Are you understanding? Something like this. So then your moment of inertia will not be mr square. Okay? What should it be, sir? Use parallel axis theorem. What does it say, sir? Moment of inertia about the given axis is equals to moment of inertia about center of mass plus m into d squared. What is d? D is the distance between the given axis to the original axis. D is equals to r. In case lo d is r kada? Yes. Very good. Go not very good. So you can simply say moment of inertia is mr squared plus md squared ante mr squared. Ide kuda mr squared kada? Yes. So ippudu the new moment of inertia 2mr square. Are you understanding? This was a ring ra. Next, I'll give you find the moment of inertia of the ring. Ide na ring. Ippudu I am taking this as a ring. Okay? This is a ring. Andariki. Kani the axis of rotation is somewhere here. Okay? This is the axis of rotation. This is the center and this distance, it is equals to r by 3. Andariki cheppandi. R by 3 is the distance. Can you say it? Can you spot it? No. You can't. You can't. Okay? R by 3. Cheppandi. Mass m, radius r. Okay? The mass of the disc is m. Radius of the disc is r. Let us see how many of you can solve it. I don't have disc actually. I should have showed you. No. Okay. So, sir, when it is coming about center, naku center, I know the moment of inertia about center. So, moment of inertia about center of the disc is half mr squared. Kani naku random moment of inertia kavali. It is moment of inertia about center of mass plus md squared. Ide kada mass m, radius r unte your distance should be known ra. Okay? You should also know the distance. Cheppandi andariki. Moment of inertia about center is half mr squared. Ide kada? Yes. Plus mass is m ra. Distance enta ra? Distance cheppandi. R by 3 whole squared. Ide kada? Yes. So you can simply say, sir, half m r squared plus m r squared by 9. mr squared common తీసుకోండి. So mr squared common ra. You are left with 1 by 2 plus 1 by 9. Direct at this instances you must be good at work ra. So you can simply say, sir, 11 by 18 mr squared. So this is the moment of inertia. చూసుకోండి. But remember, గుర్తుపెట్టుకోండి. Very good. Mohan Krishna, very good. గుర్తుపెట్టుకోండి, ఈ cases లో both the axis of rotation they are parallel to each other. అంతే కదా? This is your first axis, this is your second axis. If this is your axis of rotation, అంటే disc is moving something like this. ఈ axis of rotation తీసి you say disc will move something like this, but the plane of the motion is the same. Understanding? Good. Very good. Okay? Very good. ఇప్పుడు let us talk about the second law. Second theorem ra, it is known as perpendicular axis theorem. అందరికి చూసుకోండి. Perpendicular axis theorem. Okay? And you remember, this theorem is mostly applicable for symmetric figures ra. Okay, chala mandi sari this theorem, it is usually applied for symmetric figures, not unsymmetric figures. Ante kada, symmetric figures unte you can easily apply it, ledante it's out of your scope. Are you understanding? Yes. So let us say your ring is something like this. Chuskondi. Leda, you can simply say, okay, this is your ring, okay? Ring. This is your ring ra. Ide me ring. Initial axis of rotation was something like this. Ante your ring was rotating something like this. Chuskondi. This is the rotation of your ring, angular speed omega. Ide kada? Yes. Moment of inertia, me andarki telusu mr square sir. No problem. Everything is good and fit and fine. Ante kada? Now, I am changing the moment of inertia, but not shifting it ra. Parallel kadu. The axis of rotation is something like this. Ante enti sir? What are you talking in now, sir? You understand. I don't know how to draw the ring ra. But I hope you understand it. I also don't have anything circular, okay? Chuskondi. I hope you are understanding. Okay, this is the ring. Okay, this is ring. This is ring. Ante initially axis of rotation was something like this. This was my initial axis of rotation. Chuskondi. This was my axis of rotation. Ante kada? Yes. So this was my axis of rotation for a ring ra. Chuskondi. So this was the motion. Ante this ring was moving something like this. Okay, something like this. But I am changing now to this one. Ippudu this is the axis of rotation. I hope you understand. Okay, this is the axis of rotation in this scenario. Now, how do you think the ring will move ra? It will move something like this. Can you visualize? Okay, can you visualize? Yes. Ante ee case lo the motion of the ring will happen something like this. Chuskondi. So this is my ring. Ide axis of rotation unte the ring will move something like this, omega. Are you understanding? Here it is moving something like this. The ring is moving vertically. Total motion change ayindi kada. Total motion has been changed. Ante axis of rotation has been changed. At the same time, the motion also has been changed. So ela ravali sir. Chusko. Ee case lo your axis of rotation was about z axis. Ide kada? Yes. Here your axis of rotation is about y axis. Chusko. So this is about z axis. Hey, this axis of rotation is about z axis kada? Yes. But here it is about y axis. Similarly, if I want the motion about this axis, ante something like this, okay, something like this, about x axis, motion is changing completely. Motion is changing completely. So, in cases lo, you have perpendicular axis theorem. What does it say, sir? Moment of inertia about z axis. Z axis ante any perpendicular direction. If you want to take it something like this, it must be moment of inertia about x axis plus moment of inertia about y axis. Ade. And I am again warning you, malli sari I am telling you, this theorem holds fruitful only for the symmetric objects. Understanding symmetric objects ante enti? Sphere. Very good application. Sphere is symmetric kada? Yes. So ide na sphere ra, chuskondi. If this is my sphere, ade kada? Yes. You take this axis, x axis, y axis, leda z axis as moment of inertia, okay? If z axis is the moment of inertia, sphere will rotate. X axis unte, sphere will rotate. Y axis unte, sphere will rotate. And it is taking same efforts. Same efforts kada? Yes. So you can simply say, sir, moment of inertia about x is equals to about y is equals to about z. Are you understanding? So in case lo, what you can say is, you can simply say moment of inertia about z axis equals to x axis about x axis plus y axis. Ante kada? Yes. Next, you are not asked much questions about it, okay? Just remember, good petkondi, only the formula you put it in mind. Perpendicular axis theorem nunchi chala takwa questions ra, okay? Yes. Next. Yeah, Gunat, you can say that. You can say that, okay? You can say that. Perpendicular axis theorem, it can be applied to 3D axis also, but there is a little twist, okay? You will have to add some extra terminologies, and it goes as a tensor now. It goes too much difficult. Just remember, okay? Sphere kosam, your moment of inertias are equal, okay? If you want to take the application, you can take it using a disk. Okay, if it's a disk, then you can find the moment of inertia about this axis. Are you understanding? Okay, right. Next, let us talk about your application of torque. Okay, yes. No, solid cone is not symmetric. That's what I am telling to you. You don't go in applying perpendicular axis theorem to 3D objects. I have taken sphere as a standard example, not all the times. Okay, not all the times. Actually, for unsymmetric figures, you have some adjustments to do. Okay, that goes beyond your subject. Not even for JEE. Okay, JEE mains advanced. It also does not have the unsymmetric moment of inertia cases. Okay, good. Chuskondi. Next. Let us compare linear scenarios with your rotational ante your angular scenarios. Okay, angular scenarios. Cheppandi. What did we say in linear scenarios, sir? Newton's first law of motion. Newton's laws gurinchi maatladutunna. Okay, in both the scenarios. Newton's first law says if the object is at rest, remains at rest until and unless an unbalanced external force acts on it. Ekkada kuda the same thing. Object rest, remains rest until and unless unbalanced external torque acts on it. Ide kada? Yes. Second law of Newton, what does it say, sir? Net external force is equals to total mass into acceleration of center of mass. Ide kada? Yes. Ekkada kuda, what did we say, sir? Net torque on the system is net moment of inertia into angular acceleration. Angular acceleration of what, sir? Angular acceleration of what, sir? Of what, sir? Okay, cheppandi. So what can I say? Chuskondi. If your net external force is equals to 0, are you understanding? Me net external force 0 unte, I told you in the center of mass chapter. What did I say? If the net external force is 0, acceleration of center of mass kuda 0. Ade kada? So center of mass acceleration 0 unte, velocity of center of mass remains the same. Ante momentum remains the same. Ide kada? Yes. So sir, initial momentum must be equals to final momentum. Are you understanding? Yes. Ekkada kuda the same thing. If your net torque is equals to 0, are you understanding? If your external torque is 0, ante your initial angular momentum must be equal to the final angular momentum. Are you understanding? Yes. So your initial angular momentum is your final angular momentum. You understand? In case lo your center of mass keeps significance, and in case lo your axis of rotation keeps the significance. Okay, your axis of rotation keeps the significance. Ante enti, sir? The acceleration of center of mass becomes 0. Here the angular acceleration of the object about the axis of rotation becomes 0. Understanding? Ante if this rod is moving about this axis of rotation, okay, there is no external torque, ante about this axis of rotation only the initial and the final angular momentum remains the same. We call it as conservation. Okay, we call it conservation of angular momentum. Okay, we call it conservation of angular momentum. Kani, when is it valid? It is only valid in case where the external torque is 0. Okay, very good. Okay, it is only valid when the external torque is 0. The best examples are chuskondi. I don't know if you have seen these questions or not. Can we do it? Let me try. Okay, let me try. Kani, I don't have heavier objects. Okay, I don't have heavier objects. Same time, it has a huge resistance. Just I don't know if you have seen those experiments or not. there is a guy, okay, there is a guy sitting on a round chair. He has hold 2 dumbbells in his hands, okay. Rendu dumbbells unnayira. He is rotating, okay, he is rotating about the chair. Koncham samayam tarvata what does he do? He brings those dumbbell back and his speed of rotation increases. Ante kada? Yes. Do you think any external person has given torque? No. What did he do? He brought them together. Ante internal forces, ante internal torque, whatever it is, it's internal system, okay. Forces is internal. Internal forces unte his initial angular acceleration must be equals to final. Ante angular acceleration is I omega, ante kada? I1 omega must be equals to I2 omega 2. Chuskondi. If your I decreases, omega should increase. I ante entira mr square. I lo there is mass also, there is distance also. So if distance is more, I is more. If distance is reduced, ante he is bringing back hands back kada. So he is bringing his hands back, ante he is decreasing the distance. Distance decrease I, the moment of inertia decreases. To maintain the momentum, omega should increase. Ade. Perfect. Okay. So I1 omega 1 must be equals to I2 omega 2. When ra, if net external torque is equals to 0, you understand. Torque and force are 2 different things. Ante kada? Torque and force are 2 different things ra. Net torque can be 0, but net force cannot be 0. Are you understanding? Are you understanding? Net force need not be 0, but net torque can be 0. At the same time, net torque, am I saying correct? Am I saying correct? Am I saying something wrong? You do it by yourself, okay? You find the mistake. Let me directly jump to the question. We are running out of the time, okay? It's already 1 a.m. 1 a.m. already completed. Okay, right. Sure, good. So let us do a question, okay? Let us do a question. If your net external torque is 0, your angular momentum remains the same. The best example, Leda, the best question for this will be, okay, I'll give you an assembly. This assembly lo, let us say I have 3 masses, okay? 3 masses unnai andariki. So let me draw a circle actually, okay? Let me draw a circle. Ante kada? Yes. So this is my initial circle, okay? Yes. Dan tarvata, let me draw one more circle. This is my final circle. Andariki. Are they concentric? Are they looking concentric? No. A little discrepancy seems to be there. Okay. Now they are looking concentric. Ade kada? Yes. Very good. Very good. Andariki chudandi. The question is, initially I had 3 different masses. Andariki chudandi. This was my mass M1. Okay. This was my mass M2. Ante M teeskondira. Andariki. Take all the masses to be M only. Okay. I don't want any confusion in the problems. Okay. Ekkada kuda, this is my 3rd mass. It is also equals to M. Ante kada? Yes. Try to understand. It's a very good question. Okay. It's a very good question. So what's happening is, they are actually moving with the speeds omega. Ekkada kuda, the angular speed is omega. And here also, the angular speed is omega. Ante kada? Yes. Due to the gravitation in them, okay, due to the gravitation, they got attracted towards one another, and final scenario lo, the same masses, they have come close to one another. So ide na mass M, this is my 2nd mass, this is my 3rd mass, same masses ra, M ekkada kuda M, here also M. Kani they have changed their angular speed. Naku angular speed final kavali. What is the final angular speeds? Okay, you can take the question here, entire question you take it here, okay? 3 masses moving in circle of radius r due to their gravity. Ledante, you can do one thing, okay? Radius r with angular speed omega, with angular speeds omega each. Full stop. Due to gravity, they came close, okay? They came close and move in a circle of radius r by 6, full stop. Find the new common angular speeds. It's a good question, okay? Let us see how many of you can solve it. తీసుకోండి అందరికి. First of all, whatever has happened, ఈ మొత్తం ఇవన్నిటికి ఇంటర్నల్ ఫోర్సెస్ కదా. ఇంటర్నల్ ఫోర్సెస్ ఉంటే నో ఎక్స్టర్నల్ ఫోర్స్ అంటే నో ఎక్స్టర్నల్ టార్క్, ఇదే కదా. So there is no external torque, the angular momentum remains conserved. Okay, if there is no external torque, the angular momentum remains conserved. Thirty-six, 6W, 7W, 7W ఏంటి 7 omega, okay, 7 omega లేదా 6 omega, we are not sure. చూద్దాం. So, hi Karthikeyan, hi. Let us see. Okay, it's a very good question actually, and I'm actually enjoying the night sessions ఎందుకంటే the students who are interested, they are keeping alive. Okay, I'll explain. Don't worry. Okay, don't worry. So your initial angular momentum must be equals to final angular momentum. ఎందుకంటే whatever has happened due to internal reactions. అదే కదా. సో ఇనీషియల్ యాంగులర్ మొమెంటం అంటే ఏంటి సార్? I1 omega 1 మస్ట్ బి ఈక్వల్స్ టు I2 omega 2. ఇప్పుడు నాకు I1 I2 కావాలిరా. హౌ డు యూ ఫైండ్ I1 I2 సార్? వాట్ ఈస్ I1 I2? I1 అంటే మూమెంట్ ఆఫ్ ఇనర్షియా. హౌ డు యూ రైట్ ఇట్? యాక్సిస్ ఆఫ్ రొటేషన్ కావాలి. అదే ఫర్ ఫైండింగ్ ద మూమెంట్ ఆఫ్ ఇనర్షియా యూ నీడ్ యాక్సిస్ ఆఫ్ రొటేషన్. అంటే దిస్ ఈజ్ మై యాక్సిస్ ఆఫ్ రొటేషన్. చూసుకోండి, దిస్ ఈజ్ ఫస్ట్ డిస్టెన్స్ R1, ఇదే నా సెకండ్ డిస్టెన్స్ R2. ఇనీషియల్ సిచ్యువేషన్లో మాట్లాడుతున్నా. ఓకే, దిస్ ఈజ్ మై థర్డ్ సిచ్యువేషన్ R3. అంతే కదా. యువర్ మూమెంట్ ఆఫ్ ఇనర్షియా ఇస్ mr². రెండు మాసెస్ ఉంటే m1 r1 స్క్వేర్ ప్లస్ m2 r2 స్క్వేర్. మూడు మాసెస్ ఉంటే యాడ్ ఆల్ త్రీ మూమెంట్ ఆఫ్ ఇనర్షియాస్ ఇండిపెండెంట్లీ. చెప్పండి, యువర్ ఇనీషియల్ మూమెంట్ ఆఫ్ ఇనర్షియా I1 ఈజ్ ఈక్వల్స్ టు m1 r1 స్క్వేర్ ప్లస్ m2 r2 స్క్వేర్ ప్లస్ m3 r3 స్క్వేర్. అదే కదా. కానీ ద coincident thing is that masses and radii both are same. అంటే mr square plus mr square plus mr square అంటే 3mr square. ఇదే కదా. So your initial moment of inertia is 3mr squared. ఇదే. What about the final one, sir? ఫైనల్ యాంగులర్ మూమెంట్ ఫైనల్ మూమెంట్ ఆఫ్ ఇనర్షియా అంటే ఏంటిరా? సో మీ ఫైనల్ మూమెంట్ ఆఫ్ ఇనర్షియా అంటే ఐల్ జస్ట్ జూమ్ ఇట్ అవుట్, ఓకే, సో దట్ వీ కెన్ గెట్ మోర్ స్పేస్. ఓకే చూడండి, సో మీ ఫైనల్ మూమెంట్ ఆఫ్ ఇనర్షియా ఐఎఫ్ ఇస్ ఈక్వల్స్ టు, ఐల్ రైట్ సమ్వేర్ హియర్, ఓకే, ఇస్ ఈక్వల్స్ టు మళ్ళీ ఒక్కసారి m1 r1 స్క్వేర్డ్, r1 స్క్వేర్డ్ అనేది r2, వాట్ ఈస్ r రా? r is r/6 కదా, ఎస్. సో ఇప్పుడు ఇట్ బికమ్స్ r/6, హియర్ ఆల్సో r/6 అండ్ హియర్ ఆల్సో r/6. అందరికీ అర్థమైంది? m1 r1 స్క్వేర్ ఫైనల్ సిచ్యువేషన్లో r1 స్క్వేర్, r1 కూడా r/6, r2 ఈజ్ ఆల్సో r/6, r3 ఈజ్ ఆల్సో r/6, అంతే కదా, ఎస్. రైట్, సో యూ క్యాన్ సే IF ఈజ్ ఈక్వల్స్ టు m1 ఇంటూ r స్క్వేర్ అంటే r/6 హోల్ స్క్వేర్ రా ఫర్ ద ఫస్ట్ పార్టికల్. కానీ హియర్ ఆల్సో ఇట్స్ సిమెట్రిక్, masses are same, radii are same, అంటే it becomes 3 times of this, అంటే 3 times of mass times of r square upon 36, ఇదే కదా. So you can simply say 3mr squared divided by 36. చూసుకోండి రా, what was my initial moment of inertia sir? 3mr square. What is final moment of inertia? I final is equals to 3mr square by 36. 3mr square అంటే I initial రా, so I initial upon 36 ఇదే. So you take I initial omega 1 omega 2 ade. What do you say sir? Sir, I initial omega initial must be equals to I final omega final. You don't even have to write the values, okay? You write everything in terms of I and omega. Sir, I initial, what is omega initial? Omega must be equals to I final. What is I final? I initial by 36. So sir, I initial upon 36 into omega final. So ikkada nunchi I initial gone. This 36 division lo unte you send it, it goes multiplication. Sir, 36 into omega is equals to omega final. Ade. So if the radius is shrunk by a factor of 6, their angular speeds get multiplied by a factor of 36. Okay, very good, okay, very good. ante kada, yes. Now you can design whatever amount of questions you want and you can solve them. Chusko, conservation of angular momentum, it's a very important topic, okay, chala important topic. I want all of you to understand the conservation of angular momentum. Chuskondi, next question lo I have a disk, okay, I have a disk rotating with an angular speed omega ante kada, omega is equals to, let us say, 2 radian per second. Andariki, okay, let us say mass of the disk m is equals to 10 kgs ra, and the radius of this disk r is equals to, it's actually not required to you, it's a little JE scope ra, we are little entering into that JE thing, okay, but it's a very good thing for us, okay. This way your rotation will be completed. Chusko, ఇప్పుడు what happened is it was rotating, no problem, rotating something like this. కొంచెం సమయం తర్వాత there is this object ra, okay, there is this object that is suspended into air, okay, it's a cube, andariki, it's a cube. I hope you are understanding. Let us say the mass of this cube is 20 kgs. Understanding? అర్థమైంది అందరికి? So this disc is moving slowly, okay, this disc is actually moving slowly, and I am dropping this mass, and this mass has just dropped at the edge of this disc. Edge ante telusa, it dropped here, okay, it dropped here. Mohan Krishna, it's delay, okay, not in my class only, every class lo there is a little delay in between live and whatever you are having. Chusko, mass is 20 kgs, radius is 2 meters. Naku, what will happen ra, if there is a friction on this disc, friction unte the block will be attached to the disc and they will move together, ante kada, ante the angular speed of the disc will decrease, okay, the angular speed of the disc will decrease. So the question is, find final angular speed of disk when it is having 20 kg mass. చెప్పండి ఎక్కడ కూడా సేమ్ థింగ్ ఓకే హియర్ ఆల్సో కన్సర్వేషన్ ఆఫ్ యాంగులర్ మొమెంటం ఎందుకంటే సార్ వాట్ ఎవర్ ఈస్ హ్యాపెనింగ్ డ్యూ టు ద ఇంటర్నల్ ఫోర్సెస్ అదే కదా ఎస్ సో సార్ ఇనీషియల్ యాంగులర్ మొమెంటం మస్ట్ బి ఫైనల్ అంటే I1 ω1 మస్ట్ బి ఈక్వల్స్ టు I2 ω2 అదే ω1 ఎంతారా ω1 is 2 ω1 is 2 what is the moment of inertia about the disk initially it was just a disk kada half mr square half what is mass sir mass is 10 r square is 2 square ante 4 ide kada half mr square it should be half mr square ante kada yes so this is half mr square ante moment of inertia of the disk initially modatiga when the mass was not kept okay multiplied by I1 ra ante I1 okay I1 into omega ante must be equals to final angular momentum ee final case lo you do have the disk that is moving ade kada but at the same time you also have this mass ee mass kosam when you write the moment of inertia it's a single point mass ra single point mass teeskoni you tell the answer so sir ide the axis of rotation distance is r mass is moving and the disk is also moving sir in final case lo your moment of inertia of disk plus moment of disk inertia of the mass multiplied by omega final ide kada yes what is moment of inertia of disk ra ante half m r squared plus what is the moment of inertia of the mass ra ante m ante these are different masses okay I am writing small m and capital M చూసుకోండి capital M ante 20 kgs multiplied by distance squared distance is r only కాబట్టి r రాస్తున్నారు multiplied by omega f ఇదే కదా yes now you just have to simplify it చూసుకోండి రా వాల్యూ సబ్స్టిట్యూట్ చేసుకోండి 2 into 4 8 80 into 2 half becomes 40 రా this was my initial angular momentum must be equals to half mr square into how much sir half 10 into r square that becomes 20 is the moment of inertia of the disk plus mr square becomes 20 into 4 is 80 sir into omega f ade so sir 40 is equals to 100 into omega f ekkadi nunchi omega f is equals to 0.4 radian per second it has decreased ra ide kada so this is your final angular speed no mass will not increase you don't have to take masses okay you have to take separate moment of inertias so you have to take separate moment of inertias andariki okay moment of inertia of disk plus moment of inertia of the mass you cannot add the simple two masses you cannot add them okay because masses are different no it will not become 30 kg next last topic dan tarvata this chapter will be completed ante what is the time now 1:16 kada yes our entire topic will be completed by 1:30 finished okay by 1:30 it will be gone right so ఇప్పుడు okay Mohan Krishna very good if you got it very good okay if you are having some problems into it మళ్ళీ ఒకసారి రివైండ్ చేసి you watch the lecture okay now the topic of the discussion is okay You know what? I'm not feeling bored. I'm not feeling tired. Okay? My energy is full high. ఎందుకంటే I've got brilliant students attending this lecture. Okay? Sincere students, brilliant students, and they are, supporting me. Kabatti, this topic is independently a topic that could be taught for 1 week. Are you understanding? Chala pedda topic ra, chala pedda topic. Ade. Yes. yes. Kabatti, we will not go into the much details of this part, but you trust me, this is ఈ మొత్తం చాప్టర్ అంటే it is my favorite chapter in physics, to be honest. Okay? I'm taking this your live, mostly our lecture will be for 5 or 5.5 hours. If 5.5 hours, we are completing this entire chapter. But when it comes in teaching in a depth, I at least take 20 to 30 hours of time. Okay? Kabatti, let us just take it on the surface only. Okay? We will not go deep into it. Chuskondi. Combined translation and rotational motion, sir. ఈ స్టడీ చేసి ముందు I will just let you know about the difference between these two. చూసుకోండిరా. The first case is your translational motion. Okay? అంటే only the translation is happening. ఇదే నా first case. Your second case is only the rotation is happening. అంతే కదా? Yes. First case లో there is just translation and second case లో there is just a rotation. Okay? Translation and rotation. Sir, how would you define the two things? చూసుకోండి. మీ ట్రాన్స్లేషన్లో యువర్ ఆబ్జెక్ట్ ఇట్ ఈస్ జస్ట్ పర్ఫార్మింగ్ ట్రాన్స్లేషన్ అంటే ఇట్ ఈస్ మూవింగ్ ఇన్ ద ఫార్వర్డ్ డైరెక్షన్. అంతే కదా? ఎస్. Rotational, what happens is, in rotation, you only go with the rotational flow, something like this. Ante kada? So this is the rotation only. Ante it is at the fixed place, but moving in a circular way. Ide kada? So this is your rotation. Are you understanding? Okay? This is your translation, and this is your rotational motion. Andariki chuskondi. This is your rotational motion. Okay? This is your rotational motion. What will happen if we merge both of them? Ante enti, sir? Ante your rod is at the same time doing translation also and rotation also. Are you understanding? Yes. So this is the translational motion and this is the rotational motion. See, it is rotating. Okay, it is rotating. This rod is rotating actually. Chuskondi andariki, it is rotating. But at the same time, it is translating also. The best examples gurinchi maatladite, this is your best example of translational plus rotational motion. How should I say? Yes. So this is the example of your translational plus rotational motion. Whatever you throw it, however you throw it, okay, you understand. Okay, this is the rod. Idi translational, idi rotational. But when I throw it, it is performing both ante translational plus rotational. Are you understanding? You see something like this. See, it is translational plus rotational. If you want, you can zoom it ante go back and play this video at 0.25 speed. Then you will come to know how is it moving. Ante it is doing both the translation and the rotational motion. Okay? Both the motions. Yes. Balancing a moving football on a tip and moving forward. Very good. Okay? Very good. Perfect. So your translational plus rotational motion has 3 different categories. Chuskondi. 3 categories unnayira. 3 categories unnai. Actually there are 2 categories only, but even in those 2 categories you have 3 different categories. Ante scientists have studied something. Chuskondi. Okay, your translation motion low, your rod is just doing some translational motion. So ide me rod and here also it's your rod, ante kada. Yes, but when it is translation motion, the center of the mass chuskondi. The biggest confusion is, what is the biggest confusion, sir? Sir, the biggest confusion is about the points. Chuskondi. I don't have actually pen. Give me 1 minute, okay? Just 1 minute. I'll be back in 1 minute. Andariki. I'm back. Student. Yes, pencil is moving down while rotating. Ante kada? Yes. So when it's coming to your translational motion, you don't have any problem. Endukante all the points that you are observing. I thought it would write something good, ra. You just look at the points, okay? Ee points ni chudandi andariki. How many points you have, ra? Infinite points kada? Yes. So these are the points at which I am interested. Chuskondi andariki. Only focus at the given points. All of you, okay? Only focus at the given points. So these are my points. The biggest problem I have is there are a lot of points and I can't focus at all the points at a given instance. Ade kada? Kabatti we take the center of the objects, center of mass of the objects. Whenever there is a rotational motion, chuskondi. Whenever there is a rotational motion, the first and the most important thing that you do is look at the axis of rotation. Ade kada? Yes. So if this is your points, ee rod, if it is doing a translational motion, andariki chudandi, every point on this rod, each and every point on this rod moving in the same direction, moving with the same linear speed. Linear speed ante telusa, right? When this rod doing a circular motion, ante rotation motion, every single point has different linear speeds. Linear speeds are different. Kani their angular speeds are same. Omega is same. Chusko. Me translation motion lo, this is my first particle, second particle, third particle, fourth particle, fifth particle, sixth particle. Each and every particle is having the same speed equals to v. Understanding? Yes. Wheels on a vehicle. Very good. Very good. The best examples are wheels on a vehicle. Leda you throw up a pencil while moving. Leda pencil moving down in a rotation motion. Spin a football on your fingers and move forward. Ade. They are the best examples. Ledante the next best example would be something like this. Chuskondi. This is the example of translational plus rotational. Are you understanding? Hey, are you understanding? Translational is also happening, rotation is also happening. Okay? Yes. So these are the best examples. Perfect. Chudandi. So now we have to analyze some things, ra. Chudo. When it is translational motion, I don't have any problem. Endukante every single point is moving in a disciplined way. Ante if I look at center of mass, moving forward, speed v, random point, moving forward, speed v, every particle is following center of mass. And then my total problem solved. I don't have anything to discuss. When it comes to pure rotation, ekkada kuda I don't have any problem ra. Endukante your center of mass is at rest. Chuskondi. Rotation lo, your center of mass ante axis of rotation, it will always be at rest. Ide kada? Yes. So if I say this is my rod, if I say this is my rod, I'll say this is the center of mass of this rod. Okay, chuskondi andariki. So this is the center of mass kada? Yes. This is the center of mass of the rod. When the rod is moving, you just see the center of mass andariki. It is at rest kada? Yes, it is at rest. It is at rest. The center of mass is not moving at all. When the rod is moving, the center of mass is remaining at rest. Ante kada? Yes. Center of mass is at rest. What about other points, ra? Other points gurinchi cheppandi andariki. So this point is moving in clockwise. E point ante it is moving in anti-clockwise. Chuskondi. Every point has different linear speed. What I am telling ra, ఇది చాలా ఇంపార్టెంట్. ఓకే, చిన్న డిఫరెన్స్ ఉంటుంది రా. angular speed omega is same for each and every point. Ade kada? Yes. Omega is same. Ante angular speed omega is same, but not the linear speeds rate. Okay? But when it comes to the linear speed of the rods, ade, this is my rod, okay? Same rod this one. Okay. Let us say this is my same rod. But when it coming to linear speeds andariki, linear speeds ante this is my center of mass. Koncham samayam tarvata, the rod looks something like this, okay? The rod looks something like this, okay? Not like this. This is my rod. That means this is the center of mass of the rod. Ante kada? Yes. This is the center of mass of the rod. Andariki chuskondi. This is the center of mass of the rod. That means whatever the distances are moved by single points, this distance, they are difference kada? Yes. So they are the different distances. Andariki chuskondi. This are the speeds. Something like this. Ante linear speeds are different. Kani angular speed is the same. But when I merge these two cases, system becomes complicated. Are you understanding? System becomes complicated. Chuskondi. Ippudu when both are merged ante your rod, it is moving forward also and at the same time it is rotating also. Are you understanding? You are moving forward also and rotating also. Mari em discuss cheyali sir? Mari em discuss cheyali? We will have to talk about angular momentum, kinetic energy and the relation between speeds and angular speeds omega. Chusko. Ee case lo, in this case, your omega is 0 and no rotation. Are you understanding? Yes. Ee case lo, your v is equals to 0 and velocity of center of mass is equals to 0. About the remaining points gurunchi v is equals to r into omega. Ide kada? Yes. Are you understanding? But this is a special condition. What condition, sir? This is the speed of any general point. Chusko. This is not, how should I write? Let me just zoom it out, okay? This specific condition, andariki, this specific condition is not applicable. This condition is not applicable for center of mass. Enduku, sir? Because in pure rotation, center of mass speed is always 0. You cannot say r into omega. Are you understanding? R into omega is a non-zero quantity. Actually, you can say, sir, r is 0, kabatti velocity is 0. Good, very good, very good, very good, very good. But when you look about a general point, its speed is not 0. Are you understanding? And that speed is not the speed of the center of mass. That's what I'm telling to you. Try to understand it, okay? Good. Next scenario, chuduskondi andariki. When I'm talking about combined translation and rotation motion, and it is doing translation also and rotation also. Chusko. Velocity is v, angular speed is omega. Velocity is v, angular speed is omega. When we are talking about translation, chuskondi. It is chala important ra. When we are talking about translation, we see speed and aim speed ra, linear speed, okay? We see the linear speed. When we talk about translation, we talk about the linear speed of center of mass. Are you understanding? It is something like resolving the vectors. Sir, my vector is like this. First component in the vertical direction, second component in the horizontal direction. Vertical component does not affect horizontal, horizontal does not affect vertical. Ide kada? Same thing. When you are talking about translation, only focus on the center of mass. Andariki. And when you are talking about rotation, chuskondi. When you are talking about rotation, only talk about axis of rotation. Ade. Ide kada? Ante entira? Angular speed about axis of rotation. These are the biggest observation that you could do. When you talk about rotation, we talk about angular speed about the axis of rotation. Ade. These are the two observations that you will be doing. Malli cheptunna. Chuskondi andariki. Are you there? Have you slept andariki, all of you? Sir, it's too late, sir. We are sleeping, sir. You're not understanding. Okay, good. What did I say? Combined translation plus rotational motion law. When you are talking about translation, only see the speed of the center of mass. And when you are talking about rotation, see the angular speed of the object about the axis of rotation. Ante kada? Yes. So sir, when I say this pen ra, చూసుకోండి ఈ పెన్ గురించి మాట్లాడుతున్నావు. This pen, okay, this pen. Are you understanding? Are you understanding? This is the pen. This is the pen. Okay, this is the pen. What is the axis of rotation? Andariki. When I am moving this pen something like this, where is the axis of rotation? Where is that? Ide. This is the axis of rotation. Ante kada? Yes. And when I am doing it along with the translational motion, what can I say? Sir, your translation motion law, we will be talking about the speed of the center of mass. And at the same time, rotation law, we will be talking about angular speed of the pen about the axis of rotation. Okay? Yes. Good. Very good. Okay? The best example, చూసుకోండి. The best example would be, let me take a little thick, okay, little more thick. Okay, so this is my rod. అందరికి చూసుకోండి. This is my rod and it is doing the same things. Okay, it is doing the same things and it is doing translation also. The session will end at don't know, maybe half an hour, maximum half an hour. Okay, yes, very good question. Go Nat, very good question. Very good question. Okay, very good question. Very good question. Chusko. Now my question is two different things. What did I say? Linear speed ante v, ide kada. Angular speed ante omega. Now they are in my hands. If I want, I can take both to be equal. Leda I will take unequal things. Ide kada. Yes, 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 yes. Very good. Very good. Andariki very good. You now observe. I will try to show you experimentally everything. Okay, I will try to show you everything experimentally. Ikkada chudandi. When I am telling that this rod is doing both combined and rotational motion, I do have two flexibilities ra. Na daggara rendu flexibilities unnai. The first one is I can give whatever omega to this rod I want. Ardhamainda? At the same time, I can give whatever speed v to this rod I want. Are you understanding? Yes. Sir, what will happen if v is greater than omega? Ante the linear speed is more but the rotation is less. Understanding? First case. The best example enti sir, v more omega less. Ante kada? You understand with the help of this bottle, all of you. Okay? How should I tell you? చూసుకోండి. Your v should be more and omega should be less. అంతే కదా. Now it's a little experiment based. So ఈ ఎక్స్పెరిమెంట్ చేసిన తర్వాత go back and watch it at 0.25 speeds రా. Okay? Okay? It did not even complete one single rotation. చూసుకో. Are you understanding? It is rotating. I am throwing it in the horizontal position, but it moved too fast. Okay, it moved too fast. But it is coming in a vertical position. Ante kada. I threw it in horizontal, but it came back in vertical position. Are you understanding? So in this case, omega is very slow, but speed is fast. Ante kada. Are you understanding? Chuskondi. Something like this ra. Okay, something like this. Yes. Second case lo sir, what will happen if omega is more than v? Ante your rotation is fast, kani the speed is too slow. For example, something like this. Understanding? It is rotating too fast, but speed is very low and it is not going much up. Speed more ante height is more kada. Ee case lo chudandi, speed is not more. It is not going much height ra, but it is rotating too much. You understanding? Doing life threatening experiments ra. Okay, this is the case. Yes, yes. First case lo, when your v was more, omega was less, the motion was looking something like this. Chuskondi. Velocity is more but omega is less. Not even one rotation has been completed. Chuskondi. Okay, half rotation, not even half, 1/4 of the rotation, horizontal ra. Hey, moving up fast but rotating very slow, very slow, very slow. This is the rotation. First case low. Second case low, rotating very fast, but speed is low. You are understanding? And the third example, third case is my standard case ra. If omega is related to v, I'll not say omega is equals to v. Omega and v cannot be same. Okay. You also cannot say this relation ra. If v greater than omega, v less than omega, something like. Chusko. I have v until linear speed. To match this, I have linear format lo r into omega. Ide kada? Yes. So I will say this now. Sir, if v is greater than r omega, until the same first case ra, same first case, v is more and r omega is less. Second case lo, what I will say, sir, r omega is more than v. Ante the second case, whatever we discussed, chusko. First case ante velocity is more but omega is less. Are you understanding? More velocity but omega is less. Okay, omega is less. Not even completing one rotation ra. Second case lo, omega is more ante rotation effect is more, can you linear effect is less ante something like this. Too much rotations, ante kada? Yes. Yes, exactly, Gunnar. If you spin the bottle on the ground, it rotates more and covers less distance. Ardhamaindi? Third case ante me standard case, if v is equals to r omega. Chuskondi. This is the best case and we are going to study this one only. Chusko. Ee rendu cases lo you can say that there is some sort of discrepancy ante no synchronization. Ade kada? No synchronization. No synchronization ante enti ra? You can simply say, sir, there is some slipping. Slipping ante enti ra? I'll explain, don't worry. There is some slipping, okay? There is some slipping. Ee case lo no slipping ra ante everything is in synchronization. No slipping leda rolling without slipping. Rolling without slipping. Ide kuda antaru. Okay. Now, whatever experiment I am going to tell you, do we have some good setup ra? This chair is not visible to you, right? Just give me a minute, andariki. Okay. I know it's too late. You might be tired also, but I'm getting too much interest, you know. Kabatti, I'm taking this session to be this much long. Just see if you can see this or not. Yes, you can see this, right? You can see this. Okay, all of you. You can see this. Okay, perfect. This is my first case. Okay, this is the bottle ra chuskondi. Okay, center of mass of this bottle. Ikkada no sir. Sir, this is the center of mass of this bottle. Ade kada? So this is the center of mass of this bottle. Andariki chudandi. Can you see it? Yes. What's happening now ra? If my v is more than r omega, ante moving too fast but rotating too slow. Chuskondi. Something like this. Okay, moving too fast but rotating too slow. Moving too fast but rotating too slow. Okay, something like this. Moving too fast but rotating too slow. Second case lo, your r omega is greater than v ante enti something like this. Chuskondi. Moving too slow but rotating too fast. Okay. Are you understanding? I can't even tell you. Okay, something like this, right? Okay. The best example would be if you have a football ra. I usually explain it with the help of a football. Kani ippudu I don't have it, so I am unable to express it. Okay, but you understand. Okay, in both the cases, rendu scenarios lo, what's happening is you try to understand. Okay, first case lo, your v is more, r omega is less ante v more kada? Yes, v more but rotation is less. So something like this. Okay, something like this. You see the rotation, less rotation, but speed is more. So sir, more speed, less rotation, something like this. Can you hear this sound? Hey, can you hear this sound? Slipping. This is called as slipping. Are you understanding? This is slipping. What about the second scenario, sir? Your r omega is more, your v is less. Ante, you try to understand what I am doing is, okay? I am pushing it down, here I am pushing it down, something like this. Can you visualize? Ikkada kuda rotating too fast but moving very slow. Here also slipping. Sound vastundi kada? Yes, it is the sound that is coming ra. Kani third case lo v is equals to r omega. Very smooth, no slipping. Chuskondi. This is your v and this is your r. Andariki chuskondi, okay? This, you see any sound comes or not? Are you understanding? No sound kada. In case lo, the speed of the center of mass, it is exactly equal to the value of r times omega. No slipping sound, ante kada? Yes. So this is called as rolling without slipping. First case lo, there is slipping. The sound is coming. Sound vastundi kada? Chuskondi. Too much fast, but rotation is too slow. Second case lo, ikkada kuda the same thing. Okay, that sound you can hear here also. Yes, sound that is coming, right? This sound. This is known as slipping. So in rendu cases lo, you will have slipping, but in the third case, you don't have any slipping ante. This is the third case, where the linear speed is exactly equal to the angular speed, r times omega value ra. Okay, so this is known as rolling without slipping. Andari. Okay, that expression is known as rolling without slipping. Ardhamaindi andariki? Okay sir, okay. Now let us take the same example with a ring or a disc. Chuskondi. So if this is a rough surface ra, everything only keeps significance when the surface is smooth. Okay, smooth. Rough surface unte, you cannot say that there will be slipping. Okay. Slipping and everything is possible only on smooth surfaces. Chuskondi. So this is your ring andariki. Leda, this is your disc. Okay. Yeah, perfect. Correct. Okay, perfect. Chuskondi. This is your ring. Yes. So we'll do everything. Okay, we'll do everything. Don't worry. Yes, very good. So in case lo, when I say your linear speed is more than r omega, chusko. Ante velocity of center of mass. This is my center of mass. Ide my velocity of center of mass. And this is the value of r omega. Andariki. Chuskondi. Hey, why is it getting disappeared? Ra? Okay. So this is the value of omega. Ante too much slipping, but hey, not too much slipping, too much forward and the rotation is less. Are you understanding? It is moving forward a lot, but rotation is less. Ante, you take the example, okay? Me daggara oka football unte, you push that football, okay? You push it linearly. It slips more, ra. It moves forward a lot, but rotation is very less. Second case lo, your v is less than r omega. Ante, you take the same football. Now you slowly push it from the top point, okay, topmost point. For example, you say you are hitting it like this, ra. So either me football, okay. The best example would be your football placed on a rough surface, okay, rough surface untundi. The football placed on a rough surface. So this would not become your omega, okay. Your omega would be different. Andariki chuskondi. So what will happen if you kick it? If you kick it like this, it will go forward. Koncham samayam tarvata it will start rotating. Ante kada? Yes. It does not rotate in here actually. You hit it. After some time it starts rotation. Ante Speed is more, but rotation is less. Second case లో V is less than R omega ante, you can again say that this is your ground and this is your football. Andariki చూసుకోండి. Okay, this is your ground, this is your football. But now you don't hit it there, you hit it here very slowly. Okay, you kick it here. What will happen, sir? It will rotate too much, but it will not move forward. Are you understanding? It will keep spinning but not move forward. The best example would be third case. Third case lo చూసుకోండి. Now I am taking in the third case what I am telling you is, ఈ third case లో let us say this is my ring లేదా this is my disc. I am not taking football now. Okay, ఇదే నా డిస్క్ ఉంటే this is the center of the mass. You understand? అంటే ఈ కేసులో V is equals to R omega. V is equals to R omega ఉంటే there is no slipping. అదే, so there is no slipping. That means whatever point it is there అంటే omega, this distance is R. Okay, let us take this. This distance is R. అందరికి distance R ఉంటే whatever the speed of the center of mass అంటే linear speed velocity ఇదే కదా. So center of mass will also be happy ra, ఎందుకంటే it is having same speed as your R omega. R omega, what is R omega, sir? What is R omega? You understand, in linear, in translation, in rotation motion, sorry, rotation motion lo, what did I say ra? Yeah, I told you in rotation motion omega ante R omega is the speed of general point. Ante this is my point, it is having the speed of R omega. What is R, sir? R is the distance from the hinge of that point. Omega is the angular speed. అదే కదా. Yes, same thing ra, same thing. You apply it here also. అందరికి చూసుకోండి. If I am telling this is my first point, ఇదే నా second point. Okay, on the ring itself రే చూసుకోండి. What is the distance of these points from the center ra? So this distance ఇది కూడా R and this is also R కదా. Yes, tell me where is the omega? Omega is like this అంటే the linear speed will be R omega in the left side for the bottom particle. అందరికి చూసుకోండి ఇదే కదా. Yes, for the bottom particle R omega is towards the left side ఎందుకంటే it's moving something like this కదా. So yes, what about right particle, sir? It is moving like this అంటే the linear speed will be towards the right R omega. అంతే కదా. Yes. Are you able to understand? Are you able to understand? No. Why no, sir? Because the axis of rotation is not the center. Try to understand. When something rolls, చూసుకోండి, when it is rolling ra, where is the axis of rotation? Where is the axis of rotation? This is the axis of rotation. అందరికి చూసుకోండి. No, it's wrong, it's not right. చూసుకోండి, my axis of rotation is not this. It is the axis of rotation when there is pure rolling ra, కానీ ఈ కేసులో there is rolling plus translation కదా. So ఈ కేసులో your axis of rotation is this. If you are not understanding, just keep in mind. So this is your axis of rotation. అందరికి చూసుకోండి. Okay, this is your axis of rotation. Accordingly, all the values would be adjusted. Okay, according to your axis of rotation, all the values would be adjusted. This distance is for sure R, కానీ this is axis of rotation. You always remember, sir, కొంచెం సమయం తర్వాత what happens is this wheel will come forward ఇదే కదా. So after some time you can say this is your wheel, sir, this is your wheel. చూసుకోండి ఇదే కదా. Yes. After some time this is your wheel. So the axis of rotation that was here, it has shifted to this point. చూసుకోండి, the axis of rotation is here. అంటే rolling without slipping లో your axis of rotation also travels forward. Very important topic, very important. Okay, in rolling without slipping, your axis of rotation also moves forward. అదే అంటే these are the points of contacts. Are you understanding? It's rolling kada. So at each and every contact point, it will be the new axis of rotation. చూసుకోండి. So if it is rolling something like this, at each and every contact point is my new axis of rotation at each and every contact point, whatever it is contacting. Are you understanding? Right, perfect. So ఇప్పుడు చెప్పండి, ఇదే మీ యాక్సిస్ ఉంటే, if this is your axis of rotation, I'm again telling you 3 points. Okay, this is my first point. అందరికి చూసుకోండి, I'm naming these with red colors. ఇదే నా point number 1, here is my point number 2, here is my point number 3. ఇప్పుడు చెప్పండి, యాక్సిస్ ఆఫ్ రొటేషన్ తోనే డిస్టెన్సెస్ సార్, పాయింట్ నెంబర్ 1 అంటే డిస్టెన్స్ ఇస్ r1, ఎందుకంటే హియర్ ఇస్ ద పాయింట్ 1 అండ్ హియర్ ఇస్ యాక్సిస్ ఆఫ్ రొటేషన్ అంటే ఇట్ బికమ్స్ 0. వాట్ అబౌట్ సెకండ్ పాయింట్ సార్, r2 డిస్టెన్స్ చెప్పండి సార్, హియర్ ఇస్ ద యాక్సిస్ ఆఫ్ రొటేషన్, ఇదే నా సెకండ్ పాయింట్, డిస్టెన్స్ ఇస్ r, ఇదే కదా, సో r2 వాల్యూ ఇస్ r. సేమ్ థింగ్, దిస్ ఈజ్ మై యాక్సిస్ ఆఫ్ రొటేషన్, దిస్ ఈజ్ మై థర్డ్ పాయింట్, డిస్టెన్స్ చెప్పండి, ఇదే r ప్లస్ r అంటే 2r రా, r3 value is equals to 2r. ఎప్పుడు చెప్పండి, now you tell me, okay, r3 is 2r. Now you tell me sir, the linear speeds of each and everything. No, Gonat, if the axis in the center, if the axis is in the center, it will only rotate, it will not move forward, okay, it will not move forward. If the axis is exactly in the center, it will just rotate, it will not move forward, okay. To move forward, the axis of rotation must be changing at all the times. If you're not understanding something like this, you visualize it something like this. Hey, but that's going too much advanced topic, I don't want to go into GE advanced, okay. You just understand, if there is pure rolling without slipping on a ground, you just understand that axis of rotation is on the ground all the times, all the times, and it is moving. ఎక్కడైనా పాయింట్ ఆఫ్ కాంటాక్ట్ ఉంటే దాట్ బికమ్స్ ద యాక్సిస్ ఆఫ్ రొటేషన్. ఓకే, ఎస్, కరెక్ట్. డిస్టెన్సెస్ చెప్పండి, r3, r2, r1. r1 వాల్యూ 0 అంటే ఫస్ట్ పాయింట్ యాక్సిస్ ఆఫ్ రొటేషన్ సేమ్ డిస్టెన్స్, యాక్సిస్ ఆఫ్ రొటేషన్ సెకండ్ పాయింట్ డిస్టెన్స్ ఇస్ r, యాక్సిస్ ఆఫ్ రొటేషన్ థర్డ్ పాయింట్ డిస్టెన్స్ ఇస్ 2r. థర్డ్ పాయింట్ స్పెషల్ పాయింట్స్ ఉన్నారు కదా, ఎందుకంటే దే ఆర్ ఇన్ ద సేమ్ వర్టికల్ లైన్. దిస్ ఈస్ ద టాప్ మోస్ట్ పాయింట్, దిస్ ఈస్ ద బాటమ్ మోస్ట్ పాయింట్, and this is the center of mass of the ring. ఇదే కదా డిస్క్, ఏదైనా తీసుకోవచ్చు. ఓకే, దిస్ ఈస్ ద సెంటర్ ఆఫ్ మాస్ ఆఫ్ డిస్క్, ఇట్ ఈస్ ద టాప్ మోస్ట్ పాయింట్, ఇట్ ఈస్ ద బాటమ్ మోస్ట్ పాయింట్. మూడు కూడా స్పెషల్ పాయింట్స్ ఉన్నారు. దాట్ ఈస్ వై ఐఎమ్ ఇంట్రెస్టెడ్ అబౌట్ ఆల్ ఆఫ్ దీస్. చూసుకోండి, నౌ when you talk about the speed of this linear speed గురించి మాట్లాడుతున్నాం. చూసుకోండి, what is the formula for linear speed రా? We can simply say sir, linear speed is equals to r into omega. ఇదే కదా. ఇప్పుడు చెప్పండి, లీనియర్ స్పీడ్ ఆఫ్ ఫస్ట్ పాయింట్ సార్ r1 omega, లీనియర్ స్పీడ్ ఆఫ్ సెకండ్ పాయింట్ చెప్పండి r2 omega, లీనియర్ స్పీడ్ ఆఫ్ థర్డ్ పాయింట్ చెప్పండి r3 omega. ఇదే కదా. ఇప్పుడు వాల్యూ సబ్స్టిట్యూట్ చేసుకోండి ఒకసారి. సార్ r1 వాల్యూ ఇస్ 0 అంటే 0 ఇంటూ ఒమేగా, r2 వాల్యూ ఎంత సార్ r, r2 ఈజ్ r అంటే r omega, r3 వాల్యూ హౌ మచ్ సార్ 2r ఇంటూ ఒమేగా. ఇదే. సో దీస్ ఆర్ ద లీనియర్ స్పీడ్స్ ఆఫ్ ద పాయింట్స్. అంటే ఏంటి సార్, if at all I have a ground and a ring లేదా a disk, whatever you want you can call it, okay. If at all I have a ground and disk, 3 points I'm concerning. అందరికి చూసుకోండి, 3 points. What are these 3 points sir? First point is exactly the bottom point of this ring, second point is the center of this ring, third point is the top point of this ring. ఈ పాయింట్ కోసం యూ కెన్ సింప్లీ సే వెలాసిటీ ఈజ్ ఈక్వల్స్ టు 0. వెలాసిటీ అంటే ఏంటిరా, లీనియర్ వెలాసిటీ ఈజ్ 0. ఓకే, ఫర్ దిస్ పాయింట్ లీనియర్ వెలాసిటీ ఈజ్ 0. వెరీ గుడ్. ఫర్ దిస్ పాయింట్ లీనియర్ వెలాసిటీ v ఈజ్ ఈక్వల్స్ టు r ఇంటూ ఒమేగా. r అంటే రేడియస్, ఒమేగా ఈజ్ ఒమేగా. ఫర్ దిస్ పాయింట్ లీనియర్ వెలాసిటీ ఈజ్ 2r ఇంటూ ఒమేగా. ఇప్పుడు వాట్ అబౌట్ ద డైరెక్షన్స్ ఆఫ్ లీనియర్ వెలాసిటీస్ రా? It is 0 ఉంటే it does not have any direction because the speed is not there. అదే కదా. So if there is no speed, there is no direction. I'm not concerned about the direction of that speed. ఇక్కడ చెప్పండి, when it comes here, omega is like this అంటే ఈ కేసులో this is the direction of center of the mass of the ring లేదా disk, whatever it is. ఇప్పుడు when you're talking about this instance, చెప్పండి, the direction omega is like this kada. Yes, so tangent, this is the direction of 2r omega. Are you understanding? Arrows kuda they are telling the same, okay. 0 arrow, chinna, smaller, and here is the bigger arrow. Are you understanding? This is how the scenarios do work. What about the general speed sir? General point sir, general point gurinchi maatladite I'll write the same thing, okay? I'll write the same thing. Chusko, So this is my disk. Okay, this is my disk. ఇప్పుడు చెప్పండి, let us talk about a general point అందరికి. So this is the center. ఇదే నా జనరల్ పాయింట్, ఇదే కదా? ఎస్. సో ఇట్ హ్యాస్ టూ స్పీడ్స్ రా. వాట్ టూ స్పీడ్స్ సార్? వాట్ ఆర్ ద టూ స్పీడ్స్ సార్? వాట్ ఆర్ ద టూ స్పీడ్స్? చూసుకోండి. బిఫోర్ దిస్ ఆల్ ఆఫ్ యూ, బిఫోర్ దిస్ ఇట్ హ్యాస్ 2r ఒమేగా కదా. ఇప్పుడు టాప్ పాయింట్ కోసం మాట్లాడుతున్నావు, చూసుకోండి. నౌ ఫోకస్ ఓన్లీ ఆన్ ద టాప్ పాయింట్ అందరికి. నౌ ఫోకస్ ఓన్లీ ఆన్ ద టాప్ పాయింట్. ఐ థింక్ యూ విల్ బి గెటింగ్ ఇట్ నౌ. ఓకే, యూ విల్ బి గెటింగ్ ఇట్ నౌ. చూసుకో. హియర్ I will do one thing. I will take two scenarios. రెండు scenarios తీసుకున్నావు, చూసుకోండి. This is the first scenario, this is second scenario. Okay, same sizes కదా. Okay, it's a little small, so let us make it a little larger. Same sizes, right? Okay, perfect. Okay, this is ring, this is also ring. But you imagine, okay, you imagine something like this. In this case, this ring is just rotating. Okay, in this case this ring is just rotating. Hey, it is just rotating ante entira, just moving with angular speed omega, no translation, just rotation. How many of you can say what is the linear speed of the point at this instance ra? Just tell me the linear speed. It is just rotating. Okay, only rotation is there. Okay, only rotation unte cheppandi. If it is only rotation, what is the linear speed of that point? What is the linear speed of that point if it is only rotation? Sir, this is the axis of rotation. Ide kada? Yes, so if this is the axis of rotation, you can simply say V is equals to R omega. Radius R ra. Are you understanding? V is equals to R omega. If it's just rotating, linear speed is R omega. What if, sir, if it is just transversing, ante it is just traveling with the speed V ra? Cheppu. If it is just traveling with a speed of V, లేదా you can say V is R omega also. I'm giving a specific value రా, specific value. ఈ V కి specific value అంటే R omega. అంటే the center of the ring, it is moving forward, అంటే only translation రా. ఈ కేసులో it is only moving forward, అంటే only translation. ఈ కేసులో కూడా what is the speed? R omega. Sir, each and every point has the same linear speed R omega in the right side. Ekkada kuda R omega kada. Yes. Now focus only on this point. Due to rotation R omega, due to translation R omega, when you are mixing R omega plus R omega becomes 2R omega. Translation plus rotation. Understanding? Yes, very good. Gonad, very good. So when you are mixing both R omega due to rotation and R omega due to translation, they are getting merged and the new speed is coming as 2R omega. Idem kada? Yes. What about a general point, sir? Cheppo, ippudu general point gurinchi naaku kavali, ide kada? Yes. So when you talk about the speed on a general point ante it has two different motions. Chusko andariki. The first motion is translation motion ante V. Due to this translational motion, what is the speed of it? Sir, due to translation only, every point has the speed equals to V. Ide kada? Yes. Equals to R omega. Okay, idi kuda R omega andariki. This is also R omega. V is equals to R omega. Chala important. Okay, it is very important. Chusko. If this angle is theta, first thing that I can say is due to translation it has the speed V is equals to R omega, that too in the right side. Ade kada? What about the rotation speed ra? Rotation unte chusko. Every point over here due to rotation has the speed in the tangential direction. Ide kada? Yes. Try to understand. Every point has a rotational speed in the tangential direction. Ekkada vachi you can say, sir, due to rotation this is the speed. Are you understanding? So this speed is due to rotation. Enta, sir? Same. If it is rolling without slipping, R omega is the speed. Are you understanding? Yes. If this angle is theta, sir, what is the angle between these two? If this angle is theta, what is the angle between these two? So, sir, ide theta unte, this is a right angle triangle. Chuskondi. 90 degrees. Ide kada? 90 degrees ra. Andariki. If you are understanding, well and good. Not understanding, just remember, okay? Due to translation, there is a speed. Due to rotation, there is one more speed. Okay, right. Not directly r omega plus r omega. Go not, because their directions are different. Kada. We will have to add them vectorially. So if angle is alpha, we can say, sir, v square plus 2 into v into cos alpha. Are you understanding? These are vectors, not scalars. Okay, good. Good. Let us talk about angular momentum. Okay. Angular momentum in combined translation and momentum. Directly formula rastunnam chuskondi. When you are talking about a rod that is moving with angular speed omega and at the same time with speed v ra, chusko. You can simply say, sir, total momentum. Ade kada? Yes. Total momentum is equals to, you remember the formulas andariki. Ide kada? Total momentum is linear momentum plus angular momentum. Ade. Linear momentum enta, sir, m into v plus what is angular momentum, sir, I into omega. Ide. So this is your total momentum. I hope it is understandable to you. Okay, just remember this formula andariki chala important formula idi. Okay, so when the rod is just moving without combined translation plus rotation motion unte, this is your angular momentum leda total momentum of the system. And we are talking about kinetic energy. Cheppandi andariki. Kinetic energy ante entira? I into omega, leda you can simply say, sir, m into v bar plus r bar cross v bar. Idi kuda angular momentum kada? Yes, right. Perfect. Cheppandi. Kinetic energy, what you can write, ra? Kinetic energy total is equals to kinetic energy of rotation plus kinetic energy of translation. Rotation ki kinetic energy ante half I omega squared plus half mv squared. Okay, so this is the total kinetic energy. Let us end this session with a single question. Okay, okate question istunna chuskondi. Sphere, disc of mass 10 kg and radius, a disc of mass 10 kg and radius 4 meter is rolling without slipping. On the ground with angular speed omega is equals to 4 radian per second. Full stop. Calculate the total energy of disk. Cheppandi. Okay. Yes. In every case, these two formulas are valid. If the V is greater than R omega, akkad kuda the same formula. V is less than R omega, same formula. Slipping or non-slipping. You just keep in mind, these two formulas are valid in each and every case. Momentum and energy kosam formulas. Okay, I'll be back in 1 minute. Just a minute. Okay, I'll just bring some water and we'll end up. ఓకే మోహన్ కృష్ణ లెట్ us see చూద్దాం ఓకే లెట్ us see గుడ్ ఎఫెక్ట్స్ బై ద వే ఓకే చూద్దాం సో ఇఫ్ ఇట్స్ డిస్క్ చెప్పండి అందరికి మాస్ హౌ మచ్ సార్ ఫస్ట్ ఆఫ్ ఆల్ లెట్ us క్యాల్కులేట్ ద రా మెటీరియల్ ఏదైనా రిక్వైర్డ్ రా చూసుకో సో ఫస్ట్ థింగ్ దట్ వీ రిక్వైర్డ్ ఈజ్ మూమెంట్ ఆఫ్ ఇనర్షియా అంటే హాఫ్ mr² అంటే హాఫ్ ఇస్ హాఫ్ మాస్ ఇస్ 10 kg రేడియస్ 4 మీటర్ అంటే 16 ఇదే కదా 160 into half becomes 80 సో దిస్ ఈజ్ మై మూమెంట్ ఆఫ్ ఇనర్షియా అంతే కదా ఎస్ what else do we require? We have to find the total energy. Kinetic energy total is due to rotational plus due to translation. ఇదే కదా yes rotational kinetic energy చెప్పు half I omega squared. Translational అంటే half mv squared. half కామన్ తీసుకోండి అందరికి I వాల్యూ ఇప్పుడు క్యాలిక్యులేట్ చేసాను కదా 80 multiplied by omega squared. What is omega రా 4 radian per second అంటే it is squared plus half కామన్ ఆల్రెడీ తీసుకున్నావు చూసుకోండి మాస్ ఇస్ 10 kg ఇదే కదా ఇప్పుడు నాకు స్పీడ్ కావాలిరా స్పీడ్ అంటే ఆర్ ఒమేగా ఎస్ వెరీ గుడ్ వరలక్ష్మి వెరీ గుడ్ ఆర్ ఒమేగా కండిషన్ సో సార్ వి ఈజ్ ఈక్వల్స్ టు ఆర్ ఇంటూ ఒమేగా ఆర్ ఇస్ 4 ఒమేగా ఇస్ 4 అంటే ఇక్కడ కూడా 16 ఇదే కదా ఎస్ సో యూ కెన్ టేక్ హాఫ్ ఇంటూ 80 into 16 plus 10 into 16 you don't multiply you take 16 also common ra so 80 plus 10 అంటే 90 into 16 into 90 అంటే 1440 ఇదే కదా you divide it with half that is 720 joules ఇప్పుడు చూడండి వాట్ ఎవర్ మిస్టేక్స్ యూ హ్యావ్ డన్ ఆర్ ఐ am doing some mistake చెప్పండి am I doing some mistake half I omega square plus half mv square లేదంటే హాయ్ లేదంటే if I am doing some mistakes tell me let me know about it okay I am waiting for your responses అందరికి చెప్పండి did I do some mistakes లేదా did you do some mistakes okay great okay one last question okay ఒకటే question yeah it's 210 I know tech trainee I know it's 210 one last question and then we'll be done okay చూసుకో I would just give you a single question దాని తర్వాత I'll extend this question okay let us say I have an object of mass m okay this is the object of mass 10 kg అందరికి right moving with a speed of 5 meter per second what can you say about the momentum of that object చూసుకోండి can you tell me the momentum of this object what is the momentum of this object అందరికి చెప్పండి what is the momentum of this object sir momentum గురించి చెప్పండి అందరికి so if I have the object of mass 10 kg moving with a speed of 5 meter per second what is the momentum very simple very simple చాలా simple ఇదే కదా yes very good tech very good okay very good momentum is 50 kg meter per second అంతే కదా this is a linear momentum are you understanding no I have to go to a house now okay and the distance is somewhere around 1 kilometer so I'll have to go walking and ఈ టైంలో I will also not get in bus right కదా No. I am asking about momentum re baba. Momentum is simply half mass into velocity ide kada. If it is kinetic energy then half mv squared okay. Kinetic energy unte half mv squared. Kani I am asking about momentum. Only momentum. Ade kada. Yes. Appudu cheppandi. The biggest thing is ఎప్పుడు ఐఎమ్ నాట్ అబ్జర్వింగ్ ఇట్ ఫ్రమ్ అ లీనియర్ పర్స్పెక్టివ్ అంటే ఏంటి సార్ యూ జస్ట్ ఇమాజిన్ వన్ థింగ్ ఓకే యూ ఇమాజిన్ వన్ థింగ్ చూసుకో దిస్ ఈజ్ అ పర్సన్ ఐ థింక్ ఐ షుడ్ బి ఏబుల్ టు సక్సెస్ఫుల్లీ ఎక్స్ప్రెస్ వాట్ ఐ వాంట్ టు టెల్ టు యూ ఓకే చూసుకోరా దిస్ ఈజ్ అ పర్సన్ ఓకే అండ్ దెర్ ఈస్ అన్ ఏరోప్లేన్ అంటే తెలుసా ఎస్ ఇట్స్ లాస్ట్ క్వశ్చన్ ఇట్ ఈస్ ద లాస్ట్ క్వశ్చన్ ఎస్ గుడ్ ఇట్ ఈస్ ద లాస్ట్ క్వశ్చన్ దాని తర్వాత విల్ బి గాన్ ఎవ్రీథింగ్ విల్ బి గాన్ రా ఇట్ ఈస్ ద లాస్ట్ క్వశ్చన్ చూసుకోండి సో దిస్ ఈజ్ అ పర్సన్ this is a person standing here చూసుకో అందరికి okay this is a person and this is a helicopter. Helicopter ante aeroplane ra. Aeroplane ante telusa. Do you see the wheels of that aeroplane? Did you see the wheels of the aeroplane? Did you see the wheels of the aeroplane? So this is a wheel of the aeroplane. Andariki. Are you understanding? This is a wheel of the aeroplane. It's very good kada? Yes. Okay? It's a very big, huge wheels. Huge wheels. Ante kada? If it is wheel, why I am not taking wheels ante, I don't want you to misunderstand that this application is only valid for circular objects. Okay? Circular objects. It's not valid for only circular objects. Chusko. When the wheel of the aeroplane is moving, something like this. Chuskoni andariki. Let us see how many of you are understanding what I want to tell you. Okay? Chusko. When the wheel is moving forward, ante enti? Rolling without slipping kada? Yes. So center of mass is having speed v and it is rotating with angular speed omega. Ippudu cheppandi. Now I want you to tell me. This is a person. Okay? This is a person. How will he see this wheel going? How will he see this wheel going? This is a person kada? Yes. How will he see this wheel going? Straight line? Rotation? What? What will he see? What will he see? Andariki cheppandi okasari. Oh, I'm sorry. Velocity isn't squared. Perfect. V squared into r omega whole squared. Sorry, 16 squared into 256. So it is half into 80 into 16 plus 160 into 16. Ide kada? Yes. So you can take 16 common, half into 16 into 180 plus 60 under 240. Perfect. Very good. So 8 into 240. It is approximately equals to 0 to 1920 joules. Go not your perfect answer. 1920. I'm sorry, okay? I'm sorry. There was a little problem from my end. Okay, this case lo cheppandi. Ante, if I say you that the mass of this wheel is m, moving with some speed v, radius is r, angular speed is omega, what will you tell about the momentum now? Ippudu cheppandi. In the last case, when you have a single mass of 5 kg moving with the 10 kg moving with the speed of 5 meter per second, what did you say momentum ra? 50. I agreed, no problem. Can in case lo, what will you say the momentum? Mass times velocity only. What will you say the momentum? Are you understanding? Are you understanding? In case lo, what will you say the momentum? It is not mass times velocity simply. Ante kada? Yes. So when we are saying that this is the object, andariki chudandi. Mass is 10 kgs, speed is 5 meter per second. Ante kada? Yes. So this is the speed, this is the mass. When we say momentum is 50, that is assumed. It is assumed that you are also standing. Leda, you are only talking about the linear motion of this object. Ante entira, you are not concerned if this particle is moving forward. Ante koncham samayam tarvata, you see the distance of this particle from me, okay? Ippudu the distance is only this, okay? Only this. Koncham samayam tarvata, this particle has gone there ra. Ippudu distance cheppandi. Distance is too much. Are you understanding? Okay. That's what I told you, okay? If my answer is wrong, correct me. Okay? You don't blind me also. Ra. Sometimes teachers also make mistakes. Just go. Anyways, when I was here, momentum was 50. No problem, sir. Kani, when the particle was there, distance has changed. Distance changed kada? Ante enti ra? Distance changed ante, can I convert it into rotational motion? You try to understand. What did I say? What did I say about angular momentum? Sorry, total momentum of the system. Cheppandi. mv bar plus r bar cross p bar. Ante it remains valid even for your linear motion objects. Ante if you see the car is going in front of you, that wheel of that car, it has your rotational, ante your angular momentum also and linear momentum also. You understand it. Ante Hey, I should go forward ra. Okay. So in case lo, if I totally have to talk about the momentum of this wheel, it must be linear momentum plus angular momentum I into omega bar. Are you understanding? This is the total momentum of this wheel. Yeah? Right. Right, perfect. No, I'll complete it. Don't worry. By end of January or by the mid of February, your entire syllabus will be completed. I take the guarantee. Okay? Yes. Choose. Similarly, when I say that, okay, I'm just giving you a formula. You remember this formula and the chapter is complete. Choose. Here is a camera. Camera ante telusa? Yes. This is a camera. A camera kosam, there is this mass of 5 kg. Andarki chudandi. Moving with a speed of 10 meter per second. Ante kada? Yes. And. This is the distance. Choose ko andariki. This is my distance. Leda, you can simply say this distance is 20 meter. It is changing as the particle is moving forward. Koncham samayam tarvata, this particle will be here and this distance will be different. Ade kada, distances are different. I am not concerned about the distances. E time low, at this particular distance, the distance is 20 meters and this angle that it is making is 30 degrees. Eppudu naku total momentum of this particle as seen by the camera. I want the total momentum of the particle. Question teeskondi. Find the total momentum of particle as seen by camera. Choose ko. Ide kada? Yes. I am giving you hint ra. Hint teeskondi. Hint ante for camera, the particle moves translational plus rotation. Ide kada? Yes. Translational plus. Sir, what are you talking, sir? Where is rotation happening, ra? Where is rotation happening? Yes, it is happening. You see, if you say this is the axis of rotation, for some time, if it's rotation, then for some time, now you can say it is rotation motion. Ante kada? But for some time ante entira, you understand. For this displacement, okay? For this displacement, all of you, for this displacement, you see, you try to understand. When I zoom it, again when I zoom it too much, can I say that this much of displacement, hey? You understand, there is my axis of rotation, okay? It is gone downwards. That camera. If this particle was here, it has moved here. Can I say that rotation has been performed? Yes. Rotation has been performed. But sir, it is very small rotation. It is chala chinna that it almost looks something like translation motion. Choose kondi. Now tell me, where will you say, sir, rotation is there or not? It is just moved forward, kada. When you see this brown dot, ra, what is it looking to you like? It is just looking to you like a straight line. Are you understanding? It is not even looking to you. So when you see from that camera perspectives, at exactly this moment, this particle is performing both the motions. Both the motions are translation motion kuda and rotation motion also. Are you understanding? So in case lo, if you have to write total momentum, you must say linear plus angular momentum. Choose kondira. So momentum total is equals to linear momentum P bar plus angular momentum L bar. Linear momentum enti sir? Mass into velocity. Ade. What about angular momentum, sir? R bar cross P bar. Hey, R bar cross P bar. Gurtunda? R bar cross P bar ante enti ra? Leda, it is M times V bar plus, do you remember? R bar cross P bar ante perpendicular. R perpendicular into P or R into P perpendicular. Both of them are same. R perpendicular into P or R into P perpendicular. What I am taking, sir? I have this distance. This is my momentum. Okay, choose kora. MV is in this direction. You can extend it and you can take this distance and you can call it as R perpendicular. So if this is 20, this is angle 60, it becomes 20 cos 60 under 10 meters. So this will be our angular momentum. Choose kondi. Mass is 5. speed is 10, this is your linear momentum, okay? Linear momentum అంటే in I cap direction అందరికి చూసుకోండి, this is in my I cap direction, I cap. ఇప్పుడు చెప్పండి r bar cross p bar direction ఏంటిరా? your r bar is in this direction, your p bar is in this direction, r bar cross p bar is into the plane అంటే negative k చెప్పు. Plus sir, what is the value of p sir? P is 50 into r perpendicular is 10 అంటే 500 into minus k cap. This is the total momentum. Combined translation plus rotation. అంటే your total momentum is equals to 50 IE minus 500 k. If you want to talk about magnitude, root of 50 plus 500 whole square. Okay, 50 squared plus 500 squared. So that's it. That was all about today. Okay, thank you so much students. Thank you so much for being here, attending this class. Okay. So with that, we can say the session has been completed. Either doubts unte you can ask me, or else we can terminate this session. Yeah, Gunnar, thank you so much. Good morning, all of you, good morning. It's 3 a.m., almost 2:30 a.m., right? So almost equals to 3 a.m. Okay, perfect. How do you know? Okay, perfect. Okay, take care all of you. How do you know, Gunnar? How do you know? Okay. Bye all of you, bye. Okay, all of you. So now I think we can wind up with this session. Okay, perfect. Okay. Yeah, thank you so much. Thank you so much, all of you. Thank you so much. And please like whoever is there in this conversation, please like the video before leaving. Okay, good night all of you. Good night. So I'll just finish it. Okay?